Αγαπητοί φίλοι, συνεργάτες, αγαπητό κοινό, κυρίες και κύριοι, και φέτος είμαστε έτοιμοι να ξεκινήσουμε αυτό το ενδιαφέρον, όπως εκτιμούμε, πόνημα στο πλαίσιο της διοργάνωσης της επιστημονικής ερευνητικής κοινότητας, η οποία φιλοξενείται ανελιπώς τα τελευταία χρόνια από το περιβάλλον αναφοράς της InfoCom World. Και φέτος έχουμε επιλέξει μία σειρά θεματικών παρουσιάσεων σχετικά με το ρόλο που η τεχνητή νοημοσύνη μπορεί να υλοποιήσει σε ένα σύγχρονο περιβάλλον αναφοράς, όπως λέμε, πέρα από το 5G. Έχουμε επιλέξει διαφορετικές ενότητες που εκτιμούμε ότι θα προσελκύσουν το ενδιαφέρον σας. Επειδή όμως αυτό το live streaming γίνεται και απευθύνεται σε ένα διεθνές κοινό, θα μου επιτρέψετε να συνεχίσω στην αγγλική γλώσσα, καθώς έχουμε αρκετούς ομιλητές από το εξωτερικό και οι συγκεκριμένες παρουσιάσεις αφορούν ευρωπαϊκά προγράμματα, επομένως θέλουμε να έχουμε ευρύτητα αποδοχής από ένα μεγαλύτερο κοινό, χωρίς να σημαίνει ότι υποτιμούμε την ελληνική γλώσσα, την οποία αγαπάμε, χρησιμοποιούμε για τον πλούτο της και τη λεξική ευρύτητά της. Οπότε θα μου επιτρέψετε να συνεχίσω τις αναφορές πλέον στα αγγλικά. So good morning again, ladies and gentlemen, dear colleagues, dear friends. For once again, we are happy to be here in the friendly environment of InfoCom World 2025 conference. For 11th consecutive year, we organize again the scientific and research-oriented workshop aiming to give you flavors from ongoing research projects. This year, the title of our workshop is about facing AI challenges and opportunities in the beyond 5G or towards the 6G era. So we expect to see some options and some related opportunities rising from ongoing EU-funded research projects. In particular, we have, as you will see in my introductory presentation, organized our today's workshop in the scope of 11 sessions, and each one is referred to some specific EU research activity or to a dedicated research project. I will try just to give you the introductory framework for what you intend to see and the basis for our activities. Actually, we are now facing the 5G era, the 5G deployment, almost worldwide, in conjunction with the Internet of Things, artificial intelligence and cloud technologies. It promotes a digital transformation for the benefit of the society and the economy. 5G is offering many opportunities, as we will see, and also proposes numerous innovations, including slicing, edge computing. So this is practically quite beneficial for the market because this promotes many business activities. Just to identify the current status of technology, this slide gives an overview of the 5G infrastructure beneficial opportunities. As you can see, flexibility, lower energy requirements, improved energy efficiency, more capacity, faster access, enhanced security, lower latency and device cost, and many others. However, this is not the final frontier because due to the rising of 5G, we have gradually started facing some challenges regarding energy efficiency, environmental responsibility, challenges in the industrial and agricultural sectors, regarding the efficient adoption of public services and socialization, issues about smart cities and security and privacy. So this, in parallel with the introduction of new services or facilities or innovations like, for example, collaboration or over immersive extended reality, the raising of digital twins, holographic telepresence, the Internet of Senses, autonomous vehicles, merged reality, implicate for something more enhanced beyond the actual 5G era. So we can see in this slide, for example, challenges from the new use cases, the new sort of devices and hardware, new options for networking, implementation, challenges for trust networking, connectivity and mobility, zero touch. So it is necessary to go to something beyond 5G. And this is actually the challenge. This slide just gives an overview of where we actually are. This is the 5G framework following the gradual evolution, the Internet of Things, and we are moving towards the Internet of Everything with many, many new opportunities. If we want to translate the transition from the various generations of mobile and wireless communications, we can see, for example, we are here. We have challenges for enhanced data rate, for enhanced mobility, and for new applications. And here comes the vision for the beyond 5G or the 6G era, where we expect to have, for example, data rates of the order of magnitude of terabytes, very low latency, high mobility in order to save even airplanes and many, many new applications. So we have many, many challenges, and this gives an idea of what is expected to be done based on the current state of the art and taking into account the multiplicity of verticals where we have, for example, new opportunities and new challenges in this very fast developing domain. And this also gives, taking into account the option of having the Internet of Everything, this gives an idea of the expected architecture where we will have everything connected, not only in the framework of the current 5G, but also considering space communications, providing connectivity for everything. And here comes the role of intelligence, of artificial intelligence, which practically in this telecommunications wider framework may be beneficial in several domains. Indicatively, we mentioned the remote virtual reality, augmented reality, mobile computing, of course, the Internet of Things, which is extended to the Internet of Everything, cloud computing, and we have a consequence of benefits that may be offered. And some of the benefits are briefly listed here. It may be about spectral efficiency, energy efficiency, reduction in complexity, enhanced reliability and resilience, and of course about enabling new capabilities, especially in some domains like, for example, joint communications and sensing, which will be the main issue that will be discussed in the first session that will follow. So we face a lot of benefits via the inclusion of AI. In particular, in order to identify or delineate the framework of our entire workshop, we expect that in the next generation, which is assessed as 6G, the whole network will be assessed as a distributed computer. So the implication of artificial intelligence and machine learning implicates for a critical challenge compared to the traditional already existing mobile networks. We expect that we will have future AI incorporation in native AI incorporation in the network. So this will be a feature by the generation and the operation of the network. So AI can be considered as a general purpose technology with many technical capabilities and wider user scopes in various scenarios. So the expansion of AI technologies may be necessary for accelerating the development of the industrial sector and for leading to new industrial transformation in order to have the flavor of these works in the market area. What is essential for AI? It is data, because we have to collect data, then perform analysis and apply results to execute some particular behavior. We need to have computing capability, which provides the fundamental support for the AI industry, and of course, the related algorithms, which is the basis for the proposed AI services. I'm running the presentation in order to give some results, some views about the networking, not only in the area of the services offered. So it can be beneficial, the use of AI combined with machine learning, of course, for network planning, network diagnostics and network optimization and control. For the network planning, this is about encompassing the mechanism for planning and for promoting decisions taken prior to the network deployment. In particular, here we have to make clear the fact that these modern networks are becoming increasingly complex, so the proposed AI techniques can be used in order to take into account limitations or network designs and adopt a perfect solution, aiming to maximize the quality of service criteria for the related environment. For the case of network diagnostics and insights, this is about including mechanisms to obtain insights and will help operators to run the networks in a better way when something happens and we don't have the expected, let's say, behavior or proper functionality of the network. Here we will have techniques to forecast network characteristics in complex events, like, for example, prediction of traffic demands, inferring SLA violations, or improving quality of services. It is also about having high precision user localization in some industrial applications, and also it's about techniques that can be used to forecast security incidents or potential attacks. And finally, regarding network optimization and control, this is about proper mechanism to use AI techniques so that to reconfigure the network at different time scales. Here we have a multiplicity of actions related, for example, to some criteria implied by the radio access network, the NFV infrastructures, the end-to-end network slices, and the network slicing option, security, and many, many more. So this was the introduction leading us to our workshop in the framework of this year's AI Evolution, a Brave New Work InfoCom World Conference. As I mentioned before, our workshop is about facing AI challenges and opportunities in the beyond 5G era. What we have organized here is a total of 11 thematic sessions, including 52 presentations, which practically refer to 18 European projects. We have 9 thematic sessions dedicated to 9 specific European projects. These are the projects, you will see them consecutively. And we try to remain as close as possible to the specific framework of each one of these ongoing projects, but also to correlate our work to real market needs in order to demonstrate that research and development activities have a direct connection to our everyday life. And these are in more details that the various sessions that will be presented today. So I may now give the stage to the preparation of session 1, which is about engineering, combined sensing and telecommunications architectures for tectonic and infrastructure characterization, based essentially on the ongoing ecstatic project. Please, the introductory slide. That's why I said before, giving some instructions. And I would like now to invite to the stage the first presenter, Professor Adonis Bogris from the University of the West Attica. He will present something which is quite innovative and quite new. And I will give the stage to Adonis.
So, I would like to thank you for this kind invitation to be here in this very interesting workshop. Thanks, Yannis, for this really nice opportunity to discuss our ideas and our work on this, I would say, a very hot topic of using different new technologies, not only for communications, but also for sensing. I come from the business, let's say, of optical fiber communications, but now we are in the era where optical fiber communications collaborate with wireless communications in order to deliver the 6G, 5G ecosystems using the fiber infrastructure. So we will start with something which is not so much related, but at the final stages of the slides, I will show you how different things using here can be used also for the access networks and the 5G and 6G ecosystems. So my work, the work of our group, is the work on microwave frequency fiber interferometry in submarine deployed telecommunication cables, and I am from the University of West Attica. So at the last 10 years, there is a very strong interest in using the fiber infrastructures for sensing applications. The main reason is because we have so many fibers in terrestrial, but most importantly in submarine environments where there are no other sensors, no other instruments made by humans to sense and to take data from the environment. For example, if you want to do some sensing in the middle of the ocean, you have to go there with a boat, send an ocean bottom seismometer, leave it there for months, and then have some specialized people to go there and take it back and fetch the data from the machine. But fibers are everywhere. We know that all internet operations and internet applications really proliferate from the fibers that are already deployed everywhere, especially in the submarine environment. So there is a strong interest on using these fibers not only for communications, but also for sensing. And the main idea is to use this infrastructure for monitoring the network in a more sophisticated way, to provide surveillance of critical infrastructure, and of course to provide geophysical monitoring, which can be really very important in the era of climate change. Moreover, fibers in unexplored areas like submarine areas can provide a detailed structure of the Earth, especially on seismogenic submarine faults, which is not the case today. Another thing we have to have in mind is that we are in a period where we have so many conflicts around. So, for example, very recently we had this terrestrial internet cut from Sweden to Finland, and there was a suspicion for sabotage. So there is another reason for having really a monitoring of fibers in order to preserve them and to protect them from, let's say, malicious attacks. So the main approaches we use now, the last 10 years, and there are commercial products already out there, is distributed acoustic sensing, laser interferometry, and of course, polarization-based sensing. Just a few words on all these techniques. The most famous one is distributed acoustic sensing. So what we do, we use a laser. The laser is sent to a fiber. Part of the light is scattered back. So with this back scattering, we can really convert the fiber to an array of scatterers or an array of sensors, and these sensors can provide a very nice, let's say, picture of what happens to the fiber in terms of strain and temperature changes, and this can be provided in spatial resolution which is even below 1 or 2 meters. What is the main, let's say, limitation of this technology? The reach. Since it really relies on scattering, it can only provide a limited reach in the order of 50 kilometers. Now there are products that can reach up to 150 kilometers, but this is the limit, at least now, up to now, and it is a fundamental limit. It has to do only with the engineering issues. The other thing is that it's quite expensive tool. It can cost more than 100,000 euros, dollars. And of course, since it relies on scattering, it's not easily compatible to point to multi-point communication schemes, which are the backbone of the 6G infrastructure. So without having a sensor, an interrogator that can be put, let's say, in an access network which is usually built in this point-to-multi-point infrastructure, it's not easy to use it for monitoring the network close to our 5G, 6G infrastructure. Ultra-stable laser interferometry is a very nice technique. It can provide very high, very long reach, thousands of kilometers, but it relies on very good lasers, spectrally pure lasers, sub-hertz lasers. They are quite expensive, not easily commercially available, so this also increases the cost of the specific scheme. Finally, one of the most, let's say, attractive techniques in the last 5 years is to use the polarization. The reason why polarization is attractive is because it's already measured by the transceivers used in different applications. So each transceiver measures the polarization for communication purposes, and these measurements of polarization can be used also for sensing, because you can sense the changes in the fiber through the changes of the polarization. It's a very good technique. It's practical. The main problem it has, it is quite less sensitive than the techniques using the phase of the signal. So, the last 4 years, we have introduced a new technique. It's microwave frequency fiber interferometer. So, instead of using a spectrally pure laser, we use a spectrally pure microwave signal. They are outside available and they are very cheap. And we superimpose this microwave signal on an optical carrier. So, in this respect, we can have very good carriers in the order of, with very nice phase noise performance, in the order of sub-hertz line width. That means that the carrier has a variation of its frequency which is much below a hertz. And also they are compatible to all transmission techniques we have in mind, so we can co-locate the sensing technique together with the communication infrastructure, enabling the well-known joint communication and sensing paradigm. We can support very long distances. I will show you then later a new experiment that really verifies that. And they rely on off-the-shelf components, so we can really build such a prototype with a very low budget. So we initially did the experiments in OTE, and I would like to thank publicly Ioannis for providing the fiber at that time. And we used this fiber in OTE Academy, which connects OTE building with Afidenes. It's, let's say, a distance of almost 25 kilometers. And at that time, we did all the experimental work with discrete components. I don't want to go through the technical details, just to say only that we used a 10 gigahertz carrier. And then we did all the comparison in the analog domain using a microwave mixer. And at the end of the day, what we managed at that time was to measure some geophysical effects. Before going to that, let me explain quickly how we measure with this technique. We know that the phase experienced by the signal is proportional to its frequency, and we know that in the fiber we have this dependence of the phase on the refractive index of the fiber and also on the length of the fiber. But if the fiber is somehow distorted or deformed by external reasons, both the length and the refractive index will be affected. So both NG and L will be affected. This can be temperature changes, this can be again mechanical vibrations, this can be whatever you can, let's say, perceive as an external perturbation, external stimulus to the fiber. So at the end of the day, we can measure the strain, and the strain is relevant and proportional to the variation of phase in this fiber, and also this variation of phase, as we said before, it is dependent on the refractive index and the length changes. Then, if we use the strain measurement and we use first or second derivative, we can convert it to strain rate and also to rate of strain rate, which are very let's say, well-known parameters for people in seismology. So strain rate is the ground velocity, what is the velocity of the movement of the ground, and also the rate of the strain rate is the ground acceleration. So in the first experiments, which were conducted almost 4 years ago, even more, we had 5 years ago, I would say, we had this, let's say, first demonstration that we can use the technique in order to measure earthquakes. So we had the fiber in this star here, in the center, let's say, of Attica, close to Marousi, and we could detect earthquakes around, across Greece. And earthquakes, at that time, we were quite unlucky because we had these very big earthquakes from Crete. And this big earthquake was one of the let's say, earthquakes we captured with a very high signal. You can see it here. And we captured this earthquake in Athens. So that showed us that the technique can really be a very nice technique for doing geophysical monitoring. Then we compared our technique to a commercially available DAS, because DAS is very well accepted by the community. And we showed that we had more or less a very nice agreement between our technique and DAS, especially if we average out the different measurements of DAS, because DAS, as I told you before, can provide the spatial resolution, so it can really measure per meter what happens to your fiber. Here we average all the signals, we took the average strain, and we saw that we had almost the same signal between DAS and our system, which is called MFFI. Then, after having these very good results, we were quite encouraged, and we decided to do the same measurements in a submarine environment to see if we can measure earthquakes and different effects in a submarine environment. Again, Ioannis really provided the fiber infrastructure in Kefalonia Island, and we see that we connected Kefalonia. We use the fiber that connects Kefalonia with Ithaca, and this fiber is part of it is in a terrestrial environment, part of it is in a submarine environment. So we went there and we installed our system for 2 months, and it was quite very nice to see that we could even measure smaller earthquakes because we had improved the system. So engineering, from the engineering point of view, we had provided better resolution, and we could measure even very small earthquakes in the order of 1.6. These are earthquakes that a human cannot sense. They are very low, but the fiber could sense them. That's very important to know. The other thing is that apart from the seismogenic activity, we could also see all the activity related to the processes in the sea, in the ocean. So we could see, for example, tidal waves. Here you see the periodicity of 12 hours, which is a clear indication that our system detects the tidal waves. And how we detect the tidal waves? The tidal waves change the pressure, and this pressure is let's say, felt by the fiber. The other thing we could see is that we could also see sea waves and their relation to wind speed. And here you can see, for example, the spectrum of our signal and how it increases, it becomes more noisy in a day when the wind is faster and it can provide stronger, let's say, waves in the sea. The final test we did here was to calibrate the system and see if we can use it as a real seismometer, as a system that can really provide, let's say, clear indication not only of an earthquake, but also its position, its epicenter, and its magnitude. So what we did, we used all these earthquakes we collected in Kefalonia, which were more than 75, as I will show you later, and we clustered them in different distances from our epicenter, where epicenter was considered, not epicenter, so the center of the fiber, I mean. So we clustered them, their epicenter as a distance from our central point of the fiber. And what we did, we tried to see if there is correlation between the different distances and the different events. And of course, we saw that there is a clear correlation for the earthquakes which are inside the cluster, and a clear lower correlation with earthquakes outside the cluster. So that is a very easy technique using just mass filtering techniques to identify roughly the epicenter of this fiber. Now we are in the pleasant position to inform you that we have installed the system now with a prototype. Now it's a very small box like a PC case. And this prototype now has been installed in a fiber that connects Ireland to Iceland. This is a very long fiber. It is 1,700 kilometers long. So while we did this installation there, we were invited by some colleagues from Ireland, who are very much worried about the change in the climate in the North Atlantic. If you have heard, it's very it's a hot topic now in the news. We know that the North Atlantic is the only place in Earth that cools down, that the temperature becomes lower than higher. So all the other places experience higher temperatures. The only place in Earth that experiences lower temperatures is North Atlantic, and this has to do with the climate change, and it's very dangerous because if this trend continues, then the climate will become very, I would say, Arctic in Iceland and even in Ireland. So the temperature will go down and they will experience very low temperatures during the winter. So they want to know exactly how these things evolve in the ocean, but there are no measurement systems there, so it's very critical to have some systems to be installed there. So we were invited to use our system, the MFFI, to interrogate this long fiber, the iris fiber, which is a active fiber. It's a fiber that carries traffic, so we used another fiber in the same, let's say, bundle, and we have started collecting the results. Here is some first results showing how we can interrogate different spans in this link. Just imagine that each peak corresponds to a different amplifier in the link. And here is the installation we had. This is our new system, which is put in a box, so it is almost a product. It can be easily provided as a product. Why all these things are interesting for the specific workshop here today? Because what we do here, we use an FPGA, so an edge computing system, you do the pre-processing of the data. We use a server, and the server is connected with 6G in order to transfer this data to a data center, and also we are trying to do some edge processing here in order to reduce the amount of data. That is a very huge amount of data. We have almost 60 giga per day that we collect. So in a month we collect more than 2 terabytes. So we need somehow to compress this data, so we have to think techniques that are really important in doing some edge computing there and some transfer to the cloud, the results that should be processed in a more, I would say, sophisticated system. So the next steps is to perform measurements in the Aegean scene in the context of ecstatic project, together with Ioannis' group, focusing on tsunami seismic activity and storm surge. We are also planning to interrogate a very long link in the Mediterranean which connects Kania to Catania and combine the system with other sensing modalities like polarization sensing. And the most important for this specific workshop, we are now transferring some of the ideas in the access network. How we can interrogate the access network, the fibers in the access network using our technique. The first question is this one, and we have some first ideas. I'm sorry I cannot present them because they are quite in a patenting stage, so we have to protect a little bit the IPR. But just to give you a small, let's say, notion of all these things, since we use microwave carriers, we can use the same carriers for interrogating the fiber, the wireless environment at the same time, because in the wireless domain we use microwave carriers, and so provide a converged wireless and optical sensing infrastructure in 6G ecosystems. This is something we are now working. We have seen the first results. We believe it's very, very promising, and it's very cheap and very low cost compared to other solutions. So it's going to be a system that can really provide, for the first time, a holistic approach for sensing the 6G infrastructure, including the fibers that support it. Thanks a lot for your attention. And of course, to thank our group here, all the people and the ecstatic project for this work. Thanks a lot.
Thank you so much, Adonis, for this very interesting presentation. I was ready to set some questions, but practically your final slide gave me the responses. High dynamism, high opportunities, a lot of options in order to bring the fiber infrastructure close to the 6G era, I suppose.
Yes, and you can have a unified system, unified platform for sensing, not only for communications, this is now reality, but also sensing both fibers and 6G cells or whatever you use there, because you use microwave carriers, which are common in both, let's say, worlds.
Thank you again for your presentation.
Thanks a lot again for the
Thank you.
invitation. Thanks.
We will pass now to presentation number 3. Okay. Once again, I would like to express my thanks to the previous speaker, Adonis Bogris, for his excellent presentation, giving some highlights about how modern fiber infrastructure can be used in order to support sensing network opportunities and give some new ideas in the connected 6G world. My presentation will be a short one about the ecstatic ongoing European project, where we actually apply these new opportunities. Just some information about the ecstatic. As you can see here, it is a project that has practically started since this year. It includes 14 partners from 8 European countries. We have both academic and industrial partners in order to give, let's say, adaptability of the expected results to real market conditions and scenarios. It is a unique opportunity that practically intends to evaluate important fiber optic sensing techniques in real-life telecommunications infrastructure via the integration of high-speed optical communication with distributed sensing and aiming to offer real-time data acquisition, monitoring, and analysis. Just about the vision, which practically complements what Adonis has mentioned in his presentation, and this is actually the challenge and the core idea of the ecstatic project. We take as granted the fact that highways that carry our internet, that is the optical fiber, is now at the verge of a revolution. However, these massive amounts of infrastructure data carried through the fiber infrastructure may be potentially beneficial to help us to realize some issues like those identified here about tracking earthquakes or being able to identify and register even the small ones, detect tsunamis, monitor infrastructure, especially monitor also environmental issues like waves, temperature, and so on, and offer sense changes in the environment, and all this in real time. And practically, this is the core vision of the ecstatic project in our work. Continuing our discussion here, some concerns just to identify where we are standing. As I mentioned before, today's optical networks may be assessed as being pushed to their limits. However, based on some series of innovative solutions, it has been identified, as the speaker said in the previous presentation, that these fiber cables can realize a role of sensitive sensor, and they may be able to pick up vibrations, sounds, and physical disturbances along with their length. So this practically implicates that can act as globe-spanning sensing system. They can offer insights into everything, covering natural disasters to structural wear or tear of bridges, tunnels, and human constructions. And this practically implicates that this vision will set the requirement for rethinking the design of the communication systems from the signal to the hardware we use. This is aligned with the European policy, covering some of the requirements presented in this slide. It is about proposing cloud-based solutions to let the communication network sense while transporting data. It is about enhancing security and resilience of the network, also making network resource very efficient, and the most important, potentially warn and protect against natural disasters like earthquakes via the using of enhanced rates of sensitivity of the developed technologies and via increasing capabilities. Okay. Also important because for the man-made constructions, like, for example, tunnels or bridges where we also have the installation of fibers, this can be used in order to measure stresses and other important parameters. The ongoing research effort of this project is about new types of fiber sensing. In particular, ecstatic aims to improve the way how well fiber optic cables can detect vibrations and acoustic signals. Also, it is about sensing and data side by side. So the challenge here is that we expect to operate alongside with live internet traffic, but without disrupting the ongoing internet traffic. As I said before, this fiber optics is the infrastructure which practically supports our global internet. Small signal processing, implicating for cutting-edge digital signal processing and machine learning technologies in parallel, and real-time insight. The aim is here not only to collect data, but also it is about interpretation of data in real time, so that to offer insights in environmental issues and the health of the network in particular. Okay, continuing our discussion, the objectives of this specific project are listed very briefly here in a continuation of the previous slide. Practically, what we expect to realize is to develop new interferometry, apologies, I lost the slide, and polarization sensing technologies, creating a variety of effective solutions that can serve also a variety of different use cases. In particular, we expect to have new technologies that will be integrated with advanced digital signal processing and machine learning techniques. The project also will produce a system for real-time digital signal acquisition, and the most important is that these developments will be used for real-time applications in the scope of related technologies. Some more specific objectives are listed here. What is important from this slide is the first indication that this initiative practically brings together flavors and aspects from photonics, engineering, telecommunications, geophysics, economics, and innovation management. How? By realizing some technical objectives as mentioned here, but the most important is the way how all these scientific or technological or even business-oriented sections will come together in order to give some beneficial uses and opportunities and products and outcomes and facilities and whatever may be for the benefit of the market. The impacts and the outcomes of the ecstatic project are listed here. First of all, we expect that we will have sensors to monitor the quality of the communication network and methods to be applied for using the network as a large-scale distributed sensor. And the expected impacts, very briefly, are listed here. It's about promotion of an open strategic autonomy aligned with the European research and other European policies, creation of a pathway in order to contribute to digital and emerging technologies for the benefit of the market, being aligned with the Green Deal, environmental issues, as I mentioned before, supporting European open strategic autonomy for innovation, supporting European industrial activities, and in particular, giving opportunities for technological presence in all options of a greener digital supply chain worldwide. And finalizing our presentation here about the role that OT intends to realize in this project, as you will see, we will contribute to the specification of the sensing architecture, and we will define the related requirements. Our main role will be about the support of testing via offering our submarine and terrestrial fiber network infrastructure for the realization of trials. And once we have the results from the trials and the measurement, then we intend to work towards composing a techno-economic analysis where we will support the option of considering this infrastructure as a measure, as a tool for sensing the network in the wider beyond 5G or 6G converged environment, and of course contribution to project management. Okay, I would like to finalize here. This is a project that has started by the beginning of this year, since February. It has a duration of 40 months, as I mentioned before, but we expect that we will have results to demonstrate in the following years in the wider innovative framework presented by Professor Boglis in his previous presentation. So, thank you for your attention. We will now conclude with the first session, and we will pass to session 2, which will be about the Sunrise 6G European project. I would like to invite the first speaker and coordinator of the project, Dr. Kostas Ramandas, to start with a very interesting presentation. Just if Kostas allows me to say that Sunrise is a challenging project, bringing together private and public networks in a federated scheme, proposing quite innovative use cases like federated metaverse, use of robotics in mining environments, and other quite innovative issues supporting the option of AI as a service in the network. So I would like to invite Kostas to start with the first presentation, presentation 5.
Hi all. Thanks a lot to Ioannis for the invitation, and thanks a lot for the active participation of OTE in the Sunrise 6G project. Thank you. I think this is the next presentation, not mine. This is not my presentation.
It's presentation 4, please. P4.
Mine is, I guess, P1. Yes, let's go to the first slide, or I can do it. It's okay, I will start with this one. So, hi all, I am Kostas Ramantas. I am the technical coordinator of the project, representing Quadrat Informatica. So, Sunrise 6G is, as you can see, a big project with a lot of partners, and the project coordinator is Professor Christos Verikoukis, and the project officer is Mr. Pavlos Founogerakis. I am the technical manager of this project. So, Sunrise 6G is a project that addresses federation. Federations means that we gather all the testbeds in Europe that do 6G research, and we federate their infrastructures. Federation is basically done in essentially 3 different pillars. We federate their cloud edge infrastructure so that we can deploy applications on top of them. We federate the experimentation, so we can have a common library of 6G enablers in this federation and expose this to the community. We federate the AI plane, the AI processes of all the testbeds. And then finally, there is an overarching pillar that is a common experimentation plane, which is also the entry point to the project. So the external community, the scientific community, can have access to all the exposed experiments from one common place. So this is the architecture of the project. You can see at the bottom that we have basically 14 testbeds, and those are coming from previous initiatives of the 6G SNS program. Most are coming from the so-called Stream C program, which is about building testbeds. Some are coming from other Stream B programs, which are developing some more innovative and breakthrough enablers, and those are brought into Sunrise. And then we have the SLICE SRI, which is a European initiative for experimentation. On top of these testbeds, we implement a set of frameworks, and those frameworks achieve, as mentioned, the federation of vertical deployment, the federation of AI, and the federation of experimentation processes. So in my presentation, we will go over all these pillars one by one, and I will try to explain what we have achieved so far. So let's start with the first pillar. The first pillar is the federation of the verticals. So our goal here is to be able to deploy vertical applications on top of these infrastructures. So we start from some common APIs, and those APIs allow us to deploy the vertical anywhere, in any testbed, without basically caring about the precise platforms or cloud platforms or edge platforms that the testbeds have deployed. We have some common APIs, those are called Camara, to deploy these applications, these verticals. And also we have some common APIs to interface with a network. So we can have some network programmability, which is unified. So an application can interface with the network without, again, having to deal with different APIs and incompatibilities. So here you can see the design of this federation solution, which is following the GSMA operator platform standards. So we are not implementing something which is, let's say, unique. We are following some industry standards, some industry practices, and some standardized interfaces. So what we build here can also be used by the industry. Also, the operator platform that the project has implemented is open source and has been accepted as an ETSI software development group. So this allows also the community to participate in the implementation of our APIs or interfaces, and also the Open SDK. SDK is a set of transformation functions or plugins. So essentially we can support any type of southbound platform. If you want us to support your core network solution or your edge cloud platform, you just need to implement a small plugin, and this will be supported through the common Camara service APIs. Then let's go over the second pillar. This is about the exposure of this 6G library of components. So the idea here is to gather all the 6G research that is happening also in the framework of other projects, to gather enablers in the form of devices, in the form of algorithms, in the form of cloud continuum, and expose them to the community, and so the community can perform some tests. So our strategy was to bring some existing enablers from other projects. So you can see here that we have a library from 9 enablers coming from previous initiatives. And also the project implements some new enablers that you can see on the right-hand side. And these enablers are for joint communication and sensing, some near-field risk components, some zero-touch automation, non-terrestrial networking, and Open RAN enablers. Those were missing from the previous initiative, so those are implemented in Sunrise 6G. And here you can see that we have already implemented the first version of all these enablers. We have started performing tests, and we have already started exposing these enablers to the community. The examples here show a RIS on the bottom, on the top left corner. So we have an actual RIS in the project that is developed and tested with an actual end-to-end 5G stack through Open RAN. We have self-free massive MIMO, we have non-terrestrial networking, and all those have been delivered from the project and have already undergone the first phase of testing. The third pillar, as mentioned, is about the federation of AI. So, how do we federate AI? AI is a lot of things. AI is the infrastructures, AI is the models, AI is the processes or workflows that people leverage to train these models. So, we try a little bit of both. So, first, we try to federate the models. So we have a common so-called model registry. We have a common registry of all the models used in all the testbeds, and there we also try to have some complementarities. So testbeds that have some similar enablers, for example, RIS, can basically reuse the same models to control them. So we can have some exchange of know-how in terms of AI. Then we also implement some common model pipelines, so we can start from some existing models, and those models can be fine-tuned from one testbed to the other. So when, for example, one testbed uses an AI model to do some time series prediction for some signals, then you can try the same model on another testbed to do time series prediction on a slightly different setup. And then you can do maybe some fine-tuning and see how well my model performs on your testbed. And then finally, as mentioned, a third approach to AI federation is federating the infrastructure. So there we can have some testbeds that can also share their infrastructure, and others can use their GPUs to deploy their models. This is the so-called GPU as a service model. Finally, the last pillar of the project is about the experimentation plane. So, as mentioned, it's very important to provide to the community an entry point, so people can easily interact with your project. They can log into our portal. Directly, they have access to all the testbeds that are involved, all 14 of them, and they can have access to their experiments. So they can just click, for example, at the Siemens testbed, and they can perform their own tests, and they can interface, for example, with non-terrestrial networks solution of Siemens. The same they can do for the OTE testbed. OTE also exposes, in collaboration with Democritus, a non-terrestrial network enabler. So you can play with it, you can change some parameters of the traffic generator and see how the traffic is split between the terrestrial and the non-terrestrial domain, and see what kind of trade-offs you might have and what kind of different scheduling algorithms you can use and how they affect performance. So essentially, this portal is a glimpse into the European 6G research, because this way you can have a view of what the various teams are doing, and you can directly play and interact with their components. This is very important. We also have an experimental chatbot component. So we're trying to build a system where you can also trigger these experiments with a chatbot, with a text interface. As you know, this is something that is taken almost for granted these days, that you can interface with complex systems through some chat interfaces, and this really simplifies things. Finally, let me mention that one of our main objectives in the project was to really simplify the process of onboarding testbeds. So it's very simple to actually onboard, to add some new testbeds. We have done this in the context of a hackathon that we organized in Athens a couple of weeks ago, and we are able to add 5 new testbeds in only one day. So we really have plans to extend this federation. Here you can see how the tests are exposed through the portal. And here, for example, indeed you can see a demo exposed from the OTE platform. And here you can see some vertical use cases where we plan to validate the solution and its enablers. And for example, also, as Ioannis mentioned, we're going to have a federated metaverse use case where we will test our Open Federation platform, and we will deploy this Open Federation platform to deploy a metaverse vertical. So we will have a common metaverse solution where we will have two rooms, one at KUL and one at I2CAT, and those will be federated with our system. We will have a collaborative robotics mining use case where we will deploy the RIS solution and also the end-to-end AI solution at Luleå. They have an actual mining site over there, and there we will have support from Intracom, which is offering the end-to-end AI solution. And finally, the federated non-terrestrial network solution, where we have the involvement of OTE, and there we will showcase all these innovative multi-connectivity and PLM and handover scenarios, where OTE is offering their testbed and is collaborating with Democritos. And finally, all the other solutions that I have showed you will be validated via 12 functional test cases and also some additional ones that we bring through hackathons. So that's it, and thank you for your kind attention and for the invitation.
Thank you so much, Kostas, for this very interesting presentation, giving the framework and the layout of the project and allowing to pass to the next speakers. I would like now to thank you again. I would like now to invite Dr. Vasilis Theodorou from Intracom to come to the stage and give the next presentation about open source operator platform, enabling operator network and testbed federation. It's presentation 5, please. P5. Thank you, Vasilis.
Thank you for the introduction. Hi, everyone. I'm Vasilis Theodorou. I'm the Head of Research Collaboration at Intracom Telecom, and I will present to you a quite new initiative called the Open Operator Platform, which is an ETSI-hosted software development group that was initiated and born within the Sunrise 6G project. So a little bit of background story. The idea behind OpenOP was conceived by a well-balanced group between academia and industry and research. We were a team of individuals working and formulating the core of several 6G EU projects from the SNSJ EU program. And in particular, in Project Sunrise 6G, we had the goal of unifying somehow 14 beyond 5G and 6G testbeds and offering a single point of entry so that experimenters that are willing to test their vertical applications with 6G telco services could have, a unified single platform through which they could interact with several different testbeds in a unified way. And that's where the main vision behind Open Operator Platform was born. We looked up a lot about existing work and related work, and we saw that there were several communities, both from standards and from industry-driven groups that were already working on this direction. So we naturally came across GSMA, Open Operator Platform Group, as well as a very interesting open source initiative, the Camara APIs from Linux Foundation. And so, we thought that this idea could accelerate innovation and maximize impact by being incorporated in a very prestigious organization like ETSI. And the idea was to create a vertical app-oriented environment where many different stakeholders, developers, practitioners, researchers could drive together the next generation of telco platforms. So that was the idea behind Operator Platform, which is a unified federated framework for operators, developers, and service providers with two main functionalities. On the north-southbound direction, the idea is to abstract the telco and southbound technologies into a homogeneous and unified interface where vertical developers can interact in an abstract manner and to use an API-based interaction similar to the one that users, application providers have been used to from cloud computing services. On the east-west bound direction, operator platform actually follows standards, follows the GSMA OPG requirements for east-west bound federation of different administrative domains and different operator platforms. At the same time, AI and machine learning is a very important dimension for our approach, both for observability and abstraction of ML models and MLOps processes, as well as the exchange and sharing of AI services and assets, like data for training the models. But at the same time, for the intent-driven operation and management of the southbound technological domains, whereby users can even express their intents in natural language, and this can be automatically translated to southbound technology-specific API calls and primitives, and in essence, lifecycle management automation of different services. So we are formulating an ecosystem which is growing very fast. We started with 8 founding members, and we are currently more than 20, I think 22 members and participants in this initiative. And we are willing to leverage and complement existing initiatives like ETSI, software development groups, or industry specification groups. At the same time, to not reinvent the wheel, but collaborate with key industry players, with open source communities like from Linux Foundation or Eclipse, with SDOs like 3GPP, with which we plan to be compliant on the southbound, and also to create important synergies with research and innovation 6G projects, as we have already done. So we have established not only strong links with Sunrise 6G, which is the project where this initiative was born, and provided also the seed code for the first release that took place past September. But also, with important projects like the 6G DALI, which is the flagship AI data project of SNSTU, 6G Intense, Flecon 6G, Adroit 6G. So our objective for this year, for next year actually, for 2026, is to deploy our platform on as many 6G projects as possible, and on one direction to help by covering the needs of telco cloud management. So we want our platform to be, let's say, the de facto platform for telco cloud management within the research community. On the opposite direction, we want to receive very impactful and interesting feedback so that we can complete our services and features, and make sure that what we are creating has value and is useful and interesting for many different communities. So we just kicked off in July, but there has been a lot of traction since then. We already have big operators in our group. So we have OTE, we have Orange, also BT, Altis, and PT Portugal, and we are an ecosystem that is continuously expanding. I will not say too many details here. I will just say that our next steps is to make our platform more rigid and to make it super usable. So what we are targeting is to use AI technologies like agentic systems and MCP technologies to make our platform flexible, integratable, and usable, so that we can have the end users even express what they want in natural language, and we automate all the translation through the platform internal transformation functions. At the same time, we are heading towards vertical integration. We have in mind several impactful sectors like healthcare, automotive, media and industry. We're very happy and quite pleasantly surprised to see that there are many interesting research directions within all those verticals that converge with what we're planning to build here. And as I said, we plan to have the adoption of our platform by wider communities, not only research, where will be our main critical mass, let's say, but also targeting SMEs and offering an easy entry point for them to also be involved in the beyond 5G and 6G marketplace or ecosystem, which is expected to be more diverse with many different players than the traditional ones. So yeah, just a snapshot of AI use and vision within our platform and through our platform. One idea is that users can express in natural language what they want, like optimize video streaming for X users or for X type of users. This is essentially an intent, a high-level intent, and through our AI agentic system, that is already a module being built and will be released early next year, the translation to Camara APIs and to workflows that will enact and instantiate telco cloud services is all automatically done through our OpenOP. Another interesting direction is the abstraction of AI assets. We're talking here about AI models, AI data sets, and we want them to be exchangeable, shareable, transferable in a secure and sovereign way and traceable way, even across different telco clouds, even from different operators. Okay, and throughout all this process, we want the end user, which is the vertical user, the actual consumer of those AI services, to have a unified observation over all these assets and operations and workflow processes. And we want them to be able to express what they want from these models. Just to give you some heads up, we are preparing a demo. It is actually being presented today in an event organized by different ETSI SDGs. And we have the user expressing something like, I want to identify an AI model from the testbed of Telefonica, which is pre-trained to identify anomalies on ORAN testbeds. And I want this model to be fine-tuned on the premises of OTE. And I want it to be deployed and to conduct inference and anomaly detection for the data sets that are custom for the OTE testbed. The user can just express this in a natural language, and then all the process takes place securely, in a sovereign way, in a traceable way, using standards and technologies like data spaces. And, like magic, everything takes place even across different federations of testbeds. So, thank you very much.
Thank you so much, Vasilis, for this presentation. Before passing to the next speaker, I was ready to ask you a question about the extendability and the applicability of the platform relating to potential other ongoing European projects, but you already gave the reply. You work together with some projects like Flycon 6G, 6G DALI. So the expectation is to take into account also options coming from these projects to the extent possible, of course, and have the possibility to cover rising requirements from these projects as well, I suppose.
That's exactly the case, Yannis. So we are very fortunate and lucky that this interaction with all different 6G research projects takes place, I would say, organically, because the main core team that is involved in OpenOP is also a core team in many different projects, including yourself. In 6G DALI, for instance, I have the honor to be the technical manager, and many of the AI-driven innovations that I presented today are going to come and be contributed from that project. We have other projects that are very closely related to the people who are formulating actually this initiative. And, the idea is that we want to have established a bi-directional link, not only to, force people to use our platform. That's not our intention. We want our platform to be useful and to provide actual value and benefit and to cover architectural blocks that are being provisioned for next generation architectures, but we see that they are common and homogeneous across many different projects. And on the other side, we want to listen to the requirements that are coming from the different projects. We want people to actually tell us what we're missing or what would be nice to have or would be useful for them. And it's an open source project, so everybody is invited to collaborate, to join our efforts, and to contribute not only with their own scope, but also in a more extended scope.
Okay, thank you again. We will pass now to the next speaker, presentation number 6, and I would like to invite Dr. Paulito Palmes from IBM Research Ireland. He will present conversational machine learning operations, and we will have now his present via remote access. So please give the stage to Dr. Palmes. We don't have him connected. If not, we will pass to the next speaker. If he is not connected, then the next speaker is from Demokritos, Dr. George Makropoulos, who is present. Thank you for joining physically. And we will see if the previous speaker will join later.
So good morning. Thanks for having me. So today with my presentation, I will present one of the enablers that were mentioned, previously mentioned. Kostas made a mention about the overall concept of Sunrise and the 6G library that introduces enablers coming from previous projects, but also new enablers with innovative features. So with my presentation, I will focus on a specific enabler regarding the multi-rate dual connectivity, which integrates terrestrial and non-terrestrial networks. As I said, this is part of Sunrise 6G library. We focus on Pillar 2. And here you can see a high-level architecture of how the enabler is placed among the, the different blocks of the Sunrise ecosystem. So you can see that we have the physical infrastructure, the physical layer, hardware, antennas, any type of components. This enabler sits on top, and we are referring to the Athens 6G testbed. It is connected on the left-hand side with some components in order, to orchestrate the experiment, to store the data, and to monitor the processes. And on top of that, we have the APIs that are exposed from the enabler to the experimentation service of the Sunrise 6G project. And from this API, experimenters have the option to interact through the portal, to run an experiment and, to monitor the process and retrieve some fruitful results. Moving a step forward, here you can see a more detailed view of the specific enabler. You can see the architecture here. So, as I mentioned, we are trying to integrate terrestrial and non-terrestrial networks. So the lower path defines the 5G path, and the upper path is the NTN link. For the 5G path, we are using actual components and hardware coming from the testbed. And for the satellite link, we are utilizing a specific emulator. For this initial version of the enabler, we are using the MPTCP protocol. So we need a client and a server in order to generate and receive the traffic. We have a scheduler that is, the brain of the overall setup. And actually the brain of the MPTCP in order to split the traffic across the two paths. And on top of that, we have the experimentation scheduler, which is the brain of the system. And the responsibility of the scheduler is to organize the full process and also to retrieve the results upon the execution of the experiment. These results are then forwarded to the experimentation API, and through the adaptation framework, the user has the option to see the results in the portal. Now moving a step forward, you can see here the actual setup, the actual components that have been used in order to utilize this enabler. So for the terrestrial part, we are using a callbox, which integrates both the 5G part, the radio part, and also the different functions of the 5G as well as the UPF. For the non-terrestrial part, we have a satellite emulator. It consists of 3 dedicated VMs that represent the satellite, the terminal, and the gateway. And these machines, these instances are deployed in the infrastructure of Athens 6G testbed. For the MPTCP block, which is actually the protocol that we are utilizing in this first version, this is, let's say, a kernel-based solution. It's pretty flexible and easy to implement it. And for the 5G, the UE, we are using a physical UE, an actual UE, with a specific module in order to have the option to connect to the 5G through a dedicated SIM for Amari. And here we can see how the experiment looks when someone enters the portal of the Sunrise 6G project. So you can see on the upper left part that you have the option to select a specific testbed that the experiment is running. Then you can select the functional test. This is something that was also previously shown in the initial presentation. So you have the option to select the test that reflects the aforementioned setup. And on the right-hand side, you can see some indicative results. Upon the execution of the experiment, you can see how the traffic is split between the NTN and the TN part, and some measurements about the throughput and the jitter. Apart from that, I mean, apart from the experimentations coming from the portal per se, we have some experiments, additional experiments, in order, to have a full view of the enabler and, utilize different functionalities. So we have done some extra experiments in order to evaluate the uplink throughput, and we did this by varying the network conditions. So we are splitting the traffic dynamically across 3 specific modes. So we have, let's say, the 5G as a prior link, then we have the satellite as a prior link, and then we try to do a balanced traffic between the 2 paths in order to retrieve the results. Through the emulator, we have the option to select among different modes. So in this case, we tested LEO and GEO satellite types. And we also have the option to adjust and modify TCP window, the window size of TCP. And we try to see how they affect the overall throughput and the delay. And on the bottom side of the figure, you can see the 3 different experiments that have been performed. Some indicative results here. I will not focus a lot on this. It was recently published in a paper in IEEE NFVSDN, so you will have the option to read the whole work. So here you can see some indicative results. What we identified that, for example, in bullet 2, even though we were increasing the TCP window, the throughput had a tend to decrease, which is something that we need to identify and try to to modify a bit, and we also identified that there was a throughput variability in the scenarios that were having LEO and the 5G priority, and this is potentially coming from instability due to high peak data rates. In parallel now, previously the work that I described was coming from the Athens 6G testbed. In parallel now, the enabler is also being tested and utilized in another testbed. This is the testbed in Siemens. So Siemens is trying to do a similar setup, I mean using moreover the same approach. However, their setup is, let's say, fully softwareized. So they are using Open5GS as the 5G core. They are using UE and SIM in order to have both the RAN and the UEs. And for the terrestrial part, they are utilizing an in-house development. They have a dedicated emulator in order to do that provides end-to-end capabilities. And along with this setup, they have also performed some experiments in order to see the functionality of their setup. So there are some baseline experiments that initially are running with legacy TCP. They are using either the 5G path or the satellite path. And then they are using the multipath TCP in order to highlight the gains. And you can see some indicative results as well here. So in the left side, we have the 5G with legacy TCP. Then we have the NTN. We can see a lot of fluctuations in the traffic. And the third figure represents the introduction of MPTCP, where we can see that in the application layer, there are a lot of fluctuations that might cause issues. And additionally, we can see here how using the MPTCP as a backhaul link provides benefits, because in the first figure, you can see that we have a connection, interruption in the connection. But on the other hand, on the second figure, you can see that introducing the MPTCP as a backup, we avoiding the interruption of the connection. Now, since we have this baseline, setup, we have done some preliminary experiments. Now the idea is to shift our work in order to explore different protocols that could fit in this setup. So the idea is to test MP-Quick protocol as well. We will also test the different schedulers in order to see the gains and the drawbacks. And we will also apply AI logic potentially in the scheduler part in order to leverage how the scheduler works. And as soon as this enabler is fully ready, the idea is to test it in specific use cases along with OTE, since we are sharing the testbed and the resources. So we have two specific use cases. The one is a dual connectivity use case, more or less the setup that I have shown. However, it will be deployed in between OTE and Dimokritos. And a very interesting use case that will target inter-PLMN handover. So one path will be the 5G and the second path will be the terrestrial. So we will try to identify the benefits of having this multi-rat dual connectivity enabler. And that's it from my side. Thank you for your time.
Thank you, Dr. Makropoulos, for this presentation. By my side, just a general question, although I suppose you already have the answers, about the collected results from the trials. I suppose these are translated somehow to some KPIs normally in the project, and then these may be used as a means for assessing the progress.
That's fully correct. I mean, along with experiments, we have identified some preliminary KPIs that are of interest and will showcase the benefit of having this enabler. potentially, while running the actual experiment, I mean in the use cases, which are a more large-scale setup, we will come up with additional KPIs, as I said, to show the benefit of having the multi-RAD dual connectivity.
Okay, thank you so much.
Thank you.
Now we'd like to ask for the support of our technical team. Some of our colleagues who intend to join virtually. We passed the previous speaker, Dr. Paulito Palmes. If he is here, we can have him directly online.
Yeah, I'm here.
Yeah, okay.
Hello?
Dr. Palmes, you can start your presentation if you want.
Okay. Let me share my screen. So I'm Paulito Palmes from IBM. This work is in collaboration with ISI Athena, who provided us with a Kubernetes cluster where we deploy our MLOps. So the title of my presentation is Conversational MLOps, where we integrate a combination of MLOps workflow with chatbot. So first, here's the outline. So I'm going to discuss about the motivation of this work, together with what are the different kinds of LLM agents we are using, and then the MLOps workflow that we are deploying, and then some example of the LLM agent summarization and the future work in progress. So first, for the motivation is that we use the AutoML as the paradigm for automating the machine learning application, and it can be used for classification, regression, and anomaly detection. And AutoML is very already provides a good automation because it can find the proper the optimal pipeline and to search the appropriate hyperparameters. But this requires a lot of computational power to get the optimal pipeline. So if you combine AutoML with the MLOps, we can call it AutoMLOps because we can automate the process of finding the optimal pipeline, but we're gonna use and leverage the power of Kubernetes to scale up so that we can do a lot of parallel search to search the optimal pipelines among the choices of the different pipelines and their hyperparameters. So in order to do that, we have to take into consideration what kind of Kubernetes components we're gonna use. So we use Argo Workflow for the workflow orchestration. We use MLflow to track the experiment. We use the menu object store to store the artifacts in the models. And we use the LLM agents as an interface so that you will have minimal coding. So the project of Sunrise 60, one of the major objectives is sustainable. So you want to have this interface where the user doesn't have to install anything. All he has to do is to have a browser and go to do the chatbot integration or talk to the chatbot or go to the Argo workflow website and submit a workflow. And that's it. You don't have to do anything. You just upload your data and so on. So here's the LLM agent. So we have an agent for deployment. We have an agent for monitoring the deployment, and we have an agent for summarization to get the insights of the results of the AutoML pipeline. So we have two kinds of major framework where you have an LLM agent where you have an orchestrator that does the planning, and you have based on the number of tasks, it will create dynamically the sub-agents, and then the result of the sub-agents are aggregated by the report writer and then submitted as final report. And there's another use case where if you want a much better result, we also include an LLM as a judge. So after the report writer finishes his report, the agent here finds out whether the query matches the result. If it is not enough, it will go back to the orchestrator to create more sub-agents to get more results so that it will be satisfied. Once it is satisfied, it will go to the final report. So here's the typical workflow. So the chatbot, the user will talk to the chatbot for deployment or for summarization or for analysis, and then the chatbot will use the Argo workflow to deploy certain kind of workflow. It will get the data from the Minju object store, and then it will be tracked by the ML flow, and then the final model will be stored in the Minju object store for future inference. So here's the example lags of the results. So these are the pipelines that are being explored, and these are, for example, the anomaly detection points that were detected if you're using anomaly detection routine. And then here's the summarization of the LMA agent. It tells you which of the pipeline is the best with their accuracy and then their performance, as well as it tells you the deployment also, whether what happens during the deployment. So here's a quick real-time example. So here's the Argo workflow. Here's the lags where you have a parallel workers that looks for the best pipeline, and here's the ML flow that stores what are the pipelines that are being used and what is the best pipeline. And then you have the artifacts where the model is being stored, and then this is the Minju object store where the user can upload its data, and the Argo workflow will access it for inferencing. And this is the example of the Argo of the LLM agents. We're using Claude and Quinn for the agents. And then here's an example of how the orchestrator creates these sub-agents. And here's an example of the summarization where it tells you the deployment, it tells you the result of the deployment, and it tells you the best result and gives you the insights which of the components are the best to use for these data sets. And that's it. So I think from this, I will end my presentation. And for the future, we are thinking of using more MCP because I'm using LLM agent with multi-model context protocol that allows the agent to access certain kind of tool sets like Kubernetes cluster, databases, the Grafana dashboard, and so on, to monitor and to deploy applications. And thank you very much for listening.
Thank you very much for your presentation. I feel that even for the non-expert, the message is quite clear that there is high dynamism and a lot of further results are expected to contribute to the scope of the project. Thank you again for joining. And I would like now to invite the next speaker, Dr. César Cajas Para from Fundación Privada Itucat. He will present his lecture about Open SDK for the Federation Framework. So, Dr. Para, please.
Thank you. Thank you so much. Good morning, everyone. So I'm going to proceed to share my screen. Okay. So I'm pretty sure you can see my screen now. Let me go to the beginning. Okay, so this is César Cajas. I'm from Itucat. I'm from Barcelona, and I'm going to introduce to you the Open SDK for the Federation Framework. So, as you know, in 6G and in the telco world in general, well, we require interoperable and federated experimental infrastructures. And the problem is that the current testbeds are heterogeneous and fragmented. So we need the integration across domain, and this integration is already complex and is not standardized. So the SDK, the software development kit, it aims to simplify this federation and enable the standardized APIs. So as objectives that we have the unification access to heterogeneous testbeds via standards API, such as Camara standards or GSMA RPG specifications. And for this, we are using transformation functions for different domains that could be the edge, the network, and ORAN domains. And with this, we are enabling cross-domain onboarding, deployment, and exposure. So we have here the framework of the project Sunrise 6G, the architecture of the operator platform, and to extend it a little bit more, and we can see better, in the left side we have the originating operator platform, and the right side we can see as it is the partners operator platform. So for any application provider, if we have an inter-domain deployment, the workflow it would be to access the camera APIs and go to the resource manager, which is going to consume the library that is the OpenSDK. And this library, this plugin, is going to perform the transformation functions for the different underlying infrastructure. So here we are abstracting actually all of this complexity into the, for example, the ORAN transformation function network or edge cloud domains as well. So in the other side, we have the federation scenario, which is the interconnection between two operator platforms, and the workflow would be to send first to the federation manager the request to first federate to other platform, and then through the east-west bound interface GSMA OPJ specification to communicate to the partner OP, and here the OpenSDK will perform this transformation function between the GSMA format into the underlying infrastructure, and in this case is the edge cloud platform. So here we can see a little bit better the workflows that I was talking about. First of all, in the edge cloud domain, in the left side we have the Camara workflow, and in the right side we have the GSMA workflow in this case. So we are supporting Camara Edge Application Management API. We support GSMA East-West Bound Interface Federation Manager, and we enable application onboarding, instance lifecycle, and zone discovery. And we are integrating all of this to the different technologies right now, such as I2H, Aeros, and Kubernetes. For the network transformation functions, we support Camara QoD, location retrieval, and traffic influence APIs. We abstract the 3GPP and F APIs across Open5Gs, OAI, and Open5G Core. We enable QoS session management, traffic steering, and location retrieval, and provide unified developer experience across network vendors. And in the case of the ORAN transformation functions, we have an unified ORAN adapter. We we have basic lifecycle management for X apps and R apps. We have a read discovery and vendor agnostic operations. So for the use cases, we have that we can have multi-operator edge cloud federation. We support QoS and QoD management across operator-like environments. We have edge computing for low latency applications, context-aware service provision and via location APIs, and traffic influence for optimized routing. So what are we covering in the OpenSDK? In the edge cloud domain, as I was saying before, we have the Camara and GSMA support for the different technologies that we are adapting in this plugin, such as I2H, Aeros, and Kubernetes. For the network domain, we have full QoD, partial location retrieval, and all of this is supported across Open5Gs, OAI, and Open5G Core. And in ORAN domain, we have full QoD policy control and basic XApp, RApp lifecycle support. All of this is in a structure in a modular way, so it's easily for developers to extend all of these modules. And in terms of validation, we have different ways to validate all of this metadata, all of this information that is coming from the Camara and GSMA APIs. We have different tests that and schemas to validate all of this information. We have proven the interoperability across multiple testbeds And as I was saying, we have the modular and extensible design, so it's easy for the community to contribute to this, and is a way of very easily integration for developers as well in their platforms. So as a conclusion, we can say that the OpenSDK breaches the standards nowadays. It simplifies the application deployment, it promotes the innovation for 6G, and as a future work, we could refactor some of these components of the OpenSDK to better align to the infrastructure of the Open Operator Platform, architecture and functionality. So thank you so much for your time.
Thank you so much. Thank you so much for your presentation, which quite detailed and gave us important feature of the ongoing effort in the framework of the Sunrise 6G project. My question is only about the expected applicability of the solution as a whole. It appears that it will give many benefits in the scope of the Sunrise 6G project, but personally, from what I heard, I also feel that the use of the solution can also be applied as well, potentially.
Yeah, the solution is for now under the scope of Sunrise 6G, which we have included different technologies in order to provide this example of the functionality of this plugging into the Open Operator Platform framework. And for sure, it could be applied as well in different other technologies for other partners that could use easily this kind of modules and developments. So yeah, that's actually one of the main objectives of this.
Thank you so much, and thank you for joining our Sunrise 6G session and presenting these very interesting aspects. Thank you again.
Thank you so much.
Okay, we can pass now to the next session, which is session number 3, actually. It is based on the framework of the Flecon 6G project, which is about flexible open architecture and AI-driven enabling technologies for a novel 6G connectivity platform. Before giving the stage to the first speaker, I would like to say that this is also a new project which collects information and participants from, it is in the framework of the SNS JU, Smart Network and Services Joint Undertaking, promoted by the European Commission. And so this is quite interesting because the aim is here to apply and make real the vision of intelligent 6G network of networks with trustworthiness of native AI and network digital twins assisted approaches, as we will hear about. It is a project that promotes some proof of concepts based on security, trustworthiness, resilience, and reliability across several heterogeneous verticals. And for me, as far as I'm concerned, it is also important the relationship of this very interesting research initiative to ongoing standardization efforts with contributions expected and gradually realized to 3GPP, ITU, ETSI, Open RAN, etc. But I feel that the involved speakers will give more detailed information, and I would like to invite Professor Christos Verikoukis from the Industrial Systems Institute Athena Research Center, also representing the University of Patras and project coordinator of Flecon 6G, to join the stage virtually. So, Professor Verikoukis, the stage is yours, and thank you for joining us in this workshop and for your support in order to organize this session and have a view on the progress of the Flecon 6G project.
Thanks a lot, Yanni. Good morning to everyone. Thanks for the invitation. Let me share my screen. No. Sorry, I have an issue now. Give me 1 minute. Okay, can you see my screen?
Yes, perfectly.
Yeah, let me put it in presentation mode.
Okay, Christos, perfect. Go on.
Okay. Again, thanks a lot for the invitation. It's my third year with InfoCom and the workshops organized by Otik and Yannis. This is the project overview. I'll have a general information about the project, the consortium, the objectives, the innovations, the architecture, and finally the proof of concepts and the standardization plans. As you can see, it's a SNSGU project. We address the call of 2024 in the stream B0101 about architecture, system architecture, standardization, and follow-up POCs. Theodora Tsapkouni and myself serve as the project co-coordinators, and Adlik Sentini, Professor Adlik Sentini from Eurecom is the is the technical manager of the project. We have 19 partners from 10 EU member states, 5 RTOs, Tier 1 research centers and universities, 8 large companies, 3 operators, 3 big European operators among them, and big vendors like Siemens, Ericsson, and NVIDIA, and 6 high-tech SMEs in Europe. The main objective of the project is to deliver a novel 6G blueprint reference architecture that driven by distributed, modular, open collaborative, trustworthy frameworks, and we provide multi-layer network digital twins. The core vision of the FLECO 6G is an intelligent 6G network of networks architecture that offer native and trustworthy AI integration for automated scalable composition of service and capabilities offered by individual networks, subsystem, and technological domains. This is the main concept. You can see how here the native AI is integrated with LLMs and trustworthy AI, and how this is interconnected with the infrastructure and the different business and stakeholders around this architecture. The technical objectives is the design and implementation of a disruptive architecture for 6G networks that covers public, non-public, terrestrial, and non-terrestrial domains, to develop native and trustworthy AI algorithms for intent-driven multi-stakeholder networks, to develop a new approach of smart marketplace in order to support sharing and exposure of resources between the network digital twins and the AI models, to develop a multi-layer network digital twinning framework and integrate with this framework zero-touch operations, to propose innovative data transfer paradigms considering enhanced data plane techniques, implement a collaborative and distributed framework for recursive modeling, coordination, dynamic decomposition, and operation of multi-domain 6G networks, and finally integrate all these ideas in proof of concepts, new use cases supported from 6G networks. The main innovations of this project is to accelerate an accelerated programmable edge computing, solutions for AI native integration via foundation models, recursive and collaborative composition and federation of 6G network of networks, trustworthy AI solutions for 6G networks, intent-driven marketplace in order to exposure vertical to the verticals to the architecture, to design and implement this network digital twin framework in all layers, and to design a multi-layer and multi-domain network digital twin to assist the network orchestration. As you can see here, this is our conceptual architecture. We have here the marketplace on top of everything, where it gives access to the vertical owners to the network, the 6G intelligent layers, where we have all these entities and AI, then the network of networks framework, and between all these, between this architecture and the infrastructure, the accelerated programmable data plane. This is the work package structure, typical for such a kind of innovative projects. We have a work package for the architecture, another work package for the validation and integration, and two technical work packages where we develop all the innovations of the project. Of course, we don't stay with the theory. We have very advanced proof of concept, 4 POCs. The first one is seamless immersive reality. The idea is to validate the feasibility of enabling real-time virtual presence meetings by combining 6G technologies, advanced edge computing, and stereoscopic capture techniques. The second proof of concept is about machine inspection using autonomous robots and virtual reality. In this case, we showcase the usage of radio access networks and network digital twin with zero-touch closed-loop control in order to guarantee constant quality for the video streams collected from the robot that do the machine inspection. Then we have a network digital twin with non-terrestrial networks. The idea here is to demonstrate the potential of a digital twin within a mobile communication network by validating the added benefits of network digital twin, demonstrate the benefits of clustering digital twins in categories. For example, digital twin, computing digital twin, network digital twin, computing digital twin, process digital twin, all of them in a POC in order to demonstrate this feasibility. And finally, we have a very important application, public safety, where we showcase how public safety services can be integrated into our platform, into the other architecture, and validate the suitability of our solution for supporting mission-critical communication requirements. We are also planning to be very active in standardization activities. We expect contributions in 3GPP in different working groups, like the architecture, the requirements and standards for advanced media services, business translation, APIs. We also expect to be active in the ETSI, ZSM, and ETSI-ENDI. And finally, to contribute in standardization initiatives like Camara, Team Forum, and IRTF. That's all from my side. Thanks a lot again for the invitation. Any questions?
Thank you, Christos, for your presentation, giving us the detailed framework of the project. Actually, as we are still running the first, let's say, period of the project, I don't dare to ask you about the expectations because it is still too early, but just a prediction if you want.
Our expectation is to create, to develop a new architecture that will be able to create impact in the 6G society. And how we'll do this? By having a realistic proof of concepts and contribution to the standardization activities.
Thank you, Christos. This is clear. We hope that in next events we will have more, let's say, results from the trials and the related use cases to discuss, but I think the message is clear, and thank you for this.
Thanks a lot. Thanks for inviting.
Okay. We will pass now to presentation number 10, Key Value Indicators for 6G Networks. This will be presented by Dr. Aitor Alcazar Fernandez from Telefónica Innovación Digital from Spain. A presentation that has been prepared by my colleague, mainly Alex Kostopoulos, in cooperation with Aitor.
Yes, hello to everyone. I hope that you can hear me well because I'm having some minor cutouts in the internet currently. So I hope that it works fine. Let me share my screen and we will. Okay. So please, could you confirm if you can see the presentation?
Yes, we can see the full screen
Yes.
of the presentation.
Okay. Then, let me firstly introduce myself shortly. This is Aitor Alcázar from Telefónica. We have prepared a presentation regarding the key value indicators evaluation in 6G networks, specifically for the Flecon 6G project. Alongside with my colleague, Dr. Alexandro Kostopoulos from OTE. And yes, so let me start with it. The outline for this presentation would be to shortly introduce the architecture design goals aligned with what our project coordinator Christos has just shared with you. Then going through the KPIs and KVIs definition and evaluation concept. Afterwards, we will shortly introduce how we face this coming through the proof of concept ideas within Flecon 6G and translating this into the real world of the KPIs and KVIs, and specifically for the key value indicators. Then I will proceed with the KVI evaluation framework that we have established for Flecon 6G, and at the end, providing some highlights or some points of the defined key value indicators that we have alongside Flecon 6G. So first things first, the architecture design goals, as I was commenting, is to refine the use cases that has been already presented and the box to drive the design of the Flecon 6G system. Then our idea is to define in detail the relevant network level, both key performance indicator, but specifically the key value indicators that are correlated with these key performance indicators and the associated evaluation methodology. Third is to analyze the functional requirements to design the Flecon 6G architecture, and then to produce these technical requirements that will be used during the systems development, and has to do a lot with the KPIs and the KVIs. And last but not least, to design and test the verification methodology for these architectural design goals for the unified reliable outcome. Considering this, we have elaborated a process for the KPIs and KVIs definition and evaluation with a methodology. And let me introduce this shortly. So first, we have the technological partners, the network equipment vendors, the testbed providers, and the telecom operators that are the ones who will be providing information regarding the evaluation, providing their relevant technologies, hardware, software, artificial intelligence, assets, privacy-preserving methods, so on and so forth. And then we will need to be focused on capturing the detailed usability and performance requirements for such KPIs, aligned with the use case stakeholders that will be validating these use cases through the proof of concepts. And then this will be aligned with the KPIs. Then we will have two distinct subtasks. The first one has to do with the systematic compilation of the current use case features and needs. And then this is translated, and this has been translated into the requirements analysis that provide us the key performance indicators on the one hand, and the other hand, the sustainability-based key value indicators to be mapped and to provide all the indicators that are needed to validate the FLECON 6G as a whole. Then we will gather some feedback on those key value indicators via some surveys, interviews, or questionnaires that will be provided and incentivized to the stakeholders, providing some rewards like vouchers of the usability of the platform, so on and so forth. And at the end, we will need to establish a benchmarking methodology to figure out how will be and what would be the expectations regarding the indicators, including some real-time visualization tools for visualize these KPIs and KVIs parameters that could provide a refinement system for the KPIs and the KVIs specifically. So then going through the proof of concept, that is the main focus on our project, not only limited because we provide innovation, but it is an important part to demonstrate how it works. We have 4 POCs that have been already presented. The seamless immersive reality, the massive inspection using autonomous robots and VR, NDTs with NTN, and the public safety services. These 4 POCs are aligned with a planning and operation system that have been elaborated. First, we will need to provide to have the requirements and the specification that come directly from the POCs as a whole of the 4 POCs. Then we'll need to make the POCs set up the testing and the management. Then, and this is the main important part on here, and the more relevant one for the key values indicators, is to provide this framework for the KPIs and the KVIs and the way to measure them and the way to establish those benchmarkings. And then we will have a 4th pillar, which would be the feedback that we will gather from these different POCs, and then the lesson learned from these POCs that could enlarge the capabilities of FLECON 6G architecture in the future. And then if we go directly to the key value indicators per se, we have elaborated a framework, and this framework are based on 3 main pillars. The first one, as previously commented, is the use cases and the POC analysis phase. On here, we needed to provide a detailed description to provide understandable objectives and challenges, to gather all the technical requirements that are aligned with the KVIs, and third, to define previously the key performance indicator, and then align it with the key values, the key value indicators. Secondly, the second pillar is the societal and the business impact. On here, it is important to take into account the value proposition from FLECON 6G, to identify the actors and the roles of each one of these actors, to figure out the value chain that will have the business requirements, and then to have some key values clustering that I will be presenting in the next slide, and to elaborate and define the key value indicators per se. And then the third pillar is to have an overview of the market things. On here, we'll need to have a vertical overview, which would be research-oriented regarding the naturalness behind this project. Then having a market analysis, which is related with products, with services, industrial initiatives, standardization, so on and so forth, and it is more business-oriented, let's say. And then the pillar underneath it is to map these experimental scenarios with the 6G blueprints and the architecture that we will be presenting and providing. Having this into account, we have elaborated, based on these three pillars, a framework for the evaluation of the key value indicators. We have split the key values into three main pillars, three driving forces, so-called driving forces. On here is the democracy, the innovation, and the ecosystem. And all of them are pretty aligned with the European Union SDGs. And taking this into account, if we go through the democracy, is related with the quality education, peace, justice, and strong institution. Innovation has to do with industry, innovation, and infrastructure, the partnership for the goals. And the ecosystem has to do with the affordable and clean energy, the climate action, and the sustainable cities and communities. And taking this into account, and to finalize, we have the key VI's definition in the FLECON 6G context. And on here, and align it with previous clusterization of the three driving forces, we have the innovation one. You have the list on here. We have provided for the innovation safety, security, regulation, responsibility, and energy efficiency that will be covered by all the POCs. For the second driving force, we have democracy with privacy awareness, fairness, digital inclusion, and trustworthiness. And this will be as well provided by validated by all POCs. And in the end, we find the ecosystem-driven force with some KPIs related with the sustainability, the business value that will be providing, the economic growth coming from these 6G services, the open collaboration, and the new value chain identified by and for the stakeholders. So considering all these three forces, this is what we have provided in the framework, and you can see here the listed KPI that have been defined within the FLECON 6G context. So that was all from my side. Don't know if you have questions. Thank you so much for the invitation, and I'm open here for you.
Thank you for this presentation. In particular, it is quite important to see the new trends globally about the introduction of KVIs. We were aware of KPIs, but now KVIs is a new reality. I was thinking of asking you about the selection, but from your presentation, it was quite clear that you follow the Sustainable Development Goals of the UN and of the EU in particular. So the selection of the three fundamental pillars was more or less related to that sort of the European policy, I suppose.
Yes, indeed. When we were elaborating in the proposal part of this project, we focused on these pillars aligned with the SDGs, and then we decided to clusterize this into the three main forces as it was presented, trying to be focused on three driving pillars separately, aligned with these SDGs, and aligned as well with the white papers and the literature that comes from the SNS 6G initiative.
Okay, thank you for your reply. Thank you, and for your support towards having this FLECON-oriented session. Thank you.
Thank you so much for the invitation.
We can now pass to presentation number 11, which is about AI-enabled market mechanism for future networks. The presenter will be Professor George Iosifidis from the Delft University of Technology, Netherlands.
Hello, everyone. I assume you can hear me?
Yes, perfectly, and we can see your screen.
Great. Thank you for the invitation. Good morning from Delft. I'm sorry, I apologize, I couldn't be there. I'm joining from Delft together with my colleague, Michael Kaldis. I believe he's online as well. We are from the Computer Science Department of TU Delft. We participate in Flekon, working with Christos. And our area of expertise is resource management using and pricing schemes for networks using optimization and recently learning tools. This forum is, this conference is really interesting for us to see the latest developments in different projects, and we are happy to participate. So I will try to keep it very brief. I will just at high level give you a very quick overview of what we try to do in Flekon, and to get you there, I will just say a few words of spot markets for offloading for capacity between operators and residential or business access point owners, which was one well-investigated solution 10 years ago, actually, where the idea was that the operators, instead of deploying hardware or network capacity themselves, they would lease it on the spot, on demand, whenever it is available, wherever they need it. And then the main research question here, and practical question actually, is how to match the different operators to the different access point owners or third-party infrastructure more generally, so as to maximize the efficiency of the market. And this is a difficult problem, both from an optimization perspective, but also for various practical reasons, because there are different combinations that make this market efficient. For instance, you have to find, as an operator, the capacity at locations where your demand from mobile users is high, so as to make this offloading as valuable as possible for you, but also lease demand where it is cheap to do so, otherwise the cost becomes higher than the benefit from using it. And hence we have a matching problem which per se is difficult to solve, a combinatorial problem usually, and it becomes more difficult because there is information asymmetry. So from a market design point of view, it's practically impossible to know how much each operator needs this physical resource and how much each third party what is the cost that each third party has to serve this demand, how much it is willing to share, under what price. So we have a problem that is challenging from an optimization perspective, and there is information asymmetry. And our solution for that was to use an auction mechanism, and there were a series of papers, not only from us, but from different people, to do this, to solve this problem. Now, how does this look? I will not tire you or bore you with mathematics at this early time of the day, but again, only at high level, the market problem is an optimization problem where we want to maximize efficiency, make it work as best as possible for those who are using the resources, the buyers, the operators in this case, and as cheap as possible, less costly for those that sell the resources and have to serve the demand, the third-party infrastructure providers. In this case, we have the capacity constraints and we have the consensus. Those who sell have to agree how much they sell with those that buy. Okay, this is the feasibility constraint that we write here. Given that we don't know these objective functions, what we do is we have an iterative mechanism where buyers and sellers submit bids, offer and ask bids to a broker, and the broker decides the pricing rule and the allocation rule in a way that provably, mathematically, drives this interaction to the equilibrium, the one that maximizes the system operation. And I will skip the details here, but we can discuss later if you want. And this diagram here summarizes the situation. We have multiple operators in this capacity market and multiple access points, or in general, third-party infrastructure owners. And they exchange the bids. The broker collects the bids, calculates the current optimal solution, how much each access point should serve capacity for or traffic for each operator. And we see that this interaction probably converges to the optimal point. So this is a well-investigated topic with still some practical limitations, and there were a series of papers, including our own work, almost 10 years ago. Now, what happens in Flekon? Just want you wanted to connect you to the previous literature. What happens in Flekon and what is different in today's network. Uncertainties, scale in size and scale in time are three areas that here we have to tackle, new challenges to tackle. So what, to make this more concrete, what if the solver, the market coordinator, but also the bidders, do not know the problem parameters, right? Again, the market is an optimization, big optimization problem. This is how economists approach the market design. This is how we do it as well. But in our case, when we talk about networked markets or markets of networks, these problems are huge, and also the objective functions might be changing over time and might be even unknown. For instance, how much resources a vertical should ask when it doesn't know exactly the demand of its users for which it needs these resources, or what slice composition will be the best in terms of performance when, again, you don't know the type of request your users will ask. How much resource providers should charge for each requester, because in most cases the physical infrastructure providers have their own services and they don't know how much they will need for themselves. So all these uncertainties, again, together with the scale of the problem, we have a huge number of networks trying to coordinate, some of them and verticals, and the time scale and the uncertainty create the need for a new framework, for new market framework. And our suggestion, what we are currently working on, is to use learning, mathematical learning, online convex optimization in particular, together with deep learning tools, which provide us predictions for this missing information, so as to have a best of both worlds scenario. What does this mean? So we try iteratively to make suggestions for this matching and the pricing and the auction outcomes. And we do that in a way that we learn on the fly how to operate. Let me here explain a bit what is happening. We implement a decision about the resource matching, how much, if I go back to the example of capacity, how much each third-party access point should serve, how much traffic should serve for each operator. Then we observe the results, how good was this matching, how costly it was. We get new data about the system, and perhaps a predictor tells us, a deep learning or a forecasting model tells us what would be the demand for the next round, and we update our decision for the next round. Here, this goes beyond the state of the art, and we currently publish papers extending the theory in this area, in the sense that we manage, when the predictions, the forecasting models are proved to be accurate, something that we don't know in advance, then our market operates very efficiently, very fast, reaches the equilibrium point, despite all this uncertainty. But when the predictions are inaccurate, when we have a distribution shift, we still get the benefits of online learning tools. So what we are going to do in Flexcon, or what we are already doing, we want to evolve these ideas on the design of markets using learning tools, but rigorous optimization-driven learning tools. We want to combine multiple predictors to make this more robust, this framework more robust. We want to strike a balance between efficiency and revenue. What is the ideal market objective in this kind of systems? Is it to maximize the performance or the revenue of some vertical or some infrastructure provider? These are design questions, and we would like to have a toolbox that gives answers to all possible or all legitimate or plausible combinations. We want to design also forecasting tools specifically for this type of network markets or markets of networks. Since Flekon is the network of networks, this is what we propose and what we promote. And we want also to move from simply utility or performance or cost functions to intent-driven markets, where we quantify the performance, the intent, and map it to utility functions that we then optimize. And of course, the list is open, so if you have suggestions, we are always happy to collaborate with the new partners, or in the context of Flekon or otherwise. Thank you.
Thank you, Professor Iossifidis, for this detailed and quite interesting presentation. I had a question for you regarding the way how you developed, let's say, your approach actually based in the framework of the market actors of Flecon, or as you mentioned in your last slide, you also have some sort of openness to other market actors that may potentially join and provide feedback. I suppose that the initial approach is based collaboratively on work that and information and feedback that you will collect market actors from the scope of the project. But is there any prediction later somehow to make available some of the findings and request feedback by the wider scope of the market?
That's a good question. So indeed, now our starting point is what happens within Flecon, and as I explained, we have prior experience in designing this kind of allocation and market mechanisms. But we are certainly interested to see how this can apply to different contexts or how they can be enriched by different ideas. So certainly we are open and to hear more suggestions.
Thank you for this. And thank you for your support in order to have this Flecon-oriented workshop. We expect that in some future events, when we will have more results to discuss and demonstrate, as the project is still in the beginning, we will have the opportunity to have you again in our panel. Thank you for joining.
It would be a pleasure. Thank you again for the invitation.
Thank you. So we are aligned with the time frame. We may have 5 minutes break before passing to the next session, which will be dedicated to the DataMite project. More or less, this time we are aligned with the framework, so just 5 minutes break instead of 10. Thank you. We are now ready to start and follow the normal flow of the project, which is the workshop, which is now the next session about DataMite, contributing to the European data monetization. I will give the stage to my colleague and my friend, Dr. Christos Gizelis, who is always present and support this research-oriented workshop in the scope of the InfoCom event, and not only there. Christo, the stage is yours. Thank you for supporting us.
Thank you, Yanis. Thank you for the warm words. Thank you for the invitation, not only personally, but also on behalf of the DataMite project, and the opportunity that you're giving us to present the results of the project and what DataMite is actually about. So, good morning, everyone. My name is Christos Gizelis, Principal Innovation Analyst at the IT Innovation Center, and it is my great pleasure to welcome you and to welcome you at the DataMite session. This session is about data. It's about AI. It's about monetization. So you can understand that it is a business-driven session. We live in the age of AI, and AI cannot exist, cannot dominate without data. Data is the fuel of AI. And data is actually an asset within organizations. No matter the size they are, no matter if they are large industries, SMEs, startups, public organizations, it doesn't matter. If they have data, they produce, they handle, they own, it's their asset. So this is where DataMite comes to assist European organizations to exploit and get benefits out of their own data. Some statistics. There is a data decision gap, about 95% of data usage. And data currently only produce 32% in value. So that gives us about 60 to 73% data never used for analytic purposes. And only 10 to 30% can reach revenue levels. So from these numbers, you can clearly see that there is potential for growth, and organizations can benefit from giving abilities, giving the tools to exploit their assets. So data accumulation is only enough if data has value and can be valued. So that means that they need high-quality data. The capacity of companies to monetize data is connected to trust and quality features of their data. I think these are clear messages. So let's see what DataMite is about. DataMite helps European organizations to better govern and monetize their data. It provides an open source framework to boost monetization and create some business model strategies in order organizations to understand their data and to, let's say, follow a certain strategy, a certain process in order to exploit the data and get benefits out of it. About DataMite, it's a 3-year project, nearly reaching its end in a couple of months. We have about 20 million euros budget, 1,400 person months, and 24 partners, experts in various domains. So, DataMite framework actually assists organizations to exploit their data, to form their data in a way to be able to be shared either in, as you can see in the screen, in data spaces, in other data markets, even on the AI on-demand marketplace that it is currently developed by the European Union and several projects. So this framework contains several tools that will help organizations to improve the quality of their data, to improve the governance of their data in order to share them, technical trainings, but also business model strategies. More detailed presentations will follow in this session. We have tested all these tools and the strategies in several pilots. Indicative, I can tell you that these pilots are about data exchange within large organizations. One of these pilots is related to OT's engagement in DataMite project. We have pilots in energy data spaces and interaction with other initiatives, other marketplaces, and the European Union's AI on-demand platform. Very briefly, this is what DataMite is about. And now I would like to invite to the podium my colleague, Martin Loers from RWTH Aachen University, to talk to you about data monetization strategies. Martin, the floor is yours. Thank you.
All right. Thank you, Christos, for the invitation. Thank you for being here, presenting results of DataMite. What we are talking about today is the strategies and, in my part, about the strategy perspective. Later on, we will go more into detail where we operationalize all these strategies. What we have done, our approach and the development steps, we started with conducting literature review as every good scientific guy. Then we conducted case studies with all the pilots that Christos has introduced beforehand. And we analyze the ecosystem. So how do they use their data? Which way they try to figure out to monetize them? Maybe they don't monetize them. Why do they don't monetize them? And we conducted a lot of expert interviews in order to find out which different ways are there to monetize data and which strategies may stay behind this. Then we set up a model. And the second step, and we had an identification of 4 principal monetization types. Later on, I will show you what this is about. We have clustered these into 12 distinct strategies. Of course, every practical guy will say they are not distinctable that sharp, but we need this for scientific stuff in order to explain it in a way that everybody can understand this. In the reality, all these strategies are always mixed together. We have developed a structured framework that I will show you later on. We have improved industrial applicability with a lot of interviews, also with OTE. And we are currently in a validation phase where we are using our framework and look if it is applicable to the reality. So what we have found are 12 distinct strategies about data monetization. They are written down here. You can also find these on the website of DataMite. So I won't tell everything about this because I don't have the time about this. But what you can see is that we are starting from very easy way to use data in reducing cost, going on to other strategies where you need a lot of knowledge to do so, like information as a service or data as a service and so on. So it is not easy to follow each of these strategies, and this brought us to, first of all, an idea we must structure this and bring this then to our users. So how to structure this? We have 2 main different views. We can use data internally and we can use it externally. Internally always means that we try to improve efficiency, decision making, whatever in our own organization. External data monetization means that I use my data in however way and bring it to customers of mine or partners of mine in an ecosystem or something like this. And then we can distinct it furthermore into indirect data monetization, where we create value by using data to enhance products, services, and so on, into direct data monetization, where I sell my data or information or whatever to direct revenue. Or I have also the non-monetary utilization, where I use my data to bring me strategic benefits, like I'm looking good for my customers or bring data to improve the health system, whatever. So I don't sell them in fact, but I use them for marketing purposes. Bringing this together, we have here our monetization framework where we have brought together all the different strategies that we have found, the 12 from the beginning, to our framework. And what we see is that we have the internal monetization on the top with reduced cost and data network. We have the indirect data monetization with it always combined with a physical product, so wrapping data products around a physical product. Servitization, we have new products that are always combined to physical products or services. We have data bartering where we exchange data with other companies, and then we don't have a direct monetization in the way that we have money behind our data, but we get data in reward for our own data. And then we have the direct monetization with data platforms, as a service business models, and of course the non-monetization, non-monetary utilization where we have it shared for free. So what have we done in order to bring this now to companies? Because it is nice to have this, but nobody can use it really. So we started with a theoretical foundation of the questionnaire with the Gassman triangle, where we try to achieve what is a business model made of. So we have, first of all, the what. So what do we offer to our customers? What is the value? What is our product? Then how do we produce our product? How do we get our data? How do we align them with compliance or whatever? And the value of these. So how do we evaluate our data product, and sell this to our customer to which price? And who is our customer in the end? Because if I don't know this, I'm not able to sell anything. And with this, we conducted several questions, brought them into a questionnaire that you can see here. Then we cut it down because it were too much questions to the most important questions for the companies to answer these. So starting with, who is my customer? What do I offer to him? How do I obtain to my data? And they are gathered all in these 4 dimensions of Gassman. We have always 3 or 4 answer options for the companies that use this framework. And now I will go with you through an example where we did this with a company, Apple. So we have here Apple Health Reports. They have an information as a service. This is an example here. The overview, Apple delivers personalized health and fitness insights via health app and Apple Fitness subscription. They use for data and technology, they collect information or data from your iPhone, from your Apple Watch, from the built-in sensors they have. And they have advanced algorithms and machine learning transforms these raw data into information about your health status. The customer value of this is helping to improve your lifestyle and so on. So it's more or less, it's not that you get any money for this, but it feels good to use these data products of Apple. How do they monetize it? They don't monetize it directly. They have, of course, a short revenue about their subscription, but more or less it's more like an ecosystem idea. So they try to bring you in the ecosystem that you use their watch, that you use their iPhone, and if it is possible, also the iPad and whatever, so that you're getting stuck to their products. So there, the digital product is a mix of information as a service on one hand, with a subscription fee, but on the other hand, it's also something like a wrapping strategy about their physical products. We see here now this questionnaire. On the left side, you see the questions. I couldn't write them here down, so it would otherwise too big. But we go this through with an Apple manager, and he tipped all the answers that he thinks that might fit for him best. And what we see is here then a pattern where we have a distinct choosage of the options, answer options. We can mark this by bullets. And on the left side, on the bottom left, you see this is more or less information as a service, the answers that we have thought about. Beforehand, we've conducted the interviews about this strategy. We did this for all our strategies, And so we have now a questionnaire where we combine questions and answer options with the different strategies. And we are able to go with this questionnaire to our customers of Datamite, so the SMEs and the companies in Europe, and help them to figure out which monetization strategy for data would fit best, or otherwise, when it doesn't fit yet, what is missing. So that we can also give them a hint where to develop themselves in order to get better and monetize their data in a way that aligns with their strategy. Thank you very much. This is about the strategic view of Datamite and the monetization of data. Now I will hand over to my colleagues that will go more to the operational part. Thank you.
Thank you, Martin. We just saw the approach of monetization strategies introduced by the Datamite project. Now it's time to see how mature the data are. And I would like to invite my colleague Udo Bu from 1001 Lakes, that is leading the data monetization maturity modeling within Datamite project. Udo, can you hear us?
Yes, I can hear you. I hope you can hear me well.
Yes,
and
clearly.
I hope you can also see my presentation. Yes. So let me switch to presentation mode. All right. Thank you, Christos and Martin, as the previous speaker. Let me share some thoughts about data monetization maturity.
Udo, sorry. You're not sharing the screen. You need you need to switch back to the previous mode.
Okay. Is it?
Just full screen. Just full screen.
I cannot produce full screen probably under these circumstances. So
we can see your slides clearly. So
yes, for simplicity, I propose to continue like this then.
Yeah. Okay.
So data monetization maturity model. So let me give you the context of our work within the Datamite framework. So one of the major deliverables of Datamite is the so-called business blueprint. And the blueprint is a recipe that you can use for engaging in data monetization businesses. And it consists of 3 modules. One is the maturity model that I'm going to explain in detail right now. The other module is the data valuation model. How much money can you ask for a data set? And before you come to a price tag, you need to clarify the valuation. And this will be the next speaker, Andrea Vicentin, who is also online. So this will be clarified in the subsequent talk. Then the third module is a strategy canvas. And it builds on the work that has been presented by the previous speaker, by Martin. So we have taken the 12 strategies that you have been introduced to, and we have built canvases to elaborate further on your business model behind that. So you know canvases like the Osterwalder canvas for business modeling, and here we have a specialty canvas focusing on data monetization modeling, which is built on previous work of VDMA, a German association of machinery construction companies. And we have pre-filled canvases based on previous work for those 12 strategies that Martin has just introduced to you. But now let's focus on the maturity model. What I will tell to you can be read in further detail in this publication that I'm referring to. Christos was a co-author of it, and he will be able to point you to the publication itself. Otherwise, if you get hold of this presentation, link on the link so you can retrieve the presentation online yourself. Generally speaking of maturity models, they are built on an original, I would say, mother of maturity models, which is the capability maturity model of Carnegie Mellon University's Software Engineering Institute. It's roughly 50 years old already, and probably known to many people from this audience. The capability maturity model is on assessing software maturity for the organization that is producing software. And we have an analogon for organizations that produce data monetization models. And generally speaking, maturity models serve three purposes. And I think all of them are useful also in our context here. One is a descriptive purpose. So you make an assessment how far your organization is already now, a so-called as-is assessment. You describe what the situation is right now. But then also a prescriptive purpose, which means that you describe how it should be. Not only describe, but you prescribe. So you set up actions that put you into the position to reach the status. So it's a prescription, actually. And both of these purposes have been elaborated already in our DataMite project with examples. There's a third value that we don't focus so much on DataMite, but which should be also a consideration, is the comparative purpose, benchmarking. So you can benchmark yourself by applying this maturity model to other organizations from your own industry or across industries and learn from this how far you are. All in all, a very good communication tool, especially with senior management, but also with your own company to see where you are, where you want to go. How did we develop it? We started from previous work of the University of St. Gallen. They have established the so-called House of Digital Business, which is very often cited in literature. So it's well-grounded to cluster digital transformation work according to the House of Digital Business of the University of St. Gallen. And out of these modules of this original, we have transformed them in workshops to a subset of dimensions that are relevant for data monetization. And these are customer view, a data business product view, an organizational view, an IT competences view, a process view, cultures and skills view, and a data strategy view. And for these 7 dimensions, we have built a criteria catalog. So a criteria catalog is a set of criteria, usually as questions, formulated as questions, where you can answer of a value between 1 and 5, a so-called Likert scale, where 1 means does not apply at all and 5 means fully applies, and the values in between you can interpolate. And we've built such a criteria catalog. It's in detail, you can find it in the publication. Well, how did we get there? We made a thorough literature analysis about data monetization, more than 1,000 publications reviewed. And then we conducted several workshops with experts in the project and also with participating companies, including OTE. And like this, we came to a clustering approach that led to the criteria catalog that I just mentioned. Then we attributed 5 levels of maturity: ad hoc, reactive, defined, controlled, and optimized, to cluster the responses and find the degree of maturity that is valuable across all of the dimensions that I just mentioned. So final scalar value of maturity. So 5 levels of maturity, where we do not recommend to necessarily reach level 5. However, we have found out that in order to engage meaningfully in data monetization, you have to have some prerequisites in place, which are typically associated with level number 3. So roughly at the level of 3.5, you find a reasonable level to engage in data monetization. How does an assessment look like? So you have a criteria catalog that I just mentioned, and then you make an as-is assessment and a target assessment. Here, for example, we made an as-is assessment where a company is in all of those dimensions. So think of values between 1 and 5. And we said to meaningfully engage in data monetization, you have to reach a level of 3.5. You can see that there are gaps, and this is a very typical gap. A data product, in the sense of a data business product, is usually something that has not been developed much. Data products in a technical sense exist in mature companies, but business plans and typical data product management tasks associated with it are usually not taking place for many companies. But there are also other deficiencies that are very often should be company dependent, processes that need to be reworked. In this case, IT is already prepared, so there's even an overshooting in IT competences, of which you can never have enough, actually. And then you set up a portfolio of things, of actions. You can rank them over urgency and benefit, and then tackle the most urgent ones with the biggest benefit to come to the desired state. And the maturity model is a very good means of helping there. For completeness, I would like to show you also a screenshot from the publication where you have the individual 61 criteria listed. Don't try to read them on the slide. This is just a visual impression, what you can expect when reading the publication. And we have conducted several assessments. For example, this is with an energy company, a distribution network operator, and there you can see a picture where, with a deficit that I just mentioned, that is exemplary, data business product, not so much. Nowadays, IT is in very good shape. It was not like this in the past, but it's improving. And this D&O is actually in a quite good position. We conducted this over several pilots here. So one telecommunications company, one digital services company, 2 distribution network operators, and 2 high-performance computing centers. And you can see, for example, these are the 2 distribution network operators, and they have a different maturity level. We made a consistency check if this makes sense, and found out that there are really differences that are grounded in reality. So it's not just a modeling issue, it's an organizational maturity issue that we have discovered here with our maturity model. And as such, it confirmed the maturity model that has been developed by Datamite. Happy to go into further details offline. My presentation time is over by now, and I hand over for the moderator. Should questions be allowed, I'm happy to answer them immediately, or we can hand over to the next speaker, which is a very interesting discussion about data evaluation. Thank you very much.
Thank you, Udo. Thank you very much. Very informative, very analytic presentation. Ladies and gentlemen, you could realize by Udo's presentation that this modeling is able to show to data owners and decision makers within organizations the strengths and the weaknesses of their data, and especially units and processes that need to be improved, or strategies that need to follow in order to better use their data. So let's go more into details and see how we treat and how we realize the values of data within our organization. So the next speaker, Andreas Visentin from University College of Cork in Ireland, will present this approach to you. Andreas, are you with us?
Yeah, thank you so much, Christos. Can you hear me?
Yes, loud and clear, and the floor is yours.
Thank you so much. Let me actually share my screen, and hopefully you will be able to see the slides now. Can you see them?
Yes.
Perfect. Thank you. Thank you so much, everyone, for being here, for being actually in Greece today. I'm Andreas Visentin. I'm an associate professor at the University College of Cork, and I'm here to present a project we have developed mainly in collaboration with 1001 Lakes, so Udo that we presented before, about a new framework for data value estimation. First of all, we need to put a bit of context from the perspective that the value of the data and its price is something different. When the pricing of a data set is purely the monetary value, the value that can be extracted by the data is a lot more, because they can be used for internal purposes, can have utilities across different projects, and that is relevant not only for widely known measures like the quality of the data that has been widely analyzed in the literature, but is also strongly dependent on the particular application, so how relevant is in this particular context, and the overall utility across a variety of potential applications. Another really important aspect to assess the value of the data is the demand, so much will be used, and overall all of this is strongly linked to the strategies, the one that Martin presented before. So the strategies on how a company wants to create the maximum benefit out of this data will strongly affect which value the data has for the company itself. And what we presented is a new framework, and this one is our main contribution for evaluating a potential data source, a data set, or a way to collect data. And all of this starts from the strategy. So how do you plan to create benefits for your stakeholders starting from your data sets? And depending if you plan to sell them as data as a service or if you want to use them for internal purposes. Depending on the strategy, we can analyze what is the demand, the expected demand for the data set. And the context is actually including a set of metrics and values that we can use to assess how well we are delivering on the strategy or how far we are from fulfilling it. All of this will inform decision making, and the evaluation model that we are developing, we developed, is taking into account all these aspects: the strategy, the demand, and the overall decision, the context, and the metrics. The final outcome of this evaluation model is not a purely monetary value, but is used in a comparative way. So we can assess the value of different data products, different alternatives, and see which one is more relevant for our company, which one would be better for a given application in a numerical and comparable way. A couple of use cases: suppose that you are a micro-mobility startup. You need to expand in 5 different cities and you need high resolution geolocation data. You can acquire this mobility data from different vendors, and all of them offer different coverage, price, quality guarantees, granularity, and you want to do this, this decision in, let's say, a data-driven perspective, so numerical perspective and not purely by gut feeling. Another use case is that you are a manufacturing company and you need to deploy a new set of sensors to monitor your machines, to check their reliability, to do predictive maintenance. Of course, this different set of sensors will have different costs, different electricity consumption, so cost of acquiring the data, different level of accuracy of all the information provided overall. So how can you guide your management through this decision and make it and do it in an objective way? The data evaluation model is actually here for this. And overall, the framework we're proposing starts as 2 different starting points, or through a simpler decision tree in which we guide the user through the selection of some metrics that can be assessed for evaluating if the strategy has been delivered in the correct way and to overall data value of the data set, and they are also providing a set of recommendations. The other way is to use an analytic network process, so a business framework to identify which are the more detailed metrics and KPIs we can use and the relative weight. When we select what needs to be measured, we aggregate them and we estimate the quality, the relevance, and the utility of the overall data set. Alongside the demand and the cost aspects, we will be able to assess the overall value of a data product. The decision tree pathway, so the one that was before in the top, is simply going through a set of self-assessed questions in which you will identify what is relevant to be measured in your particular case, and they will provide some suggestions, some recommendations. These questions are including, for example, what is the licensing type you want to use, if the data you are using is GDPR sensitive, and what is your plan to create value out of your data. So if it's direct, so you plan to sell it, or indirect. To give a bit more flexibility, because of course the ways value can be created out of data are countless, we decided to do a deep analysis of all the metrics and KPIs we could find in the literature relative to data monetization. And we grouped them into a new taxonomy based on the balance scorecard. We use it to analyze them from 4 different perspectives. The financial one, so the financial performance of the business. The internal one, for example, optimizing your supply chain, improving your scheduling, or the customer perspective. And finally, the learning and growth. It's always from the internal perspective, but how to generate, for example, new products or employee retention. Dividing all the KPIs and metrics into this new taxonomy, we also analyze the way they interact and the way they are connected. And this provided, so this one is just a summary of the key aspects, but the overall taxonomy involves a few hundred different metrics that can be used. And this will provide a company for the best way to track and assess the value of an incredible wide variety of potential use cases. When the metrics and KPIs have been identified, we can group them, we can use the 2 different steps to aggregate them, and in the case of the analytical network process, we will also add the relative weight that will allow us to score their importance accordingly. And then finally we need to estimate, first of all, the quality. What here on top left is identified as main index. So this one is relative to the accuracy, the reliability, the percentage of missing data in your data set. The relevance for the specific use case, for the specific application. In this case, we relate all these metrics to what would be a desired target set by the strategy and the overall utility. So the relevance across a different set of applications. After assessing all of this, we need to estimate the cost, the overall demand, and the cost to acquire and maintain the data. Finally, estimating the potential of the dataset as well, we are able to estimate the overall value. With a couple of use cases in which we use to assess different data products to then recommend what would be the most accurate one for a given company. The main issue is the identification in this case of the metrics and KPIs and how relevant they are for your specific application. To simplify the process, we developed a tool available online at datamine.insightcenter.org that will allow you to select which strategy you want to pursue to create value out of your data, to monetize your data. And this is present in the 12 strategies introduced by Martin before. After selecting the strategy, you will select from which of the perspective your strategy will be most relevant to. And then you will be presented with a set of KPIs and metrics that you can measure, that you can consider to deliver on the strategy. We will be able later on, from your framework we propose, to assess the relative importance, and through this way, the overall outcome of the tool is how these different metrics and KPIs are relevant for, first of all, your overall strategy, and then for the 4 different perspectives of your business. Feeding these results into our data evaluation model, you will be able to assess the overall value of your dataset. So I would like to thank you all so much for the attention, and I'll be happy to take questions as well.
Thank you very much, Andreas.
Dear guests, by now you can realize that DataMite framework is the tool that assists data owners, business owners to be guided towards their monetization of data adoption. It includes actually tools to prepare data for monetization or simply sharing data, but also they can DataMite can guide them to proceed and to form a strategy. But when I'm talking about data monetization and data sharing in general, there are several restrictions, several constraints that have to do with compliance, with regulations, with ethics and trust. DataMite is also able to assist towards this legal, let's say, approach. So on behalf of our colleague from LIF Bulgaria, Polina Petrova, I would like to call to the stand Martin Lores to provide this knowledge coming through DataMite project. So Martin, please.
So I need another screen. Sorry, Andrea, we won't see you anymore. Currently, you are at the main stage.
All good. Yeah, I stopped sharing. Is there? All good?
Yeah, but the technicians have you already
okay,
all on focus. No. All right. As Christoph said, I'm the spare for our colleague Polina, so I'm not a lawyer. I'm also not from the Law and Internet Foundation, where Polina is working in Bulgaria. But I will give you an overview about the legal and ethical parts of our work package, because everybody of you knows when you are maybe ill or something like this, you don't want that your data come to your insurance or something like this. So we have some restrictions. We have a lot of restrictions in the European Union, and we have a part of our project that is focused exactly on these entering legal and ethical compliances in order to bring us not into problems. So what they have done is they have looked out about several different regulations that affect data, data monetization, but also data sharing and so on. So the regulations that are looking on was Data Act, the Open Data Directive and Digital Governance Act, the Digital Markets Act, GDPR, Free Flow and Non-Personal Data Regulation, and also some others that will be shown in the next slide. So the data type is differs from each regulation. So we have from the Data Act, the private data that is regulated in this one, and sharing of private data. And the main tools here are obligations to share data in business to customer, business to business, and also the governance. And we have a general framework about this for data access and also sharing. For the Open Data Directive and the Digital Governance Act, this is about public data. And the main tool here is the obligation of public sector bodies to offer public data for reuse, so that we have governments, we have whatever is gathering data that are not personal, they are able to provide them to companies in order for them to use it for beneficial purposes. We have the Digital Markets Act. Here we have the main tool of the gatekeepers that provide access and portability rights, so not everybody is allowed to go into these data marketplaces, and we need a central operator for this. At GDPR, we have a framework for digital trust and portability and transfer and etc. So this is more or less combined regulation from the industry and also the European government in order to give a standard for everybody that is, aligns data sharing and so on. For the free flow of non-personal data regulation, we have a ban of data localization measures. So these are non-personal data, and all other information that are in these data must be declined, so that it is not possible to gather some personal data out of the data that are provided here. The others are mainly sector-specific. For example, we have electricity, energy, agriculture, but of course also medicine and so on. So we have some different regulations for these sectors that are also in account. We have also the Digital Service Act, the EU Artificial Intelligence Act, and the Directive of Measures for High Common Level of Cybersecurity. These will take in account as the next regulations. So we are currently working on this. So the full review and the analysis of the EU data sharing framework is more or less, we are at 80%. So we had a deliverable 4.6, which is complete, which settles on deliverable 4.5, where we have a further in-depth analysis of the regulatory framework, review of the additional sector-related aspects, but especially it is for the updated revision of applicability for the pilots. So we have developed the framework, great, but we must make it applicable for the pilots and also for other companies, otherwise it wouldn't be used. And this is what is now currently going on, that they are really working on making it feasible for companies, making it have an easy entry. So what are the subsequent steps ahead? It is more or less about the tools are developed, that it is easier to use them. We have the documentation, of course, always needed documentation for all of this, that you can read this in depth if you want, in order to understand what the tools are doing. And we have a wrap-up guidance and question answer for the technical partners, as well as we have webinars where we are introducing the frameworks that are developed in this task. So thank you for your attention for the legal and ethical parts. If there are questions, please reach out to Polina. She will give you all the answers that are needed. Thanks.
Thank you, Martin. I think in this 45-minute session we managed to give you an idea of what data monetization strategies is about, what value Datamite project through its tools, but also through the proposed strategies, the monetization modeling, and the value identification of data within organizations. Datamite is reaching its end in a couple of months. You can reach out to us in case you have any questions.
Okay, for the sake of the economy of time, although these issues are quite interesting, I just want to summarize and just ask you a single question. If you would like to summarize and say just in one or two phrases the main findings, the main innovations offered by Datamite, by your experience. Because I really wanted to have more discussion, but we are lagging behind the original schedule. And as I mentioned in some previous cases, our aim was to host as many as possible presentations in order to give ideas about future directions. Otherwise, we should have selected half of the presentations and have more discussion. But Okay.
Data, very few words. Data-driven market is an emerging economy. Especially European organizations lack of clear understanding of the value that they have, the assets, the data. So this is where DataMind comes to assist European organizations, no matter the size, large industries, SMEs, startups, public bodies, to understand the value and the strength of their data, and through our framework, to guide them, to assist them, and produce value and get benefit out of it.
Thank you very much, and thank you for the organization of this very interesting session. And now we'd like to ask for the support of our technical team in order to be prepared for the next session. It is session 5 about the 6G BRICS project, an innovative effort which actually aimed to develop a 6G network infrastructure integrating non-cell-free technologies and reconfigurable intelligent surfaces technologies for beyond 5G. In the scope of this very interesting project, which is running towards its end next June, there was also effort for examples of unified control based on explainable artificial intelligence, also strong correlation to the Open RAN initiative, and a very interesting focus on use cases covering, for example, holographic communications, as we will see the metaverse and digital twinning. I would like to invite the first presenter of this session, Dr. Kostas Ramandas from iQuadrat Informatica. Kostas, thank you again for supporting us and for coordinating together with Christos Verikoukis this effort to demonstrate information and outcomes from the project. And please pass to the presentation of Dr. Ramandas.
Thanks, Ioannis, for the introduction, and thanks again for support for supporting also this project as part of the consortium. So, hi all, I am again Dr. Kostas Ramandas. I am the technical manager of 6G BRICS. So 6G BRICS is also a StreamC project, like Sunrise 6G, and this means that this is a project that is developing the first 6G project, the first 6G testbeds in Europe. This is a Call1 project, so it's one of the first 6G projects that were funded. And our aim here was to basically take some early beyond 5G components that were being developed also during the latest phases of the 5G program, and take these breakthrough components and integrate them within testbeds. And we did this through Open RAN interfaces. Open RAN was a relatively new initiative back then. It managed to succeed somehow. And what we did was take these breakthrough components from previous programs and package them, expose them to the testbeds within Open RAN interfaces. So these concepts, we call them BRICS. So breakthrough components packaged in the form of Open RAN components with Open RAN interfaces are our BRICS in this project. This project combines 3 testbeds, 3 experimentation infrastructures. The Athena ISI testbed is the entry point. It's where we basically have deployed the orchestrators and the portal of the project. And then we also have 2 testbeds, one in Belgium, KUL, University of Leuven, and there the focus is on cell-free massive MIMO. Cell-free is one of the beyond 5G technologies that uses some advanced interference cancellation techniques. And the other 6G BRICS technology is the RIS, Reflective Intelligent Surface, and RIS technologies are deployed at the Eurocom testbed in France. Also, we have a cognitive compute continuum enabler that is being developed in collaboration with Intracom, and some explainable AI that is delivered by ISI. So let's go over our major outcomes one by one. We will focus on all these outcomes. First, cell-free massive MIMO. As mentioned, Self-free massive MIMO is a beyond 5G technology. It's not used in the current version of 5G networks because it needs a very strict synchronization between the base stations, and this allows them to implement some advanced interference cancellation techniques. Due to this strict synchronization, most implementations of self-free rely on a centralized node. 6G Bricks and some previous initiatives were the first to try to deliver a more real-world self-free massive MIMO implementation where you don't have this centralized node, but you can do this with some distributed protocol. So you can have some distributed synchronization, and we used to this effect some open-RAN interfaces, and we were also the first to propose some extensions to Open RAN in the form of some inter-DU interfaces between the distributed units of self-free, and actually those interfaces were eventually standardized. Unfortunately, we were never given credit for being the first to propose this interface. Eventually, the industry realized that these inter-DU interfaces are necessary and added them to the standard. So, 6G Bricks implemented basically we took some existing implementations of the CU and the DU, those are basically components of the base station, extended them with self-free support. We also implemented a RIC. The RIC is also an important component of Open RAN with all its interfaces. Again, the RIC was extended to support self-free. And we also implemented an XApps framework, which is a framework that allows programmability. So you can basically program your network and change some parameters. You can change the scheduling algorithms on demand. We also implemented a self-free massive MIMO emulator. So this XApps framework can be exposed to experimenters, and the experimenters can test their XApps, their programs essentially, in a sandbox environment. These programs essentially allow you to change the parameters of devices. So 6G Bricks was the first project that allowed external experimenters to interact and perform experiments directly on device through this portal. And here you can see the interface where you can select some pre-existing XApps and you can change their parameters. So you can, for example, change the scheduling algorithm. You can select from a list of already existing pre-coding algorithms. And you can also, of course, upload your own XApp in the form of a Docker image. And then you can even more deeply interact with the devices and change their characteristics. So this is a radio unit. The radio unit is also a component of self-free massive MIMO. 6G Bricks also implemented a radio unit based on a National Instruments USRP platform, and basically was extended with self-free capabilities. And now let's go to our second beyond 5G enabler, the RIS. I will go directly to my second slide, because first I want to explain you what a RIS is, because maybe you are not familiar. So the RIS is like a relay, but it's an active relay. You can see in the figure that there is a transmit and a receive, a transmitter and a receiver. It's the TX and RX. And the RIS is on the left-hand side. So you can imagine that the RIS is like a mirror that allows the transmitter it reflects the signal from the transmitter towards the receiver, essentially, and of course increases the SNR value. We managed to measure an improvement of 10 dB compared to without RIS, but there is also the capability that you have with the RIS to steer the beam. So you don't have a fixed angle, like when you are using, for example, an actual mirror, but you can also actively steer the beam. And so when, for example, the receiver is moving, you can actually follow the receiver by changing the angle of your beam. This concept is also very well connected to the concept of localization. So you can simultaneously localize your receiver, and then you can also track them with the beam. So RIS was considered one of the important technologies of 6G. Within 6G Bricks, we basically leveraged an existing RIS implementation. This was further matured within the project, and also was connected with a real-world 5G stack, Open RAN stack. This is called Open RAN interface. This is open source. And through 6G Bricks, we could actually control this RIS through the base station. And we could also use the concept of the DXApps, which I explained earlier. And through the DXApps, we could dynamically change the angle of this reflected beam. And now, finally, we also had some very important contributions in explainable AI. 6G Bricks was one of the first projects that implemented some explainable AI algorithms for 6G. So, here you can see the general architecture of the explainable AI framework. Essentially, we have a set of KPIs that are coming from various technologies domains. We can have some KPIs coming from the radio access network through KPM. These are some Open RAN monitoring APIs. You can have some KPIs coming from your compute continuum. And through explainable AI, you can pinpoint some problems to your that you detect. So you detect some problems, and then you can identify which KPIs contributed to the problem. So this is called reconstruction, and you can also detect the anomalies and predict them before they actually happen. So this was implemented in 6G Bricks for the first time for 6G. And we also implemented a module, an explanator on top of this explainable AI component. And this explanator uses LLMs to also explain the anomalies in human language. So first you detect the anomalies, and then you provide a human-readable explanation like the one you can see here. For example, you can write to the output that the root cause of the SLA violation was due to insufficient RAM allocations. And it can also provide you a recommendation. Here the recommendation is increase the allocated RAM, resulted in a new RAM limit of 700 megabytes. So the user can easily then address the problem and improves the SLAs. So that was it. Thanks a lot for the invitation again, and thanks for your attention.
Thank you, Kostas, for giving us a concise description of the major achievements of 6G Bricks. The next speaker is Mario Montagu from I2CAT. So, Mario, you will be connecting remotely. The floor is yours. Is Mario here?
Hey, Mario, by the way.
Hello. Hello.
Yeah, Mario is checking his microphone. It's not working well.
Okay. Now?
Yes.
Okay, so what a problem with the headphone. Sorry for that. Okay, so we'll share the screen. Yeah, you can see my screen, right? Correct? Perfect. So, hello everyone. My name is Mario Montagut. I'm a researcher from I2CAT Foundation. And in this case, it's about one of the use cases that we are addressing in the 6G project, previously introduced by Kostas. And in this case, it's about cluster-based collaborative metaverse scenarios, okay? So this is the outline of the presentation. It will take 10 minutes. And first, we are going to highlight what is the potential and the current limitations of the metaverse, the current status of the metaverse. And then we are going to try to highlight how 6G technologies can serve as a foundational technological enabler for the next generation metaverse, no? How it can address these limitations. Then we are going to introduce the collaborative metaverse use cases addressing 6G Bricks, and we will conclude with some conclusions. Okay, so if we talk about the metaverse, all of us are thinking mainly in virtual environments, and that's true, but it also includes like a seamless blending between the real and the virtual worlds, including digital twins already introduced before in the conference. And it includes the environments, the virtual environments, the elements that are in the virtual and the real environments, multimodal data collected or presented in multimodal IoT sensors, and important, the people, no? People that are teleported or are immersed in metaverse scenarios and interact with the environment or with other people. So that's why we believe in 6G Bricks that metaverse will be a new foundational medium for information access, for human-to-human collaboration, but also for human collaboration, okay? So if we think about use cases, we can think about entertainment and gaming are not the first probably relevant use cases of the metaverse, but now metaverse is relevant for education and training, for smart cities, for smart industries, among other business sectors, okay? Okay, so the metaverse is already a reality, and there are companies and the scientific community researching on this, and the companies making business. But it still contains multiple limitations in terms of interoperability or fragmentation, no? Because of support for different platforms or only a subset of them, or devices, protocols. Also limitations about scalability, because it requires challenging bandwidth and processing demands for the network, but also for the terminals. In terms of ubiquity, no? Because if you need multiple or high bandwidth, probably it doesn't reach all areas that we would like. And in the end, cost, no? Limitations, because it's not cost effective. And if we focus on the users in most of the existing platforms are represented as synthetic avatars, okay? And synthetic avatars are fine, and even they could be funny, no? For some use cases, but imagine, I don't know, interacting with your doctor or your bank account manager, okay? So it brings to limited quality of interaction. That's why in 6G BRICS we are introducing holographic communication platforms, because it gives more trustworthiness, because you know with whom you are interacting with, okay? So we believe that 6G technologies will serve as a foundational technological enabler for the next generation metaverse, because 6G technology will provide improved performance compared to 5G technologies. Performance, we can refer to latency, to bandwidth capacity, to reliability, no? Because if you are supporting or you're providing support for a relevant service, okay, you of course you don't want a poor quality of service. Because of interoperability, because, for example, the network can help you or help your terminals to split computing functions from the terminals to the edge, okay? Or the network can adapt the bandwidth that you need, or that your device can, or your network can support, okay? And also important for us is that when we think about metaverse, we have a lot of cameras, a lot of sensors, we have the headset. So at the end, we have multiple devices with lots of cables, so, and a lot of GPU processing, no? So it brings portability challenges, and that's why we think that with novel self-free technologies, we can overcome these challenges, okay? Because we can eliminate the need for cables and have like high capacity and low latency communications, okay? So in 6G BRICS, we're addressing a collaborative team building metaverse use case, and it consists of two main technologies, okay? The first one is about multi-user holoportation. Basically, it's multiple cameras that capture color and depth and pointing at you, and they can reconstruct in real time the hologram of yourself, okay? So it will look, this video is my colleague Sergi, captured in real time, holoported to a virtual office, okay? And Sergi could be conducting a shared activity with another, and now Sergi will be teleported to a virtual fabric, okay? So it can be to anywhere, okay? Or different use cases. And the second video shows a capture of the POC of 6G BRICS, in which we can have multiple teams of users conducting a shared activity together, okay? And we can isolate these different groups to improve the scalability and to assign them different edge servers. So I talked about shared activities, but what shared activities, no? What activities you could do with others in the metaverse? So they could be multiple. In 6G BRICS, we are addressing like shared media playback, no? You can see me in the image at the top right doing a slide presentation in the metaverse. Okay, there is no virtual screen, but I can project information whenever I want. It can be co-design activities. I added here like a small Lego bricks, but Javi in the presentation that comes will show more co-design or more capabilities to interact with 3D elements, or brainstorming activities in the case that we can have interactive boards, okay? So what we want in this use case is to leverage 6G technologies to avoid what we said, not the need of cables, but also to manage intelligent group-based communications in which we can actually divide the communication and the processing for different users based on their roles or based on the activity that we are conducting. For example, if I'm now the professor, I could be given more priority, no? Or based on their location, both in the real or in the virtual world, okay? Or it could also be based on the device they are using or the next access network they are connected to, okay? Edge computing for us is very important because you can offload processing functions from the client to the edge, but you can also allocate the closest or the most adequate communication server based on where the users are connected to or based on the overall status of the network, okay? Or you could even perform like some transcoding or rate adaptation or also format conversion techniques to overcome the interoperability issues. So this is the testbed that we are deployed at Q11 as Costas introduced. We are now, Javi and me, doing some tests at Q11 testbed. And I will not pay attention to the technical details, but basically we have the UEs with cameras, headsets. We have diverse edge servers to allocate different network or virtualized network functions. And then we have the self-free infrastructure that Costas introduced that we will plan to assess different configurations and to connect different segments of the end-to-end pipeline to show that is a feasible or a ready technology to support metaverse use cases. So we will conduct pilot activities and experimentation activities, and in these activities we will plan to assess key performance indicators, so objective performance metrics like latency, bandwidth, scalability. I don't mean to be exhaustive here, but also what is important for us, key value indicators. Now we want to show that these use cases together with 6G technologies provide societal, economic and environmental impact, positive of course, which includes digital inclusion, trustworthiness, operational efficiency or cost reduction, because you have a digital twin, you don't have the real machinery, you don't have the real environment, so you can replicate as many times as you want. So in essence, that would be my presentation. If you have any question, just feel free to drop me a line, okay? Thank you very much.
Thank you very much for your very interesting presentation, which was quite detailed. Just one question on my behalf. Regarding the final slide of your presentation, the collected KPIs were enough in order to demonstrate the expected, let's say, progress towards a transition for something more than 5G? Mainly that, and this also correlated to the option that these are very interesting applications. Do you feel that these are still mature enough to be offered in the market, or potentially a version of these applications based on the experiences gained to be offered after the end of the project?
That would be our intention. I have to recognize that these KPIs are more focused on the exact service level metrics. Then we have KPIs which are more related to the self-free technologies. Of course, we will also evaluate them. And what we want to evaluate with these KPIs is that with the self-free technology, we can keep the desired quality of service and quality of experience levels that are required to provide successful services that we could go to the market, okay? So the final TRL we still need to assess, but that would be our intention, to develop something that can provide a service that can be really deployed in a wild environment. That would be our goal, yes.
Thank you so much, and thank you for contributing to the organization of the 6G BRICS session with your presentation. We would like now to pass, thank you. I would like now to invite the next presenter, Dr. Javier Montesa from Brainstorm Multimedia, Spain. The presentation is 6G-powered immersive technologies for metaverse-like virtual broadcasting. So, Dr. Montesa, the stage is yours.
Hello, can you hear me?
I can hear you, and we can see your slide. Oh, perfect.
Okay, I understand that you can hear me. I cannot hear you very well. Okay. So if you can hear me, okay, this is Javier Montesa. I work for Brainstorm Multimedia. Can you hear me? Yes, okay. So I work for Brainstorm Multimedia, where we do mostly virtual productions for broadcasters, okay? So we work with many TVs, Spanish TVs, of course, BBC, ESPN. So we are working with many big televisions, right? And what I will present here will be the proof of concept Mario already introduced in his presentation. But in our case, it's about integrating both I2CAD technologies and Brainstorm Multimedia technologies. So what they have, as Mario said, is they have holoconference. They mostly use VR headsets, of course, 3D capture devices, and they put everything in a virtual environment so they can share the environment and see each other in 3D, right? For that, The software they have is what they call the HoloMeet server, which is providing connectivity for all the users online. And also they have their HoloMeet players or clients. But in fact, the most interesting thing I think they have is the HoloMeet SDK, which allows any user or any company to implement clients for their system by their own. And that's what we did. Brainstorm implemented several HoloMeet clients based on this SDK, okay? And here we have some 3D captures, but you already saw them. So what we have in Brainstorm? Well, virtual production. We use a green screen, a camera, we use camera tracking, of course, and then the virtual studio with everything. And then we have virtual virtual production engines like Infinity Set, Aston, or Edison. This is our products, and we have been using Infinity Set in this project, right? So what we did is integrating everything. The HoloConference coming from I2CAT and the virtual production. The idea is to have in a virtual produced program in a broadcaster to have a HoloConference so the audience can see in their TVs a third-person view of this conference. So they can see virtual reality participants or collaborators that are connected remotely to the TV, captured in 3D, not with a very high resolution, but with a very high interactive content. And then also the presenter. You can have a presenter over a green screen captured with 4K resolution, and because you know where the camera is in the studio, you know the tracking, you can have the only case is this presenter, you can have it somehow properly inserted in the 3D scenario, okay? So we are using the 3D capture system for the VR users, we are again using the VR headsets, then the virtual set for the presenter capture, and finally we have the presenter capture, the VR 3D capture holograms for the VR participants, and then we put everything together and have the audience experience on TVs, okay? So this is the scenario we decided to use, a Formula One scenario. Probably every country has this kind of program in their countries. And what we did is, okay, let's have instead of a camera for this POC as a proof of concept that we cannot bring all our stuff into a university, we are using an iPad as a camera, because cameras, iPads, they have a part of the camera. If it is an iPad Pro, it has LiDAR, and you can have a proper tracking for the camera position, okay? So we are using an iPad for picture capture and tracking. We have this virtual studio with the Formula One. We are providing many Formula One parts for the collaborators to take them and analyze them and show them to the audience. Of course, we have the presenter, and then we have the collaborators. Instead of Kinect or these old devices, we are using Orbec cams. This is what I2CAT provides, and we are using MetaQuest 3, and of course the audience a TV. Okay. So this is the kind of result we have. This you need to understand that this virtual studio is professional quality. So this is the kind of view that you have in a proper TV program. But we are inserting this VR participant, and then we can move the camera around and see the participant in 3D in this virtual scenario. Okay. In this case, it's a remote participant with a headset on. Okay. This is the view of the participant. In this case, you have the wheel, the Formula One wheel, and you can go and check different things in this wheel. We have many other elements like compounds of the wheels, then the ailerons or suspensions, everything. You can go around and see the Formula One, okay? And this is the architecture we are using. Mario already introduced some things here, but what we did in Brainstorm was implementing the HoloNative client for the VR users on the left. Then we have also created a HoloNative player for the virtual production side. In this case, the HoloNative player is not intended for a user with a headset. It's more intended to be connected to our virtual production engine and share the camera point of view and share the render, so everything connects and superimpose properly. Of course, we have the edge server with all the I2CAT Holo Orchestrator and Holo Communications systems in order to put everything together. And also in this proof of concept, we are collaborating with Ectacom, who is also connecting to the same system where you can see the VR users, you can see the presenter on TV and everything together, and they are rendering the whole experience in a panoramic view, a 360 view from one point of view, of course, and then they are streaming all this big panorama video streaming. They are streaming it through the 6G infrastructure to as many users with headsets as you want, because in this case it's a broadcast. Of course, all the users will see the scene from the same point of view, the one you decide in Ectacom. Okay. Then the implementations that we needed to do were mainly the synchronization between the HoloMeet player and the Infinity Set engine renderers. So they need to render at the same time from the very exact position. Each engine is rendering different parts of the scenario, the background and the foreground, and each engine needs to deliver to the other one the render. And we are using NDI for the codec, for the streaming, for the video streaming. We have also implemented the HoloMeet. Based on the HoloMeet SDK, we have implemented the client and the player. And finally, we have done all the composition with the talent, the VR participants, the scene coming from Infinity Set, and also the scene coming from the HoloNative player. Okay. As Mario said, we are now dealing with the proof of concept, and we are testing it and trying to measure different indicators. And mostly we are interested on the end-to-end delay. We have also interest on the transmission delay on the network. As we allow to lose some frames in the transmission, we are interested on this rate, how many frames you are losing, and of course the uplink and the downlink bandwidth. Regarding to the KPIs, we want to measure the digital inclusion, the trustworthiness that I can already tell that is very high, and finally the energy efficiency. This is what Infinity Set, our virtual processing engine, renders: the presenter over the green screen with high resolution over the background of the scene. This here is what the HoloNative player is providing, is the table that we will see superimposed to the render. And then we have here the presenter over the background, and then the table coming from the Holo client. And finally, when we put also the VR participants, we have everything together. It is interesting to note that this VR participant is in 3D, and you can rotate the camera as you will around him or around any other you have in the scene, but the presenter is 2D. The interesting thing here is that even if the presenter over the green screen is 2D, we know as we move the camera over the real scenario, we connect the virtual view to the movement of the camera. So it happens to be 3D because you see the presenter from the proper view. Okay, I don't know if I explained it well, but I need to run. So this is more or less how it's viewed. I don't know if you can hear the audio, but it is not. In this case, in this video, we didn't have the integration of the VR participants, so we will see just one episode. But this is the view of one of the participants. This is the virtual production. Instead of the capture, this is the participant. In the next video, it will appear. And let me jump with it because it's a little bit repeating. And then, yes, in this here we can see remote participants and yeah, you can select different items and yeah. So more or less, this is the final result. And if I'm right, this is my last slide. So thank you very much for your attention.
Thank you very much for your presentation. And just one general question regarding the selection of the KVIs. I may suppose you have applied an approach potentially aligned to the Sustainable Development Goals of the UN's, potentially.
Yeah, well, there are different points of view for the KVIs and KPIs. In our case, of course, we are very interested in the trustworthiness, but honestly, depending on the TV and on the program, they are interested in different things. The most important thing usually in broadcasting, more than the bandwidth or the frame rate or any of these values, what they want is the system working 24/7 with any glitch, with any problem. As long as it works that well, all the other KPIs and KPIs are not that relevant for them. As long as they know how it works and they know what kind of programs they can use. Okay.
Thank you so much for your reply, and thank you for joining this 6G bricks oriented session. And hopefully we will have you in a future event to continue the very interesting results you have demonstrated. Thank you so much.
Thank you.
I would like now to invite the next speaker, presentation number 20, Dr. Nikolaos Zafiropoulos from Space Hellas. We have Dr. Zafiropoulos online.
Yes, hello. Hello, my name is I'm Nikos Papadakis, representing...
Okay, so Mr. Papadakis will make the presentation instead. Okay.
Yes. Good morning, dear colleagues. The paper I'm going to present is again on under the scope of 6G brick problems. Here we are going to present a robot-based interaction.
We can hear you quite well. May I ask for the assistance of our control panel? Okay. Okay.
Yeah.
Mr. Papadakis, if you can arrange probably your microphone closer to you in order to hear you better, if it is possible. And please try to access your presentation and start your slides.
Yeah, I have already shared.
We see just the first one. Can you pass to the next one? Normally.
Yes. Yes.
Okay, perfect, perfect.
Right, okay.
Go on.
All right. Just to describe a few things before we go into some technical details about the paper. The motivation here is that we need to somehow establish a quick, fast and reliable interaction between robots and humans. 6G will actually provide us with the latency and the parameters that are needed in order to establish this proper connection. So the introduction is that the robots are becoming essentially manufactured. Okay, but what about 5G and 6G? These are the networks that provide the connectivity and the edge intelligence that is required to bring on board the robot machine in order to overcome limits that are currently present in the existing network. So the goal is to enable personalized, safe and rapid and responsive human and robot interaction. So what we examine here, we are actually examining the use of the reconfigurable intelligent surfaces, that is an innovative aspect, innovative technical issues that is built under the 6G network, which is going actually to drive the signal apart from the fact that we are going to have a reduced network latency. We are going to have a higher throughput and network latency. Okay, we are going also to have this RIS system that will actually support, enhance the real-time collaboration between human and robots. We'll see in the next slides how this is going to accomplish. So all this, just a short introduction, this actually goes under the industry form this DASTI4 context, which integrates the cyber-physical systems, providing the necessary means and actually the way and the facilities to elaborate more on the driven automation. The low latency communication is a key enabler. That is the first KPI that we're actually we're trying to accomplish based on the metrics that are going to be received during the experimental trials. Just a parenthesis here to inform that this experiment is going to be testing under the infrastructure, the 6G infrastructures manufactured by Eurecom in France. So apart from the low latency communication,
excuse me, I interrupt you, but I feel that we don't have good quality of your volume. If you can use a better microphone, because sincerely speaking, we can't hear you quite well. And this is not good for your presentation and for the session. Okay, go on. We can hear you now if you want, but better close to your microphone, please.
Yes, okay. This is based under the window, the industry for context, like I said. So we need to build on the collaboration between the human and robot in order to acquire adaptability and deterministic actually behavior. Some basic things, elements here regarding 5G and 6G. These are the elements that are needed, the characteristics that are actually derived by 5G and 6G networks. Not necessary to go into details here, but let's go again on the architecture itself. Here is the experimental testbed. What we have actually built is going to implement it within the 6G project testbed under the Eurecom platform in France. It combines a cloud-native radio access node, the reconfigurable surface, and the edge computing orchestration. We have the key point here is that we have a robot that is equipped with certain equipment and devices that are cooperating together with the robot operating system and actually drive the robot through human-based commands. This is actually the narrative, the point, the context within we are building the application. These are the components we use: Turbo 4 with LiDAR camera and Raspberry Pi, a 6G enabled model, the Quectel, the one that is the model here, the reconfigurable panels for non-line of sight signal steering, and the control center for monitoring the robot application and actually using the commands, issuing the commands for the robot movement. Okay, the data flow is that the robot captures sensors data, LiDAR camera, and coordinates. There is a data flow established between the robot and the control center, so the data are transmitted over 6E to the edge. This computes the AI inference and the SLAM, okay, and issues the center commands in order to navigate, to steer, to instruct the robot going from one point to another. This is actually the case. We suppose that we have the robot in a workhouse, and automatically we need to instruct the robot going from one point to the other. The latency is to achieve the 10 milliseconds round trip, and apart from the throughput established. The edge of loading network, not not so critical to spend too much time. That's the critical thing is here to enable real-time, the last one, responsible, even in dynamic factory conditions. This is actually the key point when we work with the robots in industry. The reconfigurable intelligent surfaces actually encompasses those things you see here. The key is to ensure the low latency links under non-line of condition. This is actually the point, the concept that the RIS surfaces provide. So in case we need that the coverage won't be so the radio coverage won't be so long within the 6G experimental testing platform. So with these surfaces, we are going to secure the non-line of sight coverage that exists, and actually to make sure that we maintain the exact, the very same flexible and reliable communication between the robot and the control center, which actually plays this role we see here: monitor the robot position, task progresses, the remote commands and the visualization in order to be able to anytime see, monitor and vigilate the movement of the robot within the warehouse or within the environment itself. The tasks between the workstation A and B, the transportation and the moving of the object from position A to position B, and the deterministic operation under both line of sight and non-line of sight scenarios. This is actually more or less the context we are building the applications. There are some experiments that need to be have already been conducted, and we are working on it based on some methods that we have already derived during the experimentation we had a couple of months ago in the Eurocom places in France. Based on these methods and the analysis of the data derived, we are very confident we are going to evaluate and to provide the necessary proof of concept that this interaction, this communication between the robot and the control center is still secure, reliable, and will be eventually evolved in a very efficient way. Conclusions are these: actually, we still believe that we will be able to evaluate properly and effectively the results derived from the metrics that we will derive from the experimental testbed, and these will be included in the relevant deliverables of the projects accordingly. The work was funded under this grant agreement, under the project 6G BRICS, and again, a special thanks to the guys from the colleagues from Eurocom and IQ Quadrat for their support and consultation, and of course all consortium members. Thank you very much, and really sorry for these audio problems.
Thank you very much for your presentation, which gave some aspects regarding the proposed scope of your research within the wider framework of the 6G BRICS project. And now I would like to invite the next speaker, Mr. Yannis Chasiotis from Satways Ltd Greece. Thank you for being with us. Mr. Chasiotis will present the presentation number 21 about AR-enabled remote digital twin for Industry 4 applications within the framework of the 6G BRICS project, and the stage is yours. And thank you for coming.
Thank you very much, Dr. Kokliouros and Mr. Adopoulos. Thank you very much, everyone. My name is Yannis Chasiotis, and I will try to be a bit brief in order to catch up on the timeline. We are going to give you a short flavor, a small flavor of what the proof of concept is all about. As the title states, we are going to be describing briefly the AR-enabled remote digital twin for Industry 4.0 and the concept that is being elaborated in the context of the 6G BRICS project. Sorry. Yep. Now, what this proof of concept is all about is the effort to establish the means for assisting the inspections, namely maintenance operations of equipment in the context of a factory floor, let's say, without having the need to have physically present the experts, the technical experts that would assist the field personnel. In order to have this feasible, to establish this feasibility, the proof of concept makes the use of the digital twin functionality in order basically to bridge the gap between the technical expert and the field personnel, so that they have a common understanding of what the technical problems are all about, and, let's say, optimize this technical feedback provision from the field expert to the field personnel and vice versa. Now, this this task is becoming feasible through the availability of an open run for scalable and flexible network infrastructure, the use of RIS, which ensures the connectivity in non-line of sight conditions. That is a pretty realistic scenario in industrial environments, whereby we have very difficult setups of internal environments. And of course, the proof of concept considers, let's say, a set of technology component inherent to the proof of concept, such as a 6G compatible modem, a mobile tablet, a workstation, and of course a server running the application. In the context of the test consideration as part of 6G bricks, we consider the visual inspection of or maintenance of an electrical bore panel, just for providing, let's say, the general proof of concept, that requires the performance of a specific maintenance task through the exchange of media, video, audio, and text informations between the expert and the field personnel carrying out the maintenance task. And of course, trying through this process to record the visual quality, latency, and relevant KPIs that we are going to be describing shortly. Now, this whole process consists of two primary phases. The first refers to model preparation, or the digital twin of the actual asset, whereby in each environment a process is executed to capture, let's say, the real world and the actual model, and create the actual model of the asset that we are going to maintain. And of course, the second process referring to the on-site delivery of the augmented AR-assisted maintenance process that assumes this set here of equipment, namely the Artemis CMS management system, the tablet and the AR glasses that relay, let's say, the necessary information to the maintenance personnel field of vision. The deployment architecture may be seen here, whereby we can see the user equipment apparatus being in the periphery of the green fields. The green fields indicate, let's say, the equipment provided by the 6G testbed infrastructure, consisting, of course, as you can see, the RIS and the GNB components. And of course, on top, we can see the 6G bricks platform that sits on top of the task and regulating, let's say, orchestrating the whole process. Now, the main components of the actual testbed, as we have highlighted before and as Kostas introduced, encompass the radio unit providing a millimeter wave access network, the reconfigurable intelligent surface, the RIS, for maximizing, let's say, reception at non-line of sight condition, and of course, the necessary 5G modem here provided by Quectel in order, let's say, to establish this connectivity in 5G plus environments. Now, as far as the actual proof of concept is concerned, and as far as the augmented reality part is concerned, the main components are comprised of the Artemis tablet. This is being an Android tablet running the Artemis mobile application and providing the user interface for this exchange of maintenance information. The workstation that is basically hosting the Artemis augmented reality application, and of course the Artemis server providing, let's say, the hosting of the actual web service. These are a few indicative screenshots of how, let's say, the interface and the actual relay of information is being provided to the end user. And here we can see a small set of the target KPIs that we are currently in the process of measuring, encompassing the smooth visual experience, the real-time data delivery, the latency, the coverage, and the bandwidth that is being targeted for ensuring a smooth quality of service in order, let's say, for the maintenance operation to appear as seamless as possible. Before we close, the whole process has been also associated with a set of key value indicators that is, let's say, the latest hot topic. Taking into consideration the nature of the service, we have identified the impact with regards to the business value in the context of the operational efficiency and the cost reduction and revenue generation it entails. The economic growth due to the increased productivity and cost reduction potential again, and of course the new value chains from the point of view that it relates to the integration of stakeholders from diverse spectrum of industries. And finally, the safety domain from the point of view of enabling real-time or near real-time hazard or fault detection and allows the potential for proceeding to predictive maintenance operations and also enabling, let's say, high awareness of potentially difficult situations with regards to industrial infrastructure. Well, having said that, I would like to thank you for your attention.
Thank you for your presentation as well, which was quite detailed and impressive, at least for me. Just one general question regarding the Artemis tablet and solution. This is a product of the company, I suppose? Or?
Yes, parameterized for the needs of the Industry 4.0 applications in order, let's say, to accommodate all this network infrastructure.
If it was something coming from a third party, then my question would be why the selection was like that. But if it is something coming from your activity, so you have the full control and you get the solution.
Mm-hmm.
Okay. Thank you again for your detailed presentation.
Thank you.
And now I would like to invite the final speaker of this section, Mr. Michalis Randopoulos from the Hellenic Telecommunications Organization, OTE. Michalis will give presentation number 22, an insight into the KVIs developed in the 6G BRICS framework.
Hello, everyone. I'm Michalis Randopoulos, and we have prepared the presentation An Insight into the KVIs Developed with Dr. Ioannis Chochliouros in the context of 6G BRICS project. A brief outline will go through the overview of the final KVIs, the selection and why we chose the aforementioned KVIs in the context of 6G BRICS. Most importantly, we'll go through the template description, which was developed in the lifetime of our project, and the representation at EU CNC with interesting outcomes. A few words about OTE's role. We have active contributions to most of the work packages, apart from Work Package 1. The main focus is on Work Package 2, which is the formation of the requirements. Work Package 6 consists of the evaluation process of the KVIs, which we have an active role coordinating all this activity. And Work Package 7 with the relevant dissemination, communication, and exploitation activities. This table summarizes the theoretical framework of the KVIs which our work has been based upon. 3 main subclusters, as you can see: innovation, democracy, and ecosystem. Under those subclasses, we have specific indicators. For example, we have safety under innovation, and safety refers to the ability of a system to avoid human life, the environment, or private property due to its unavailability. This is something that will take place actively in the course of our project. Democracy is about privacy, fairness, digital inclusion, and trustworthiness. It consists of the developments of 6G technologies that will serve everyone. When we say everyone, and those who were historically underserved, those they have to be taken into consideration to access the 6G developments. Finally, we have the ecosystem cluster, which involves more business-related aspects, such as business value, economic growth, open collaboration, and new value chain. This is the selection of final KVIs. Not all KVIs can be illustrated and evaluated throughout this project. So, according to our obligations, we chose 10 different KVIs to be evaluated and described thoroughly. In a few words, use case number 2, which is about 6G applications for Industry 4, will focus on innovation cluster. The use case 1, which is about the metaverse, as it has been explained in the previous presentations, focuses more on democracy, on the democracies cluster, with the digital inclusion taking active place. And the ecosystem and the business-related aspects will take place in both, evaluated throughout both POCs. This is the template description that has been evaluated and developed throughout the works of 6G BRICS. This was a collaborative work with the POC leaders, and the main categories identified in our template are a general definition of the indicator, the aim, what 6G technologies aim at, what is their target, the target groups involved. This consists of all the stakeholders that could potentially evaluate the indicator during the demos. We have, of course, a definition of the societal impact. This gives, in other words, we have to say what benefit does this work bring to the society. Then all this table is mapped into the relevance to 6G BRICS. How 6G BRICS serves all the above. In a few words, this will be explained. Finally, we have the KV indicators, the methods of measurement. 2 main categories were discussed and developed throughout 6G BRICS. We decided to use a metric called objective and another metric called subjective. The objective metrics could involve potentially quantifiable methods of measurement throughout the POC. This will give actual numeric results. It could be the rate of workplace accidents or near-miss accidents prior to and after the implementation of digital twin and augmented reality. This is in the context of safety KVI, as we have mentioned. However, these produce tangible outcomes, numerical outcomes. The subjective metrics or means of measurement could involve the formation and the completion of survey questionnaires by the relevant stakeholders identified above. This is quite, as we said, a subjective means to evaluate how this KVI is actually contributing to the societal impact as we have promised. A deep dive now into the surveys developed. You can see there are very general information at the top of the survey, who is answering. And the questions I have indicated in red involve subjective questions, such as how much it asks the stakeholders, how much do you anticipate for the digital twin to improve operational efficiency in your organization? What percentage reduction in downtime would you expect? We cannot, in the course of a three-year project, actually measure accidents. Please keep in mind that this is a Stream C project. It involves lab demos. Physically, not many stakeholders can access the lab to evaluate such indicators, how much the hazard rate will be improved or other means. The stakeholders are not allowed to access the labs physically. So what we decided is to produce 3-minute demos to judge and try to answer these questionnaires. Our works have been represented at EUCNC last June in Poznan. The main outcome of our presentation is to distinguish, to raise the issue of creating different KVI frameworks for Stream B, Stream C projects and Stream D projects which involve large-scale demos. The works of 60 Bricks leads as pioneer for other projects such as Intense and Sunrise 6G. The same framework will be evaluated in the other project as well. This slide summarizes what we have said. Some POCs, we have to say, are designed to target, validate technological enablers rather than full use case. This highlights the differentiation between Stream D and Stream C, Stream B projects. The lessons learned, what is important and discussed throughout in front of the SNS representatives at the EUCNC conference, is that the KVI methodologies are not at this stage mature enough to shape the requirements of the POCs. In reality, many of the current projects are attempting to, according to the technologies developed, to map technical KPIs to potential KVIs. This is not the right way to go forward. We should revert the process, and we should take into consideration the societal impact and shape accordingly the formation of the technical requirements throughout the early working packages. That would make an impact, and then we can say that we truly take into consideration the KVIs and the societal impact as defined in the UN Societal Development Goals towards the formation of our POCs or use cases. Thank you. That's it from my side. If you have any questions
for this presentation, maybe a comment, not a question, because actually this is a brand new world. The social orientation, together with business and legal orientation, is something new in the form of KVIs, as recently promoted by the European policy. And this is not only for research and development, but affects many policies for implementing solutions in the real market framework. What I would like just to say is that based on Michali's presentation, we have seen a new approach proposed in the framework of the 6G BRIC project, because there is no, let's say, specific or recommended methodology how to implement and how to define and how to assess and how to select KPIs. There are some, let's say, global initiatives like, for example, the UN Sustainable Development Goals, but this is a broader policy-oriented framework, or some European Union's announcements and guidelines, but in particular for the technical implementation, this framework proposed in 6G BRICS, which is also adopted, as Michali said, in other projects, is something new and something quite interesting, because this is the next step from the technically defined KPIs, which are measurable, to some concepts that are not always measurable. And this may be the difference, because somebody may say this is theory. No, it's not theory, it's practice, because this affects policies for funding, this affects policies for priorities and implementation, so it is quite essential and quite challenging. I finalize with that. Thank you, Michalis, for your presentation.
Thank you for the comment as well.
And now we are closing this 6G BRICS session. We will pass to the next one, which is about the ambitious project, Advanced Computing Continuous Solutions for Boosting Digitalization Across European Regions. This is a challenging effort for enabling a fundamental technological infrastructure that will provide advanced data collection and cleaning, analytics, AI-powered forecasting, through transparent continuous computing infrastructure. There are quite challenging issues here. It's about strengthening the European capacities of SMEs companies, promoting innovations and supporting cooperative actions between the industry, the academia, stakeholders and the public sector. As we will see, we have two essential pillars: the AIDA pillar, which promotes data analysis and prediction with the use of artificial intelligence, which is our case, and the Agora pillar, which is about data collaboration and security. Each pillar proposes several use cases, 5 use cases that will be covered in the scope of our presentation for the AIDA framework, which is relevant to data analysis and prediction with artificial intelligence, and 2 more in the framework of Agora. Now I would like to invite the first speaker of this presentation, one of our friends and collaborators through the last few years in the arena of the R&D projects, Dr. Dimitrios Gembelikos from the municipality of Egaleo. The municipality of Egaleo and Dimitris in particular are always with us. They support us. They offered us the possibility to bring to their citizens some ideas, some first results of what we are working together in European projects. And this is also an opportunity to thank you and thank the municipality for this support. So, Dimitris, I will give you the stage in order to have the first presentation.
Okay. Thank you very much. Before I will start my presentation, I would like also, on behalf of the City of Egaleo and the Mayor, to thank you personally, the Dr. Ioannis Kochliouros and his team, and the OTO group for the invitation and for the support all of these years. Thank you very much. Good afternoon to everyone. I am Dimitris Gembelikos from the municipality of Egaleo, and together with Dr. Alexis Kostopoulos from the OTE, we're excited to share our experience from a real surveillance pilot deployed in one of the most iconic green areas of Western Athens, the green area of Barboutadiko. Today, we will look at how modern digital technologies AI, 5G, and the edge computing can truly support the municipality, for instance, the city of Egaleo, in protecting and monitoring a challenging public space. In a nutshell, our pilot is part of the Regional Innovation Investments Program, namely I3. It falls under the ambitious project, a European effort aiming to push digitalization across regions through real testbeds and pilots. The idea is very simple. Instead of keeping innovation inside the labs, the ambitious project brings into a real environment. And that's exactly that we did in Egaleo, testing advanced surveillance, of course with our technical partner, in a genuinely complex outdoor area. About the vision, the project brings together 4 countries, several regions, for example, the region of West Greece, and a diverse ecosystem, public authorities, universities, SMEs, and citizens. The cross-border collaboration allows companies to test technologies early, refine them, and understand how they behave in different environments. For us, as a municipality, it's a great opportunity to be part of a European innovation chain while improving our local services to our citizens. The challenges, the SMEs faces big challenges. The AI is evolving fast, 5G is expanding rapidly, and the IoT is everywhere. Ambitious focuses on these 3 areas where these technologies can make a difference. Surveillance, smart water, and the precise agriculture. Our role is in surveillance, specifically monitoring a large green area that requires constant attention. Regarding the Egaleo pilot, our pilot is located in the Egaleo Grove, known to local as a Baroutadico Grove. It's one of the largest green space in Western Athens. It's full of life, schools, sports facilities, cafes, and the well-known open-air theater, Alexis Minotis. But it also means constant activity, dense vegetation, and high fire risk. So it's perfect for us real-world testbed to see how technology can support public safety and the environmental protection. About the pilot architecture, here you can see that the technological setup at a glance. Inside the Grove, we install cameras connecting through the OTE commercial 5G network. A secure VPN connects the camera to the OTE Academy infrastructure where data is processed and stored. At OTE Labs, we have the VPN server, an SFTP repository for video snapshot, and a GPU server that runs the AI models for fire detection. This creates a complete pipeline from the trees and the pathway of the park, of the Grove, straight to the advanced AI processing. The pilot setup presentation. Before going live, we perform all the necessary groundworks, checking the camera position, ensuring stable 5G coverage, configuring the connectivity, and preparing the environment for the continuous video transmission. Also, this phase is very essential because the pilot is fully outdoors. Sun, shadows, all these environmental parameters, everything affects to the setup which actually took place. Once the physical setup was completed, we moved into a system integration, connecting the cameras, validating the VPN tunnel, ensuring that the data flows correctly. The pilot has 2 main goals: the early detection of the fire, critical for a park of this size, and prevention of malicious or risky activities, especially during hours where the staff municipality of Egalo are not present in the park. So everything will build revolves around these two use cases. This is the heart of the solution. The AI system uses high-quality data sets and objects detection model to analyze the video that come from the real-time capture. The workflow is straightforward. The cameras continuously capture the environment. The AI model processing the stream frame by frame. When it detects smoke or fire patterns, it generates instant notification, and all these events are logged into a web interface. This allows municipal staff, for instance, the civil protection as well as the municipal police, to react very fast, even when no one is in the presence in the park. Regarding now the pilot execution, the next step, now what comes next? We plan to expand the number of the camera viewpoints inside the grove, closing the blinding points and improving the coverage. We also refine the AI models as we gather more data from the real condition. There are a specific technical pattern for this scope. Also, the goal is to increase accuracy and reduce the false alarms. Another important also is the seasonal testing. Don't forget that the park looks very different in summer, winter, or spring, and so the AI technology must adapt. And finally, we want to integrate all this. This is the most important from the Egalo municipality perspective. The system with all of the system to integrate in the municipality command and control center. We have set a new one in our premises. This will allow the civil protection, which actually dedicated department for this purpose, and the municipal police teams to receive alerts instantly and respond faster. So step by step, we are moving from a successful pilot to a fully operational capability to the city. And the last slide, because the time is running, the last one. Sorry, this one. Okay. Now what comes next? We plan to expand the number of the camera viewpoints inside the park, as I said before. We create a dataset creation to support the AI mechanisms. We use also UAV standalone support and UAV mobile application support. Also, we'll try to all the pilot results from all the demo sites to consolidate and evaluate against in a new AI models and agent. That's from my side. Thank you very much for your attention.
Thank you so much, Dimitris, for your presentation. I don't have any comment. You said everything. I just want to say this demonstrates the importance of the introduction of innovative solutions in real conditions, and especially for the benefit of the end users, the citizens here, via initiatives like those promoted by the municipality of Egalo. And if there may be any comment, I may say the municipality itself is able to assess the validity or not of such solutions. Yes. Simply because they make life better for their citizens, and we thank you for that. Thank you for supporting us and giving us the possibility to implement some solutions to serve real needs.
Okay, thank you very much also. Thank you very much.
We will pass now to, in the same session, to presentation number 24, Precision Olive Farming towards Autonomous Pest Monitoring. This is a presentation prepared by PK New Technologies, a very active and core colleague in the scope of the ambitious project. We have Mr. Christos Panagiotou as presenter. Thank you for joining. Thank you for all your support in the project, and we would be glad to hear your presentation, Mr. Panagiotou. We have Christos online.
Yes.
You can join.
Can you hear me now?
Okay, we can see you and we can hear you. Thank you.
Perfect. Let me share my screen. And I hope you can see my presentation as well.
Yes.
Okay, perfect. So, hello everyone. First of all, I'd like to thank the organizers and Dr. Kochliouros for the invitation and for giving us the opportunity to present our work. I also want to apologize for not being able to be there with you in person, but we needed to join remotely due to other obligations, so as to share our progress and activities within the ambitious project. My name is Christos Panagiotou. I'm a co-founder of PK, and today we will focus on our integrated IoT and cloud approach for autonomous pest monitoring in olive agriculture. The ambitious project brings together, as already Dr. Kochliouros introduced, partners working on next generation digital technologies for various application domains, including the agriculture, utilizing Internet of Things, connectivity, cloud systems, and artificial intelligence. PK is involved in three heterogeneous use cases, one of which is the precision agriculture use case that is the subject of this presentation. PK's role focuses on building the IoT infrastructure that is commonly shared among all the three use cases that were involved, the sensing devices, the edge to cloud continuum, and the user interfaces so as to enable modern and data-driven precision agriculture. In the context of the project, we are developing a smart olive tree flies trap, the so-called DACUS, that can automatically detect DACUS flies using computer vision and AI analysis. At the same time, we're deploying IoT-enabled microclimate weather stations so as to collect in real-time environmental conditions. By combining pest presence with environmental data, we can identify patterns, issue timely alerts, and support decision-making. All these data streams integrate seamlessly with our IoT analytics engine, enabling and unifying the monitoring capabilities and the centralized management of the cultivations. I would also need to mention that our partners in Ambitious are also involved in these activities. The University of Patras works closely with us on the analytics and the AI components, providing the intelligence that builds on top of our IoT infrastructure. The region of Western Greece contributes essential the agronomic expertise and connects us with the producers and the actual end users in the field. And of course, OTE supports the project as our telecom partner, ensuring the communication backbone and the consultants for the real world deployments. Moving on to the next slide, the current pest monitoring practices rely heavily on manual inspection of traps, which is in principle slow, subjective, and often incomplete. Farmers lack the continuous visibility of what is actually happening in their fields, and without environmental data, it is very difficult to correlate the pest activity on one hand with the conditions on the other hand, such as the temperature, the humidity, levels of rain, etc. There is also no standardized or a unified system that can combine the biological, environmental, and the historical data of the cultivation. All this results in a limited ability to predict outbreaks and intervene in an early stage, especially for olive trees, which are dominant cultivations across the Mediterranean, the Dacus fly represents the most significant threat, heavily impacting the production performance. Setting up a system like this isn't an easy case. On the technical side, we need clear images outdoors, very low power consumption, and connectivity that works even in the middle of the field. On the practical side, it has to be simple for farmers to install and tough enough to handle the heat, the dust, and whatever the weather throws at it. Of course, we need clean and frequent data so we can run the real-time analytics and send timely alerts with the required precision. All of these challenges help shaping the way we design our architecture. At PK, we tackle these challenges with a fully integrated IoT and cloud ecosystem. We bring actually together smart traps and sensors and cameras with a secure IoT backbone and an edge-to-cloud data pipeline. With this setup, we can automate incident detection, track microclimate conditions, run the real-time analytics, and present everything through dashboards and that make sense to farmers and the agronomists. The whole system is modular, scalable, and built so we can easily plug in future AI upgrades as the project evolves, so as to support the monitoring and the detection of other diseases except for the pest detection. On the cloud side of our solution, things are just as important. Our backend is based on the AWS managed services that handle the entire life cycle of each device, from onboarding and authentication to secure operation in the field. We manage identity, authorization, elasticity, and full end-to-end security, so the system remains reliable at all times. All incoming data, images, sensor readings, the environmental measurements are collected as time series information and stored in time series databases. From there, we run the real-time stream analytics so we can process the events that are produced the moment they happen. The architecture, in principle, is built to scale smoothly. Whether we are supporting a handful of devices that we use during development or testing, or hundreds that are deployed across many regions, the system must and does maintain the same level of performance and stability. Our first version of the Smart Trap is built on an ESP32 embedded platform that is paired with a 5-megapixel camera, along with a 5G modem that supports our communication needs. The whole device is completely energy autonomous. It runs on a rechargeable battery that is powered by a small photovoltaic panel. And with this setup, we are able to validate all the core functionalities, the continuous image captures, the stable connectivity, long-term power autonomy that is required, and the full integration with our cloud services. Deploying these first units in the field gave us a lot of valuable feedback during this first round of pilots, as we were able to test the stability over time, check the camera quality in real outdoor conditions, evaluate how frequently we would make sense to capture the images, and understand how the weather, the heat, and the exposure affected the trap design. All this helped us shape the improvements we introduced in the second version of the trap, during which we performed the full redesign of the mechanical and the embedded platform. We actually introduced now a custom 3D printed enclosure, which significantly improves modularity, allows precise and repeatable camera alignment, and provides a better structural stability for long-term outdoor operation. The new form factor is designed for direct mounting on the tree. This approach eliminates the need for external stands. It reduces the installation complexity and mitigates the shadowing and the angle of view issues we observed in the first version of the deployments. We also integrated the liquid level sensor for the ammonium sulfate reservoir. This actually enables continuous monitoring of the bait level that allows the producer, the user in general, to implement, to monitor the levels of this bait and implement predictive refilling alerts based on actual usage and environmental conditions. Additionally, this redesigned housing accommodates both liquid and dry duct strap configurations, which are available in the market, improving the compatibility with different field practices and regional preferences. Finally, these enhancements significantly increase the system's robustness and move the hardware towards a production-ready form suitable for large-scale field deployment. And this is something that we will actually deploy and evaluate during the second round of the pilots of Ambitious. At this stage, the PK-IoT platform has been validated end-to-end, from embedded sensing and power management to data ingestion, stream processing, storage, and the front-end visualization. The next phase, the second round, focuses on integrating the intelligence layer developed by our AI partners. And this involved deploying the second version of the incident detection models and devices, the integration with the cloud analytics pipeline, and enabling the model-driven event generation based on image classification outputs. All these tests will allow us to evaluate the mechanical stability, the environmental durability, the sensor performance, and data throughput under real operational conditions. The insights from these deployments will feed the final hardware tuning and into the continuous update pipeline for the AI models that we deploy, will support preparing the full system for a larger scale rollout and long-term operational use. And with that, I would like to wrap up my part of the presentation. Thank you all for your time and attention. Everything you have seen today forms the foundation that enables the next major component, the intelligence layer. The related activities with this layer is highly supported by our partners from the University of Patras, who have also prepared the presentation to walk us through the AI models and the DACUS detection pipeline they have been developing during the last period. The work builds directly on top of the data capabilities that we have put in place and completes the picture of an end-to-end smart monitoring system for olive cultivation. So, once again, thank you.
Thank you for your presentation and for the detailed information discussed and presented. In particular, this demonstrates that some solutions are very beneficial for the agricultural section, easy to implement if there is the proper platform, not so expensive, easy to afford. So I expect that this will be, and this is the aim of the project, a new service that can be jointly provided with you and other market actors, like for our case, OTE. This is a great challenge, potentially.
Sorry, but I cannot hear you well.
Okay, I was saying that your presentation was quite interesting because it demonstrated how some solutions can be easily implemented if there is the proper platform, if these solutions are easy to afford, and they provide innovation and opportunities for growth. And we expect that this will be also a commercial product that will be offered in the market with the conclusion potentially of the project. Thank you again. Thank you again for joining. I would like now to invite the next speaker from SAMI private company. It will be about a smart marina case, berth allocation optimization and object detection utilizing AI algorithms. Dr. Ioannis Kostopoulos, thank you for coming, thank you for joining.
So thank you very much, Dr. Kochliouros, and thank you very much for the invitation for today. Good afternoon, everyone. As mentioned before, I'm going to present the specific case that my company is involved and has a specific interest because we are activating in the blue economy and specifically in the digital and smart port marina solutions. So the specific case is called berth allocation optimization and optimization through the use of AI algorithms. I have split my presentation in two parts. The first part has some introduction about our company and why we have a specific interest of participating in the project, and at the same time to demonstrate the data that we have collected in the past and we provided through the ambitious project to the other partners in order to deliver efficient AI algorithms. And of course, in the second part, we are going to the core part of the presentation about our role and what we deliver in the specific project. So a few words about us. Actually, we are a startup. Now we are in a scale-up stage, offering an innovative digital platform that connects sea travelers and the yachting community with marinas and tourist ports, leading the digital transformation of the sector around the globe. The main product that we provide to the market is a fully automated platform that it is consisted by three different subsystems. One, that it is a full platform for the marina management that integrates data from a port as a digital twin service and berth reservation and marina management system. We visualize also the critical ports of marinas areas by collecting IoT and camera data. This is one of the areas that we provide data to the project itself. Also, we do traffic management and process optimization, and this is also the second area that we provide data, but also real-time communication between marina and sea travelers, remote management and paperless transaction, and document management. We have also two sub-products, one related with the docking staff, the staff that it is working in a port or in a marina, and a mobile application that it is provided to the end users. About the product itself, the product itself contains a lot of AI capabilities, and this is the reason that we provide some extra slides here. Our marina management application and also the application that we provide to the end users has online payments, document management services, but also trip planning services that they are using existing LLM models already trained for this specific community in order to provide services about trip planning. But going to the main area of our work and our activity, what we called Marina 4.0, and under this umbrella we can say we participate in several R&D initiatives. We work with berth occupancy monitoring. Berth occupancy, for those that they are not familiar with the term, is like the parking for the boats, okay? This is the name that is called in marina and port. We are also doing vessel detection with AI cameras. So we have trained specific cameras working with vision analytics and taking very important insights about the positions of the boat or the entrance of a port, etc., inside a marine or a port environment. And also we are working with an environmental monitoring, water quality, smart energy and smart lighting in different areas, having an holistic approach under this umbrella of Marina 4.0. We are mainly activated in Greece, but not only in Greece, I can say in southeastern Europe and Mediterranean space. Here in Greece, we cover more than 40 marinas and tourist ports, and we provide also services in the cruise sector in 150 marinas. And of course, we have a strategic collaboration with OTE, having delivered a real project to the market in several key partners like ports in the Ionian Sea, and now we're planning also some other installations outside of Greece. So going now forward to ambitious project, we are among the 18 partners of the consortium, and we work in one of the pillars related with surveillance and monitoring of control areas. That this is the main area that I'm going to present you. We work in these two areas. One is to pilot one, like the vessel detection that I mentioned before. So how we exploit the existing data and we train more the cameras in order to give a holistic approach about and insights about the position of a boat and also the characteristics and features of the boat. Okay, so during our past activity, we have installed in several ports cameras that collect in real-time data about the entrance of a boat or the traffic corridors in a port. And having all these data sets, we trained algorithms, and thanks to the ambitious project, we create on-demand annotated image datasets, feeding specialized AI algorithms for enabling accurate object detection. By that, let's say, technical phrase, what we mean is that from a single and simple detection of a boat, now we're moving forward to a detection of all the features of the boat. That means that we can detect the type of the boat, if it is a sailing boat, a motorboat, a catamaran, or a rubber boat, etc., that it is very essential for the port authority. Also the size of the boat, and in some cases we can have some other critical issues like possible collisions inside the marina or a port area. This is also related to vessel detection, but in the work areas that we have done until now, we have updated the existing UI UX to include the vessel detection outputs and all these features that I mentioned before. We have updated the boat detection mechanisms along with our partners, University of Patras, and also the other involved partners in the specific working package. Data sent via dedicated APIs to the AI detection algorithm that we have specifically designed. We await for the AI detection algorithm to give the output, all these features of the boat, and then we can display the boat type and category in this new UI that we developed. And last but not least, to create notification mechanisms for the marina personnel on arrival and departure of boats or other critical notification that affect the operational efficiency of a marina or a port. The second area is the berth allocation optimization. The berth allocation is one of the major problems in marinas and tourist ports, is the way that we manage the berth spaces in order to have an optimized results and maximize the revenues. So again, we pilot these services to Patras Mega Yacht Marina, where we have also some cameras already installed and sensors that are doing the berth occupancy. As an input, we also gave historical data for berth occupancy sensors because this specific harbor is a client in the last 6 years in our company, and also historical data sets of berth bookings. And as output services, we design berth allocation optimization services through specific AI-designed berth allocation algorithms based on a preset rules that have to do with the pricing policy between periods, the occupancy of the spaces, the size of the boat that we detect before, etc. So as an output, we get that on-the-fly berth space reallocation proposition. So at the time that a boat is coming, to give proposals about the optimal berth space based on the vessels and berth spaces real-time data. We have also propositions automatically feed the SAMI's digital twin, our existing platform digital twin Marina module, in order to visualize and to give us intelligent tool, let's say, to the administrators and the staff of the marina, finally enabling the dynamic decision-making for the marina administrator and staff. Here you can see the work that we did is the new, let's say, version of the UI UX that we include berth allocation outputs, data exchange via dedicated APIs to the berth allocation modules, communication with the AI algorithm results to test the dynamic reallocation, incorporation of AI-generated berth reallocation proposals with the API, also display of this information to the marine, as you can see, with the name of the boats, of the typology of the boats, and the better visualization. And finally, to allow the administration to review and confirm, because the last decision has to do with the human, especially in these areas, because it is an open areas, open environment, so we need the collaboration between the machine, the technology, and the staff for the berth proposals. This is the my last slide, is illustrating the status of our work. So we have done until now the two-thirds of the work of the berth space optimization service, 75% of the movement boat type detection service that enables the boat type detection, as I mentioned before. Almost 90% of an updated UI UX experience for the marine administrators, including the new services that they are designed. And of course, as I mentioned before, staff is critical. The upskilling and skilling of marinas personnel following the presentations and trainings that we have specifically designed. So this is it from my side. I would like to thank you very much for your attention, and we're happy to complete the next year the project, and of course to follow up to new endeavors and initiatives. Hopefully, yes.
Findings in real
exactly.
Market offerings, because indeed what you are doing is quite interesting. It's a new market, interesting for all of us, because we all travel, we all need to have these sort of facilities, more or less. And there is no dedicated bibliography or work, as far as I know, for this specific use case. You are pioneers in this area, at least at European. I will not say worldwide. I would like to say at European level, at least.
This is evident, and speaking about our economy and our country, I think it is one of the areas that we have a competitive advantage, because we combine technology with a strategic sector that it is tourism, is the yachting and coastal tourism. So the combination of this can give us an advantage to go also, of course, to our country and support our country to the digital transformation, but also to move forward to other countries and to resell the products and the innovations that we develop. And with OTE, as I mentioned before, we have a strategic partnership. We have already completed 2 operational projects in Greece, and we are now designing also some others for the near future.
Thank you again for coming and for your support.
Thank you very much.
Okay.
Thank you very much.
Now we'd like to invite the next speaker, Professor Spiros Kontogiannis from the University of Patras. Following to the presentation we have already heard, we will hear about AI-enabled optimization algorithms for berth allocation and smart agriculture. Spiros, are you online?
Dr. Hochliuros, this is Christos Panagiotou from PK.
Yes.
Since this is a joint effort, Ioannis Panaretou will present the
Okay, no problem. We just need, we know you are working together. You can have the stage and make the presentation on behalf of the University of Patras. Go on.
Okay, I will present you the second part, which is the smart agriculture DACUS detection, the AI work that the University of Patras implemented, and when Ioannis Panaretou have resolved his technical issues, he will continue, hopefully before I finish my presentation. Give me one moment to share my screen.
Just one favor, just try to be within the prescribed time slot to the extent possible, of course, of 10 minutes maximum. I say again, to the extent possible.
Sure. Okay, so we will continue with the computational part of the DACUS detection that is based on the infrastructure and the technology.
Excuse me to interrupt you. Is it possible to pass to full screen?
Sure. Let me try again to share my screen instead of.
If not, okay, but.
This is the correct screen?
No, it's not full screen, actually. Yes, now it is.
Okay. So,
but it is too big. Yeah, now it is.
Perfect. So, the objective is to have a real-time detection of the olive fruit fly DACUS based on the processing of the captured images. There is already an approach implemented. It is based on the YOLO deep learning model for the olive fruit fly detection and count of the objects that are detected. We have been investigating this approach, and the University of Patras extended it with 3 new methods that it is based on YOLO as well. So there is already a dataset published, the DERT dataset, where several images from DACUS traps have various a variety of density of the presence of DACUS. The crucial part of this new method is that we have used randomization in the data augmentation. This approach and this solution offered us a larger versatility and resulted in a higher accuracy for our framework, since we managed to extend somehow the data set and do a more thorough training of our model. Here you can see the whole pipeline, starting of course with the training data set based on DERT. We performed the yellow mean color normalization as an image pre-processing step, and then continuing with performing flipping and shifting and rotating the dataset so as to augment our dataset with more variations of the images until the final detection of the flies and the counting of the population. Here you can see a snapshot of an actual image captured from the DACUS trap, and how the implemented approach detects with a certain confidence the insects on the image. Here you can see the performance, which scores quite impressive, as in most of the relative indexes, the approach performs more than 90 and 93%. Moreover, a very significant enhancement of the approach and the existing solutions is that now we are able to identify not only the insects that are captured in the trap, the population, but also the gender. Capturing and identifying the gender is quite critical, since the agronomists and the end users are very interested on not just knowing the population of the insects, but their gender as well, since this highly affects how the insect threatens the cultivation. Again, this is something that we managed to deliver, the colleagues from the University of Patras, with high accuracy and confidence as well. Here you can see how the presented work performs compared to the existing work of the literature. So we can say that we have more than 80% in most of the relevant indices. So this is the AI part, the computational part, the intelligent component of the DACUS detection system. And it complements all the whole use case and how we approach it in the context of Ambitious, and we plan to validate it during the second round of this use case. So this part of the presentation is completed. Thank you very much.
Yes. We can hear you. Will you continue?
No, the second part must be continued by a colleague from SAMI as more.
Do we have the colleague from SAMI? Probably. If not, we will pass to the next presentation. In any case, all presentations will be uploaded as we do. And so potentially every interesting party will have access to the material, and also the live streaming will be uploaded as Smart Press always does. Okay, if not, we can conclude with this presentation. Thank you for giving us these important pieces of information. Thank you for supporting us also via this way for the organization of the yes. Okay, I have the information that Mr. Panaretou has just joined, so we can hear him for the second part. Okay, we were ready to close, but everything goes.
Hello, can you hear me?
Yes, go on.
Okay, sorry for the delay, but
no problem. The most important is you are here, Dr. Panaretou, so the stage is yours.
Okay,
Just try to remain within the strict time framework to the extent possible, of course. Thank you.
Yeah, I will be quick. I want to let me just a moment to share my screen. Give me a moment. Okay. Can you see my screen?
Normally it appears that you are trying. Yes. We are here.
Okay. Good day. Today I will present an optimization approach for one of the most critical problems that we face in port and marina management, the berth allocation and the scheduling problem. This research is conducted in the context of the Ambitious project by the ICE lab of the University of Patras, and specifically by the professors Kotogiannis and Zarouliakis, in collaboration with their team. The objective is to use intelligent algorithms for berth allocation and scheduling, a problem which has a direct impact on the operation of modern ports and marinas. The berth allocation and scheduling problem aims to provide a service schedule for each arriving vessel, offering the optimal berthing position and mooring time, while avoiding collisions and adhering all spatial limitations. The top image, you can see that there is a non-optimal assignment where the disorderly placement of vessels creates dead gaps, that lead to vessels remaining outside the port. In the bottom image, you can see the optimal assessment we want to achieve. Vessels are intelligently sorted in space and time, so as to see more vessels serviced at orderly time. The goal of the research is to minimize a linear combination of the critical parameters of customer discomfort and acquire less waiting times, delays, and penalties for the marine. So the methodological approach to solve the problem, the team examined three categories of algorithms: the exact solvers, which calculate mathematically optimal solution, but they are extremely time-consuming and resource-consuming. And several heuristic techniques, different techniques that have been tested, which provide suboptimal but extremely good solutions and faster. Specifically, the team studied the constructive heuristic algorithms that they build a feasible solution incrementally, handling the vessels one after the other, and allocating each vessel in a available berthing position, but without disturbing the previous allocated vessels. This is an extremely fast method, quick and dirty solution of acceptable quality. The improvement heuristics algorithms, they try to improve a given schedule of all the vessels to berthing positions in a trial and error fashion. They are still very fast, better quality than the solution provided before. And the meta-heuristic algorithms that involve either a single solution or an entire population of solutions in an adaptive way, mimicking various natural selection processes like the cuckoo search, the genetic algorithm method, and the adaptive large neighborhood search. These are fast solutions of extremely good and almost optimal quality performance, even in difficult cases, but still keeping faster, almost as fast as the exact solvers solutions. So the contribution of the team involved the design, implementation, and the experimental evaluation of the following algorithms. Three constructive heuristic algorithms: the nearest neighborhood, the insertion, and the Q&D. Two improvement heuristic algorithms: the swap and reinsert. And three meta-heuristic algorithms: the CSA, the GA, and the adaptive large neighborhood search. To train and test the model, the team created a synthetic data generator for berth allocation and scheduling problem instances, which mimic the characteristics of a real-time, real-world actual instances. Using publicly available real-world instances for the Piraeus cargo terminal, a few vessels among 11 and 13 having to be served simultaneously. Synthetic datasets were created for various sizes of vessels with discrete vessel berthing positions, different draft, length, dimensions, etc. So the data set size varied from 45 vessels to 10 pairs up to 100 vessels and 25 pairs. And now the experimental results of a 1 week schedule. The team examined scenarios with increased load, 45, 70, 90, and 100 vessels. And for data sets of sizes 45 and 70, we see that the constructive heuristics algorithms in red, they require a few microseconds to provide solutions of good quality. The meta-heuristics, they require a few seconds to provide solutions of good quality, but also very fast. And the exact solver, which is in purple, we see that even if after 3 hours, we cannot find the optimal solution. For the larger sets of ships and berths, we have almost identical measurements, with the conclusion that the meta-heuristic algorithms, and primarily the ALNS algorithm, offers the ideal balance. Actually, they are almost as accurate as the exact solver, but run in real time, which is very important for our case. This is all by me. Thank you very much for your attention.
Thank you for providing us this information, explaining the essential, let's say, composition of the related algorithms in order to realize the expected solutions. Thank you for joining. We can conclude with the ambitious special session, and we will now pass to the next session. There is a presentation that will not take place. We pass to session number 7, which is about cybersecurity challenges in the modern era. Our session is structured around the CyberNemo project. This will be initiated and coordinated by my colleague, Mrs. Maria Bellesiotti. Maria, I can give you the stage, actually. And by the way, I would like to say that this is a quite interesting research project because it is practically the continuation of a previous project called the NEMO. Now this is called the CyberNemo. It aims to infuse end-to-end cybersecurity and trust in the IoT edge cloud data computing continuum. It will offer end-to-end and full-stack protection issues, and this is around several pilots, but I will let Maria to give more detailed information as an expert in this action.
Okay, hello from my side. Thank you all for being here, and special thanks to our presenters to follow. CyberNemo has to do with IoT edge cloud continuum. So we will analyze all the cybersecurity framework that CyberNemo deals with. The IoT market has, in the last decade, has seen a great explosion, starting from 10 billion devices at 2020 to 20 million devices in our days, and it is expected to reach at about 55 billion in 10 years from now. The reason behind all this is the limitless capabilities of IoT technology, its low cost, the energy efficiency that has to offer, and of course the devices which are the heart of IoT ecosystems. All this result to IoT to be used in a lot of markets, such as manufacturing, smart cities, smart agriculture, smart energy, and with the use to be expanded even more in the next years. With the arrival of AI, the next logical thing to make IoT more useful was to integrate AI algorithms to IoT technology. What AI had to offer to IoT was to make devices more intelligent. And this was succeeded with when AI algorithms were added to devices and allowed them not only to gather data, but also to be able to analyze them, to process them, and to make intelligent decisions autonomously without human intervention. So, from AI, we have now come to Edge Cloud Continuum, which integrates and organizes and considers the computing and network resources from across different infrastructures. And starting from IoT endpoints and reaching the cloud. The deployment of such a continuum, of such a network, is very demanding and has many technical challenges. Among them, there are security, privacy, and trust issues. And this is where exactly CyberNemo aims to interfere. So, the heterogeneous devices from different actors, from different owners, from different vendors, the diversity of networks, which the different APIs, the different applications used, the weak authentication authorization, the lack of encryptions, the vulnerabilities of firmware and software that could lead to compromise the whole device. The insecure communications are posing several security challenges in the continuum, and they are paving the way to many phishing attacks, malicious attacks, DDoS attacks, many threat challenges that can compromise an IoT network. Another big issue is the attack surface, which continues to expand. With the term attack surface, we consider everything that the continuum, every segment of the continuum, either it is physical, either it is application, network, device, human, every segment that could be compromised is part of the attack surface, which is always expanding with the addition of an application, a user, or a network. So, as we can understand, the need for end-to-end trust and security is a necessity and must be achieved in some way. So, CyberNemo consider all these issues, the transition from IoT and the rising cybersecurity threats, and try to create, let's say, and protect the continuum segment, since it considers every segment as not trusted, with an open framework, try to protect all from end to end, all segments of the continuum in IoT. Its vision is to establish itself as a paradigm towards cybersecurity, IoT, and edge cloud continuum, and to introduce an open framework for supporting resilience, awareness, detection, and risk mitigation in critical infrastructures and supply chains. So, in this session, we will see more details about this project, the use cases, the architecture, and the open framework that CyberNemo has to show. And I would like to invite, let's say, our next speaker to give you a better overview of the project and its, let's say, vision.
Thank you, Maria, for giving us this detailed introductory framework for the motivation, the challenges, and as you said, you are coordinating this session with me. We have Dr. Artemis Voulkidis from Synelix Solution. Synelix is the project coordinator, and so we expect, as Maria said, to have a more, let's say, a global view of the full set of the activities of the project. And thank you for joining.
Thank you very much. So, hi all, I'm Artemis Voulkidis, as was introduced. I would also like to thank you very much for the organization of this event. And I would also like to thank Maria for taking part of the introduction that I was going to make. And now I have more time to deep dive into the, let's say, details. So, I'm Artemis Voulkidis. I'm part of the coordinating team of the project, and I work for Synelixis Solutions. So, a bit of the project identity. I don't know whether I'm misaligned. We started this year, October 1st, 2024. So now we are in month 14 of the project. It's a quite big project of 6 million euros, spanning over 11 countries and comprising 24 partners, as you can see on the map. Now, Maria offered a quick glance on the motivation of the project, which essentially is to secure the AIoT edge and cloud continuum, or the computing continuum, as we call it in the project. And with, in difference with the other projects of today's presentation, we are kind of focusing on the critical infrastructure side. So the project is a security one, rather than a computer continuum. So what we have done is that we have assumed that the continuum exists. We leveraged on another project that was called NEMO. And what NEMO did essentially is to enable multiple clusters talk to each other and migrate information, applications, exchange device information, and also introduce, let's say, in a homogeneous way, artificial intelligence. So what we did in CyberNemo, and what we are trying to do, is take all this NEMO paradigm, as you can see here, and apply cybersecurity on top of the applications, the data, the artificial intelligence properties, the devices, as well as the clusters themselves. So once we do that, essentially we transform NEMO into CyberNemo. That's the whole concept. To increase the awareness, preparedness, detection, and risk mitigation indices, as well as the resilience of critical infrastructures operating on top of the computing continuum. So how do we do it? This is the high-level view of the CyberNemo high-level zero-trust architecture. So with gray color, you can see existing technology, let's say off the shelf. And with the blue color, we can see technology that is offered by the NEMO project. So everything that's not gray or blue is part of the CyberNemo. And following a bottom-to-top approach on the lower side, let's say, of the architecture, we can see that we have the zero-trust network access layer. Essentially, what it does is comprising a set of components. For example, regarding virtual network microsegmentation. So if we identify that there is, for example, a compromised payload, limit its connectivity into a segregated virtual network so that, for example, we may install there honeypots to detect better what is the threat that is under exploit. We have a zero-trust network access controller for identifying network access and limiting it based on the role of the components. We have network topology attestation, as well as modules related to distributed lateral movement detection. Now, going a step up, there's another big group of components related to the cybersecurity situation perception, comprehension, and protection framework. So essentially here we have a decision support system that gathers all the information from the lower side and applies AI assisted with LLMs mostly, as well as traditional machine learning, to identify what is exactly the risk or the threat exploited and hence manifested attack currently under my system. So this is a decision support system, and this is backed up by a number of detection components like the cybersecurity NS, the firewall as a service. We have components for AI-assisted or AI-driven Kubernetes networking policy management. Moving on next, we have a PRESS framework. So PRESS stands for Privacy, Data Protection, Ethics, Security, and Societal Framework. Essentially, this one implements data loss prevention mechanisms at the computing continuum, so at federation level. And then we have another big and important layer that is related to the knowledge sharing platform that we have. It's called SAM. And this enables effectively organizations to share information across each other in a controlled and secure way. Mostly related, for example, it could be related to the EU Cybersecurity Act and the EU Cyber Resilience Act. Comprising as well SAM, also an auditing, certification, and accreditation framework, so ACA. In what sense? In the sense that we would like to have audited applications and services running into our clusters. So another layer of security related to certification and auditing of the services. It's not all that. We have many more, like homomorphic encryption, zero trust, federated machine learning. We have XAI and many more components as well. But these are the core, let's say, concepts of the project. So how do we do it? This is a layer architecture that we showed before. Currently, the project has deep dived into the concrete, of course, specification of the architecture, which is based on ISO 42010, revision of 2022. So essentially, what we're doing this time is having a lot of diagrams regarding all the relevant viewpoints of the architectures, the stakeholder views, the concerns, and all the elements that are attributed and documented in ISO 42010. The concept of all this, of course, is to have all these components that we mentioned before, so that in the end, we may have a concrete risk assessment framework that is also reactive, and it's heavily based and compliant, I would say, with ISO 31000. This is going also to be detailed in a presentation a bit later. Now, concluding the presentation, and with the focus on the piloting and the technology validation activities of the project. These are quite extensive, so we have 6 pilots spanning 5 countries and 8 use cases over 6 verticals. So we may see that, for example, we have a smart media use case in Spain. In Italy, we are checking on CyberNemo technology in the context of smart energy and smart water, so energy and water utilities. We have healthcare scenarios as well as smart agriculture. And last but not least, we also have a consolidated, let's say, cluster that also enable cross-critical infrastructure cooperation and information sharing in the context of the sharing platform that I mentioned before. So this is it, more or less. Thank you for your attention, and I would be open to any questions you might have right after the session. Thank you.
Thank you, Artemi. The next presentation will be from Dimitris Skias from Net Company Intrasoft. CyberNemo SAM, Pan-European Knowledge Sharing, Risk Assessment, Threat Analysis, and Incident Mitigation Collaborative Platform. Thank you, Dimitri.
Thank you, Maria. Hello, everybody, and thank you for inviting us and having the opportunity to present our framework in InfoCom World 2025. If we move... So now we will try to shed some more light on the SAAM framework. It has a quite difficult name. So it concerns a pan-European cross-critical infrastructure, knowledge sharing, and risk assessment tool that will also provide incidents mitigation insights and recommendations. So, yeah, looking at the CyberNemo functional stack, if we move to the top, we see the placement of this framework, which aims to make available the insights and the findings of CyberNemo to third parties and to CyberNemo stakeholders. It digests information and cybersecurity events that are detected by cybersecurity baseline technology and also state-of-the-art AI and XAI tools and threat detectors that are deployed within the CyberNemo framework. And this information is digested by SAM framework, and we try to propagate it to the interested and eligible stakeholders so that we can enrich our findings with additional information. Yeah. So there is a quite comprehensive regulatory and legislative framework that we need to consider in order to build an effective knowledge-sharing framework that concerns the cyber threat intelligence sharing. So just to name a few, for example, we have a cybersecurity strategy framework that concerns to invites us to build, let's say, a shield or a network of cooperation between security centers, cybersecurity authorities, and if I can, let's say, drive some conclusions on all these frameworks, is that we need to promote collaboration and coordination in order to effectively defend against cybersecurity threats. Also, since it is indicated, for example, in Cyber Resilience Act, we need to promote a sort of certification for the tools and the devices that are on board in such systems, including CyberNemo, so that we can trust, at least on a design level, these solutions and adopt them into our systems, thus trying to protect the security of the perimeter that each system tries to protect. Cyber Solidarity Act, for example, again, tries to give us information, insights, and regulations on preparing and responding to large-scale cyber incidents. And there are a lot of other, such as, for example, AI Act, which also tries to put give us the framework of the proper using AI technology. Having, for example, the human factor incorporated into our solutions, for developing the systems, and of course, giving detailed thought for the data governance aspect. And NIS2 is not that new. Again, here we promote knowledge sharing, and this is something that it is our framework aims to realize. If we see some more information about the functional operation of the SAM framework, from the bottom up in this figure, we can see the various critical infrastructures that the CyberNemo instance is deployed and detects cyber threats. This information are collected by the SAM framework. We collect cyber threat intelligence, and also we facilitate the federated learning paradigm by providing aggregation capabilities to a federated learning scenario. So weights of trained models are also shared and returned back to the participating entities. In return, the outcome of the SAM analysis, collecting all this information for the participating entities and critical infrastructures, we create actionable alerts, mitigation countermeasures, and these are communicated to the critical infrastructures. Various technologies for security, such as blockchain and DLT, are part of the communication model adopted. Let's see here a little bit some information about sharing. So knowledge sharing, especially when we're talking about cybersecurity threats, we need to address on standards. We need to incorporate standardized approaches, which in return promote interoperability and accessibility of our solutions. So it is quite important. It was mentioned before by Artemis how much we focus on standards such as ISO. And here, again, we'll try to realize and understand what is already available and how we can promote this work through our work as well. So, for example, sticks and taxi can be used to communicate messages to the interconnected cybersecurity authorities, and MISP galaxies and relevant sharing protocols and platforms can be used and will be used by CyberNemo. Another property that CyberNemo adopts is called trusted circles that form sharing groups. So, since CyberNemo is cross-border and also cross-domain or domain agnostic, if you please, for cybersecurity incidents that it processes, we need to form properly defined sharing groups so that we can communicate messages on one hand in a secure way, but on the other hand in an effective manner, so that we can understand better the context in which we receive and we send events, information and insights, so that we can make better use of them. Through the cooperation of third parties and stakeholders and competent authorities in the context of the SAAM, we build on top of high quality information that are collected, and we try to gain insights by leveraging on AI and XAI tools and suites that will be built for CyberNemo SAAM. Again, a keyword that is important for us, and it is in some cases overlooked, since we are focusing on technical aspects of our developments, collaboration and cooperation in all aspects, in information sharing, it is crucial for an effective system. So it is something that we try to remind ourselves and incorporate into our design. So after all, what SAAM plans to achieve, it plans to be deployed and create some detected events from critical infrastructures and also interconnect with cybersecurity authorities such as ISAC and CERT. This information will be further analyzed in a collaborative and coordinated manner through the AI XAI tools to create high-quality EU and pan-European now CTI data. And at the end, to be able to provide some insightful recommendations that would enhance the cybersecurity and the security of the critical infrastructures that are participating in the schema. Quite importantly, the SAAM platform will have a visual environment that will put some effort to make it intuitive and usable, so that we can reflect the status and the network operational status of the critical infrastructures that are participating. We put a lot of effort to align our work with the current contemporary EU cybersecurity regulatory framework. As I said before, we will use and we use secure and standardized communication protocols and data models, including attack and defend taxonomies such as MITRE-1. Last but not least, SAAM is also incorporated with an auditing and certification tool. This is also aligned with the regulations that we mentioned before, that concerns the certification of the services that will be onboarded in such systems and on IoT devices. So this is another critical factor that was created just to address particular recommendations of cybersecurity regulations. And it is also incorporated to the SAAM, where it will be validated, as mentioned before, in 5 different countries and in CyberNemo instances that will be deployed there at the validation stage of our project. Thank you very much. Thank you for your attention. I saved a minute and a half. Thank you.
Thank you very much, Dimitri. The next presentation, it will be remotely from Dr. Per Meiser. I don't know if he's online.
Yes, I'm online. Can you hear me?
Hi, Per. The presentation is entitled AI-Empowered Risk Management for Cybersecurity.
That's right. Then should I share the presentation, or will you share it for me in the meeting room?
We will share it.
Okay.
Presentation number 31. E31.
I cannot hear the messages if the microphone is not used.
You can
tell me something, then I need to have it.
Can you see the screen?
Yeah, I can see the screen.
Okay, you may begin.
Yes, thank you. Thank you for the invite. And are you still seeing the PowerPoint? Yeah, there it is. Good. Thank you for the invite and opportunity to give this presentation. As you probably understand, I'm part of the CyberNemo project, and we have been working on a methodology approach for how to deal with risk management in a situation where AI is all over the place. So please go to the next slide, please. So in a situation where AI is linked to the IoT, and AI is on the edge, and AI is on the cloud, and so AI could be all over the place in a complex OT environment or in a larger infrastructure. We would like to investigate how can we deal with efficient risk management. The situation is that the vendors that is creating the systems that is placed in the IoT, they will be monitored by cybersecurity mitigations. And those systems, again, will create valuable input to the risk management process. So if you click one slide, we have then established a process for how to deal with risk management that utilize AI to do the different risk processes. And this is a granular scale, because in some of the processes related to risk management for cybersecurity risks, it's maybe easier to do the automation, and in some you need to still have man in the loop, or it's hard to do the automation as such. And also, as mentioned, there is a need to do different kinds of certification, and the certification part, there are activities of doing certification efforts in the CyberNemo project, but DNB is also part of another EU project which mainly look into how to automate certification of ICT products according to the EU AI Act and Cyber Resilience Act and such. So we play with these two projects into this bigger scene. So please go to the next slide. So we have a situation where we have the different risk process steps according to ISO 31000. We copy that one, and the rationale for that is that many of the legislations that we would like to be compliant with is also inspired or very closely linked to ISO 31000. But 31000 is a guidance for risk management, but it lists a lot of principles. And the framework is very valuable for us. So what we do, or what we have done, is to create a method where we investigate each of the risk steps that is listed in the 31000, and investigate what will happen when we introduce AI to support us in this risk step, and what information is needed as input, and what information is needed as output. So if you click one more time, we will test this for each of the trials in the projects. That some of the trials have been mentioned already by the other presenters. For each of the trials, we will test out this method. We will test out the different CyberNemo tool supporting the risk method, and we will investigate if the method, the tools, and the data created is helping the trials to perform better on risk management, perform better on vulnerability detection, and in risk management in general. So the next slide, please click one forward, is illustrating the 31000 risk process, which many of you probably have seen this figure before. By using that process, we generate an information repository or a risk information model that is created and used by the different CyberNemo tools. And of course, then the risk owner can visualize the risk picture in different visualizations. For example, a bow tie, which is shown here. What we have learned is, if we go to the next slide, is that there will be different levels of or different degrees of automation. We currently have a situation where we manually create the input needed to the risks processes, and that the information that is then created is output from one process and input to another process. Then we start to use different kind of IT and AI systems to support us or automate the different sub-processes or the full processes of risk management. But there could be a situation where there is still a person that receives this information. The next step is that one system creates an output that is risk process automation, and the next system, which is also part of the risk process, is yet another system. So we have a system-to-system interaction as a data value chain. And then we need to rethink a bit, because we should have a human in the loop here. So the fourth illustration is when the human in the loop is overlooking the orchestration. So this is a figure that is inspired by the current thinking related to AI agents. So we believe that different AI agents will be a good way of illustrating this. And the next figure is what's happened then in the bigger picture. If you click one slide ahead, then we have the situation where we have a conformity process that is to be done to validate towards the Cyber Resilience Act requirements, or the EU AI Act requirements, or the EAC 62443 requirements, depending on what is the aim of the conformity assessment. And we also have a similar setup for the risk management, where both the risk management and conformity assessment is driven by AI systems or AI agents. And each of these agents, they consume data and they produce data. So we have this cycle of the triangle where we have AI systems, we have data, and we have a process. And seen from an auditor point of view, since the company I come from is typically the third party or the auditor, give the last click on this slide, please. Then what we see is that we as an auditor, we will receive, if you click one more time, please. We as an auditor, we will be interested in the data part. We as an auditor will not necessarily be able to investigate fully the AI systems. We will not have all the interviews with people that we are used to have. So the auditor role will change, and the preparation for audit will change, will be much more data-driven. So the trust that has used to be between auditor and people, an auditor reading the different documents, now the trust will be much more related to the AI system that creates the data and how to evaluate the data that is sent to the auditor, evaluate the strength of evidence, strength of how can an auditor trust that this data is really telling the truth. So when AI at the auditor side is doing the certification and audit of AI used at the vendor side, then we have AI investigating AI. So that's the challenge in the future that we need to move towards and try to solve. So that's the risk challenge in this project as we see it. So that was the high-level presentation on the current challenges and thinking related to the risk methodology and how that fits to the mitigations and the systems that we build in this project. That was all for me. Thank you.
Thank you very much, Per. The next presentation is recorded, is by Dr. Rosaria Rossini from Eclipse Foundation of Europe, and it is entitled CyberNemo Open Source Approach.
And I'm here for talking about open source and CyberNemo. I'm Rosaria Rossini from Eclipse Foundation. I'm a serial research manager, and I'm the leader of the open source commitment in CyberNemo project. Looking at CyberNemo impact creation and outreach plans, we have several points, very important points that this consortium will consider. Exploitation and sustainability plans, dissemination, communication and training activities, contribution to European CI security policy and standardization, continuous socioeconomic analysis and business model, and open source ecosystem and community building. The objective for CyberNemo and open source strategy are twofold. The first one is open source best practices. It means implementing a framework for good open source practices, including professional governance, IP license management, to efficiently manage the creation of exploitable open source projects where needed, and substantial contribution to existing projects when appropriate. On the other side, we have the community building approach and the community building vision. That means participation to events, in community events, production of open source specific communication material, contribution to relevant marketing channel, and organizing thematic workshop or webinar or event dedicated to relevant developer community. From Eclipse Foundation, that is the leader of the open source ecosystem community, we can start understanding why the communication is the cornerstone. Communication is the base of everything, because communicating what you are doing is important for you to form a community. A community is important because the community can sustain your project and leads that to a sustainability for your code and your project. Having a good sustainability means that you can go for the exploitation of your results and of your project. Looking at that, let's start digging into community building and best practices. CyberNemo will follow the SEED approach. The community building SEED approach is an acronym for Share, Embrace, Engage, and Develop. It means plant the open source seed and grow your community. But let's go letter by letter. Let's start with share with your community. You need to communicate. Communication is the cornerstone, so you need to communicate what you are doing. And CyberNemo has social media, blog posts, and as a web page, and of course, it's about code, so you need to have a complete documentation of what you are doing. And you need to work on that in such a way that you can share what you are doing. In this way, CyberNemo is using Eclipse Research Lab. That is a process in which you can have open collaboration and open source best practices that leads to the sustainability. It's part of dissemination communication as well as exploitation and business model. You can find the Dissemination Research Lab in the GitHub of Eclipse Research Lab. You can find the link in the slide. Let's go on with the first E, that is embrace other community. It means go to conferences, organize local events, interact with user group, meet other community. You need to understand your community, you need to meet other community and share your idea, your code, your results. In this method, Cybernemo participated to the Open Source Community Day that was in September this year, and it was an event for meeting other community. And we have the second E, that is engage your community. It means organize workshops, webinars, hackathons, and challenges. That means to gather feedback from others, identify some early adopter, and share your results and your commitment to the open source. In this way, we have the community building event that will be in April in Belgium, 21st to 23, that is the Open Community for Research. Cybernemo will be there with other communities, and you can participate with talk dissemination and attendees. But let's go on with this open source community experience. You can find everything online. Let's go on with the last letter, that is D, develop your community. It means promote success, support issue, and answer questions. So be there for your community, be there for people that wants to know more about what are your results and what you are providing to the community. Means communicate. Communication is the cornerstone. So open source is a journey, it's not a destination, and this is a journey that we are starting in Cybernemo with all the partners. And I will thank you for the attention, and I'm glad to answer some questions. Thank you.
We would like to thank Rosaria as well. Last but not least, Mr. Luigi Brigulio from Cyber Social Lab. He's going to present ethics and regulatory governance framework toward the compliance by conception development. I don't know if Luigi can hear us.
Good morning. I'm sharing with you my presentation.
Hi, Luigi.
Hi.
You're going to share the presentation? Okay.
Yeah. So let's start. First of all, thanks for inviting me to this relevant event. I'm Luigi Berguglio from Cyber Social Lab. Cyber Social Lab is a partner of Cybernemo. And this presentation is dealing with ethics and regulatory governance. And we will discuss about how we go toward a compliance by conception development. So in this presentation, I will talk about what is the meaning of compliance by conception development, the ARC framework that we are adopting in the project, and finally, how we move and we proceed from principles to the requirements that are driving the development. When we talk about the main objective of the project, Cybernemo, we enhance the ensuring compliance of the project.
Sorry, Luigi, we cannot hear you very well.
Can you hear me now?
Okay.
Can you hear me now?
Speak closer to the mic.
Okay. Maybe now it's better. Yes or not?
Yes, better.
Okay. So we are going to ensure the compliance of the project since the early stage of the project. And this is done by adopting the definition of compliance that apply in DevOps or DevSecOps paradigm. This is coming from the ISO standard that is also shared with the IBC and IEEE, the 32675 2022, where compliance means continual fulfillment to internal and external requirements, rules, and regulations. Therefore, we cannot perform compliance if we don't perform it since the conception and not at the end of the development. Therefore, CyberNemo established and adopt a methodological framework to continuously monitor and assess development with respect to EU values and rules. And this is called the Ethics and Regulatory Governance ERGO framework. ERGO supports the project to perform the continuous assessment, identify concern and challenges, select suitable ethics and regulatory principles, such as safeguards and guidelines, and provide requirements and tools. In order to do this, during the first part of the project, the first 3 months of the project, CyberNemo performed a baseline assessment to gather and collect data on activities, technologies, data management, and personal data. Here, we report also a part from the deliverable that is a sensitive deliverable, so it cannot be published at all. But we extracted part of the information that is anyway aggregated and anonymized. So we are not sharing personal or confidential information. Mostly of the project is is not using personal data, as you can see, mostly 74%, while just a small part, something like 26% of the project is using personal data just because they need it. And as you can see, the proprietary format are just a minimum set of the format used in the CyberNemo, so just less than 9%. They are necessary to ensure specific protocols in the communication between the specific IoT devices. Then, if we see to the top 4 technologies, we can see that machine learning and artificial intelligence are representing the most relevant technologies. Blockchain and IoT are also relevant technology used in the project, and also data spaces. Therefore, based on this information, we performed an analysis and we identified 23 challenges and concerns corresponding to 5 macro categories and corresponding to respective principles to be followed. So we can see categories dealing with personal data, data from IoT, data sharing in spaces, confidential data, and AI and data. All of these challenges are corresponding to a specific regulation from European Commission and Parliament and Council. We are dealing with the GDPR, of course, so when we deal with personal data, Data Act when we deal with IoT data. Data Governance Act is the main reference principle for data sharing in data spaces. The NIS2 for the cybersecurity aspect, and the AI Act when we deal with data in AI technology. So, according to this analysis, we identified guidelines and requirements, and now we are also working on self-evaluation checklists that allow the project to check automatically during the project development the main concern and identify countermeasures. So we identify the consent form, or we suggest to not use it. It is forbidden to use personal data in blockchain because this is against 2 main articles in GDPR, the right to be forgotten and the right to rectification. A blockchain doesn't allow you to perform a rectification of data or a deletion of data. So a right to access their own data, because these are coming from Data Act, how to perform data sharing, ensure the interoperability, the transparency, and the security concern relying to the Data Act, but also the authorization to the use, so according to ground agreed upon rules between the owners or the handler of data and the user. The adoption of a risk-based data notification for the confidentiality, for the sharing of confidentiality data. So according to this new, we checked also that we are not infringing the AI Act and specifically the no prohibited AI practices. We are considering the AI just for cybersecurity purposes, considering also the quality, the transparency, the human oversight, and the literacy. Just to provide you with a concrete example, so going in practice, you can see here how from the challenges we identified the regulation, how the requirements are specified, and also guidelines to implement this specific requirement. So it is not just a high-level requirements, but providing also implementation details. So in conclusion, what we can do is we can say is that compliance cannot be a process performed at the end of the development, but is a continuous process since conception. The compliance can be achieved without risk and additional effort if and only ethics and regulatory requirements are established at and embedded in the development process. The ERCO methodological framework support compliance in DevSecOps and is still using this project ERGO framework, and the additional tools are going to be defined for self-evaluation. So that's all from my side. Thank you for your attention. If you have any question, I'm fully available. Thanks.
Thank you. Thank you, Luigi. Are there any questions? This was the last presentation of the project. I don't know if there are questions in general for the project. Okay.
Just allow me to summarize that we have the CyberNemo dedicated full session. We have seen the challenges initiated by Maria and the framework. Then by Dr. Voulkidis, we have seen the exact context of the project. Then we passed to risk assessment and risk management issues presented by Mr. Eskias and Dr. Misert, and we have seen the open framework according to the Eclipse Foundation policy as presented by Dr. Rossini, and finally we have seen these issues by Mr. Bigulio covering ethics and other wider aspects of the project. Thank you all for this very interesting session. We will now pass to the next session, which will be about the 6G Path project. And presentation number, yes, and okay, just a few words. 6G Path, as you will see also in the presentations that will follow, it's an initiative intending to promote the way towards 6G. How? Via dedicated and selected use cases directly coming from the market, as you will see, and via trials where they will lead to results, and those results will be translated to dedicated KPIs initially and then KVIs in order to...
Sono io che ci assisto. Se mi dici la roba, ma dai, ma leggo gli altri.
I beg your pardon? Okay. So this is a quite interesting initiative because it comes directly from the market. We have a dedicated session which covers 2 among the 10 initially proposed use cases. The use case where OT is involved is about automatic logistics. You will see the first 3 presentations, and finally you will see our approach for smart management for applications in agriculture. So I will start the presentation, number 34, which is about automated logistics in the 5G era as an effort to identify the framework where our OT use case jointly with ACTA Ltd is taking place. So I get to the stage in order to proceed to the presentation. So this is a layout of my presentation. I have several slides. I will come to more details one by one. So actually, we are discussing about logistics. It may be evident for some people, for some other, not quite evident. It's a broad business. It takes place internationally. It affects a great variety of activities. The challenges are global, as I mentioned, because we have many legal entities, in particular companies, trading internationally, intending to improve efficiency and resilience of the logistic processes, and so related technologies will have a high potential towards that effort. Continuing our discussion, also in the framework of globalization and manufacturing, because we identify the dynamics of this potential part of the economy. As I said before, global trends towards automation and digitalization affect logistics. This has also to do with international trade, innovation in economic potential, investments, the removal of trade barriers that apply a new framework internationally. Also, the development of what we call as industry 4th generation. Some people have started discussing about industry 5th generation. Maybe it is too early, maybe it is not, it is the time. However, this means that according to this liberalized and competitive framework, there are also opportunities for the industrial section. So we are facing challenges because of the introduction of the IoT, Internet of Things, which is strongly connected to 5G, as we will see in logistic management. The combination of IoT and modern technology like big data, cloud computing, and the core of our today's workshop, do not forget AI, allows for improvements and optimization in many processes. The question may be why and to which extent, and the reply will come to the next slides. But before that, just to focus also on the business potential, if we consider the joint transport and logistic, not only logistic, this implicates for high dynamism. It affects macroeconomically both developed and less developed countries. This domain may influence several technological advancements in information technology, vehicle autonomy and connectivity, drones, and many more. And this is quite important because all these beneficial uses that characterize, if you remember my first presentation during the event, offered by 5G technology, we will go further, are features that can be included and support related activities in the combined transport and logistic area. Modern studies demonstrate a value of billions of dollars till now, with options for further development. And the option of including the dynamism and the features coming from 5G via network applications may be also beneficial because we can have benefits like abstraction of complexity of the underlying 5G infrastructure, reduction of the service creation, optimization of and the utilization of 5G resources. So this is an option in order to promote ways for innovation in the market. So in order to have a view of what we face in the future is the fact that logistics practically bridges physical and digital work. Combined effect of 5G and IoT allows the digital world, allows the information to enter the digital world in digital form, which is quite necessary. When we have data, we can have machine learning and artificial intelligence. Also combined with blockchain, with extended virtual augmented reality and other issues. So these are all opportunities, but still the question remains, why and how, in which way? Okay. And probably part of the answer comes here. Because of the inclusion of 5G, we can have intellectualization of logistics transformation, automation in warehouses, networking, extended networking with so many possibilities. And some of the benefits, 5G can offer options for making all processes more accurate and easier. Supports new applications, as I said before. It enhances automation in all activities. And so supply chains may be able to handle greater sets of data, and this in real time. This is a feature supported by 5G. We can have connected vehicles like drones, trucks, robots that support and enhance activities. Connectivity, as I mentioned before, becomes greater. Vehicles can cooperate and interact and potentially create swarms or fleets of vehicles for supporting these applications, and we can have more accuracy and enhancement in all potential related actions. Automated guided vehicles in modern warehouses. Why? Reply is given here. Numerous reasons. Flexibility, able to rotate in the environment, can navigate easily, help for the reduction of errors, support options for safety regarding the involved human personnel. They can be operated without the aid of a central control, low expenses, perform transportations in an automated way. They can work for long hours in extreme climate conditions, can handle various loads, collaborative work as fleet or as swarms, depending on the selection we are doing. I think these are some convincing reasons why these AGVs that are supported by modern technologies may be initial options for having beneficial uses. And so what we say in this slide is the fact that these become parts of the connected ecosystems in smart warehouses. With embedded IoT sensors, these guided vehicles can communicate with warehouse management systems and enterprise resource planning platforms, real-time data exchange, 5G and edge computing enhance their performance. When we have integration of AIs, these actions, the above actions, can be done automatically in real-time conditions. This is the general framework, and now a few words about the project 6G Path. I will try to give just the main ideas. An ongoing project, 29 partners from 13 European countries, 10 use cases initially, an ecosystem that has been extended via financial support to third parties via the inclusion of 2 extra test beds. We have initially 7 test beds for the trials, plus 2 additional ones following to the open call of the project, 9 fully automated with detailed assets and exact resources. As I mentioned in my introduction, this is the scope of the project. I won't repeat it. promotion, transition towards beyond 5G via KPIs and KVIs that will come via the test beds, where we have real use cases covering 4 verticals. These are the verticals, and this is the case where our automated logistics come in the smart cities. And in order to give the stage to the next speaker, what we intend to do and what we are doing here is, first of all, the fact that considering all theoretical and practical aspects I mentioned before, you can make the translation as you wish, it's up to you. For me, both may stand, is the inclusion of what we call before as the vision of Industry 5 principle in the smart cities, the exploration of automated logistic processes by the inclusion of automated guided vehicles, the design of an automating sorting process to reduce the time required to organize the produced goods, and of course, beyond 5G and 6G networks can play an important role in that action. This is more or less a repetition of what I mentioned before. And finally, just an overview. Logistics is a very important activity for making and realizing global businesses. The combined transport and logistic area may be critical for the macroeconomic development. If we consider IoT technologies with other innovations like AI in particular, this may be the critical issue to optimize current logistic bases. This combined vertical is a key adopter of 5G technology. Automated guided vehicles can be the critical factor that may transform warehouses to smart ones. This allows for the inclusion of AI opportunities, and just we have made an initial presentation of OTs jointly with ACTA, automated logistic use case that will be presented in the next presentation. And we have a video for the next presenter, please, that will give more details following to this framework. The video will be presented by my colleague, Mrs. Christina Lessi, who unfortunately had to leave earlier. So I leave you to hear her presentation.
In this presentation, the Beyond 5G architecture that implemented in the framework of 6G Path Research Project is presented, as well as the key technical solution that we propose for the needs of the logistics sector. The first step in order to design and propose a proper solution and the characteristics of the network is to identify the needs of the sector. In our case, we focus on the needs of a warehouse. In a warehouse, products may change location multiple times, so it is important to optimize the route and minimize the waste time while moving these products from one location to the other. Additional information is also needed, such as the room temperature, since some products might require specific conditions. Taking into account all this, our solution includes the use of robotic vehicles. These robots will send and receive a large amount of data, and the network should be able to support its operations. The advanced networks promises to support the demands of such services. 5G networks were introduced to enable operating models with networking characteristics that enable added value services, not just to redesign the production line. Additionally, it supports better network performance, for example, high reliability, high availability, and high throughput, and combined with cloud computing, we can achieve high degree of autonomy. Finally, it supports slicing, which will be described later on in more details. Making one step forward, Beyond 5G introduces the AI as part of the network functions, increasing accuracy on the decision and data analysis and provide faster response. As I mentioned earlier, the solution proposed to include the use of robots. These robots will allow the reduction of the delivery time, and they could also reduce the need for employees to manually transport heavy goods. Robots will move autonomously in the area. However, in case of emergency, a human operator would take the control. Robots would be able to send and receive data and analyze network performance, so in cases when network is not available, robots could store and process data locally. The network characteristics that support these operations are the high KPIs, the full area coverage, and the automated slice changing process. In this figure, you can see the network design. There are 4 main components. 5G core, which is based on standalone release 16 architecture. RAN, which uses new radio technology. Cloud infrastructure, and slice manager. Testbed also allows internet access and supports secure VPN connectivity for service developers to access cloud infrastructure and install applications and services. As I mentioned, slicing is a feature supported by the network. Slicing is useful as we could manage resources and introduce sustainable network processes. At the same time, UE, which is in our case the robot, is able to request resources, request slice chains, and ask for information. Slice Manager is the key component in this mechanism. It sends information when there is an update about the existing slices, for example, or one extra slice is created. And it also sends information after a request from an external orchestrator. And when we talk about external orchestrator, we mean a component that is not part of the network infrastructure. And here we can see in more details the exact mechanism. The components that take part are the slice manager, an extra internal orchestrator, and the monitoring tools. The orchestrator gets information about the available slices and their parameters, their configuration, and the information about each user equipment in which slice it is registered. It gets real-time data from the monitoring tool, and then it scans some criteria that are installed in the orchestrator. For example, a criterion could be if throughput is 90% of the available throughput, then change slice. When this process is completed, the orchestrator sends the request to Slice Manager for slice change if needed. The network that was presented has been implemented and tested. In this figure, you can see the robot management system, where here you can see the image from the camera that is installed in the robot, as well as the map of the area designed by the robot while moving. So, to sum up, our target was to integrate 2 new technologies, robotics and beyond 5G networks, to provide solutions to the logistics sector. By achieving high network performance, these 2 technologies combined could be very useful in this sector. Thank you very much.
Okay. Following to this presentation, we will also continue by inviting Mr. Panagiotis Verios from ACTA. ACTA is a collaborator and a supporter of our effort in order to realize our activity in the automated logistics use case in the 6G path framework. So, Panagiotis, the stage is yours.
Thank you very much, Dr. Hochliuros. Now we're going into the use case description, which is the Beyond 5G network in warehouse logistics and network validation platform for the smart cities use case, a part of 6G path, one of the use cases of 6G path. To not lose time, we go next to the next slide. So the automated logistics quick overview is refers to a smart cities use case which addresses automated logistics implementation. The use case investigates how robots in the form of AGVs can improve production process and employee safety for use case stakeholders, that's warehouses. The robots, through a beyond 5G network, move automatically, map the environment, perform path planning, bypass obstacles, and stream high-definition video to the warehouse operator located in a remote site. The robots are simultaneously carrying order components. The use of robots can potentially reduce order assembly, delivery time, reduce order errors, limit the manual effort in moving heavy objects, and minimizing workers' risk for injuries. All these are achieved by exploiting and validating the integration of large-scale extreme IoT edge cloud scenarios supported by OTE's 5G standalone testbed. The key players are OTE as the testbed owner and ACTA as the use case champion. Oops. Okay. What we demonstrate through this use case is the responsibilities of and the task operated by the robot. Issuing commands to direct and control the robot for performing specific tasks. In case of unexpected situation, the emergency intervention. Data verification to ensure the seamless and errorless reception of sensor data and camera stream from the robot to the AGV control application. Analyze and evaluate network performance metrics, latency, packet loss, jitter, etc. The 5G lab, the Hotel Labs 5G infrastructure, as it was mentioned, is the Beyond 5G mobile network at Hotel Labs, which has capability of new radio and slicing. And the performance capability of this pilot network are being monitored and validated using ACTA's commercial network KPI validation platform, which is fused with the open source ELCM platform developed by 6G Path project partner University at Malaga. Now, the network monitoring tools equivalent used are a central network performance management system, which composes of the Viavi Fusion applications integrated with analysis dashboards and network probe control functionality. Network segmentation validation is done using the probes and the control panel traffic. A multitude of probes are deployed, both hardware and software. The project developed ELCM platform, common for all use cases, can combine the commercial platform functionality above with open source features, since KPI measurements, the raw data, from the probes are being delivered through a Kafka interface. The integration of ELCM with the Fusion through the Kafka interface goes through from the commercial solution that gathers 150 matrices from various points of the live network and performs automated real-time collection and estimation of selected network KPIs. The automated selection is 24/7, 1 minute monitoring granularity, and 10 milliseconds sampling granularity. This raw data is passed on to the ELCM application, which where experiments are defined and the data are presented in the Grafana environment. In the Fusion, Viavi Fusion application, the flows, the tested flows are visible in a tabular form, and they can be expanded in the two directions of the measurement, which is the one way and the other way, plus the overall end-to-end and both two-way application. Here we can see packet loss, latency, and jitter data presented for all the measured paths. KPI and KVI and results. The application, these applications that we mentioned before gather the KPI matrices, and here are examples of latency and reliability. Because we have probes within the network in various locations, we can identify which part is, let's say, the optical part, and which part of these values are the radio part. And from the analysis, we see that the radio part has, let's say, the worst latency, etc. values. And we're looking into, in cooperation with OTET, into improving this radio part and utilizing the slicing mechanism to switch over to a better location, better values. And the KVI indicators have been gathered through questionnaires from warehouse experts and employees, which have provided useful feedback to understand this environment and notify which areas can be improved or are essential for improvement. The initial analysis of the responses indicate there's an increased expectation of the use case, resulting in improvements in the working environment. Some remarks and next steps are that the successful integration of KPI measurement originating from the commercial environment to the project development ELCM solution gives us the opportunity to indicate this as an innovation. The introduction of slices in the 5G network will satisfy the requirements of the robot applications compared with other services, which have less demand of the telecom network. To investigate further the need of additional network performance KPIs, perform demos and showcases of scenarios to obtain additional stakeholders' feedback, and experimentation at optimizing tasks like order assembly and inventory cataloging and are under examination. So up to now, the project has performed the installation, pilot presentation, scenario implementation, and scenario implementation to stakeholders. So the next step are improving through the feedback from the use case and the measured KPIs and KVIs, improving the whole environment, and having additional showcases to stakeholders to proceed with final analysis and reports. Thank you very much for your attention.
Thank you so much, Panagiotis. And we will pass now to the next presentation. I will give the next presentation in order to investigate smart water management in agriculture. Presentation 37, if I remember correctly. Okay. So as I mentioned before, this is the final 6G Path session presentation. It's about water saving for modern agriculture, which covers, as you will find out, the farming vertical, one of the 4 core verticals of the project. These are the contents that I will cover, some very fastly, some with more details, some general concerns. Water is an indispensable factor for life and for our society and economy, as it is energy and food. Demand for fresh water, energy and food will increase over the next decades, as we expect, under the pressure of economic development, urbanization, international trade, climatic change, cultural, technological changes, and many, many other factors. So actually, the management of water is, and of the natural resources in particular, it is quite important. This has a direct impact on the preservation of the ecosystems, so in food production, in agriculture, and in a wider framework. Okay. It is not, okay. What we see here, we see that the water systems have sustained agriculture since the ancient time. The resource of water is not inexhaustible. There are limits to the availability of the water, and so it is essential to apply specific policy measures. And first of all, the governments play a critical role on that in setting water policies and establishing rights to the resource and in providing infrastructure to convey water to users. Also, environmental policies, together with agricultural policies, may influence water management in agriculture. It is an essential part for agriculture. It is heavily dependent on water. More than 70% of available water it is used for agriculture activities. However, as mentioned here, it is a resource vulnerable to a number of challenges like pollution from pesticide residues, heavy sedimentation caused by soil erosion, and also overuse, which is a very critical issue. As I mentioned before, 70% of freshwater withdrawals comes for agricultural purposes. So it is essential that it is necessary to promote some solutions to preserve water, to preserve the use of water to the extent possible. How? As you will see, via the inclusion of 5G and modern technologies. And this trend is expected to be increased by 2020. Just a few words about the policy framework, especially in the European Union. There is a strategic view of the use of water. Water protection is a priority subject in many public agendas, as well as in the essential core of the European policies. The main overall objectives is the one you can see here. So it is quite necessary to identify that the European Union promotes an option of a public good instead of an option of a resource for which only business or commercial aspects may be taken into account. What exists, just for your information, we have what we call as the Water Framework Directive, which provides the general framework for the avoidance mainly of over-irrigation and reduction of pollutions and measures for keeping the water clear. This complements some previous European regulation for this area. Quite important is what we call the Common Agricultural Policy, which is a set of measures since 1960, well known as CAP, which serves European Union's needs for a resilient, sustainable and competitive agricultural sector. So apart from preserving water, we must find some ways to support agriculture for the benefit of the European Union and for global options in particular. And finally, among the other issues, we have the European Green Deal, which promotes some environmental-oriented solutions in order to reduction pollution. It is aligned to the UN Sustainable Development Goals, something we heard many times during our action, and we can see that all these policies are fully aligned to United Nations initiatives. The question here may be by the audience, why you are mentioning this? This has nothing to do with technology. And I may say, no, you are totally wrong, because this is the policy framework which supports some actions. This is the European policy framework which supports a proper handling of the water for irrigation purposes, and we must find some ways to apply, to respond to that. What the ways will be will come our reply to the next slide. So here, as I mentioned before, we intend to avoid water stress. We must find some smart water technologies. The reply will be via the use of sensors, information, communication technologies, ICTs in particular, in order to provide appropriate responses to the use of water for irrigation. And the challenge here is to decide when to irrigate, the amount of the water needed, and the frequency of those actions in order to be effective. So we involve new technologies like IoT, as I mentioned in the previous use case, big data analysis, artificial intelligence, cloud computing, remote sensing, and many, many more, supported by ICT technologies. The sensors can be used to collect data on weather, soil, air quality, and sending to the cloud platform for the analysis. Then artificial intelligence or machine learning solutions analyze those collected data to predict the water needs. Sensors monitor, in particular, the soil moistures, temperatures, and nutrient levels. Precision irrigation systems deliver water directly to the roots to avoid excess of water use. And also, some weather-based controls use local weather data to adjust watering schedules and provide more opportunities, more enhanced opportunities. So, from the previous slide, it becomes evident that the communications network may become the backbone of the digital agriculture. These networks may enable real-time monitoring, automations, and data-driven decision-making, which is very critical. We expect that the farming industry will require integration of AI, machine learning, and sensing capabilities. And beyond 5G or 6G, networks will play a critical role to that action. Now again, as I mentioned before, comes the role of the 6G Path project, the composition of the project with strong market presence, 12 SMEs, 5 major industrial players like OTE, Airbus, Hewlett-Packard, Telefonica, Orange, all together. This is the core aim of the project, just for the contextual continuity and the use cases, the verticals where we have identified here the water saving, and now some short discussion of what we are doing. We have the water saving use case, aiming to automate the decision-making process for localized irrigation. This takes place in Malaga, in Spain. We have implementation on beyond 5G technology to allow the instantaneous treatment of large volumes of data. The main objective is to acquire and store data, monitor and control the plot of fruit trees, and create a real-time information database. How? We have these specific goals: create a network of sensors and actuators, test the water demands in avocado crops in situ via three dedicated scenarios, monitor the phenological state of the crop through images and videos that will be collected by using drones, and then the images will be uploaded to the cloud using 5G technologies, and then AI and machine learning will come and support options for prediction. From the technological point of view, just keep in mind this slide where we have usage of three concurrent slices. We have an enhanced mobile broadband slice in order to provide greater bandwidth for the transmission of drone captures. Because we, for the control of drones and for any other agricultural machinery, we implicate an URLLC slice. And because we have many sensors, battery-powered these sensors, and many connections, we use a massive MTC slide altogether. This was the core for the creation of the 5G in particular, in previous 3GPP recommendations. All these three are used in our use case. And these are the scenarios. Just keep the notes. Avocado irrigation, just to use sensor in order to identify when, how, and to which frequency we use water for the irrigation purposes. Avocado water scarcity, we have selected some trees where we reduced the water used for irrigation purposes, and we want to see by monitoring one by one the trees of the farm, which is very critical for the use of drones or other modern equipment. And monitoring the avocado phenology, a drone sends images in real time, as I mentioned before, and we obtain parameters to control the hydric status of the plants. So, how we perform our actions, we have several KPIs like video resolutions, data transmission, video transmission throughput, remote control throughput, and others that allow us to monitor the proper realization of the previous scenarios. You can find the information, and consequently we have identified some KPIs about cost savings, increasing yield, which is the challenge, and energy intensity of agriculture, which is also one big challenge. So, to conclude, water is necessary for the agricultural purposes. In the European Union, there is a dedicated regulatory framework promoting proper and efficient use of water. It is essential to consider modern IT technologies and 5G and beyond 5G and other options and facilities like AI, machine learning, in order to make the way we monitor and we manage the farming activities automated and practical. And this was a use case promoted by the 6G Path project. You can find more information in the website of the project and concerning various publications, presentations, and so on. Okay, I finalize my presentation here. Thank you for your attention, and we will pass now to the next session. Thank you, Michalis. We are running towards gradually the closing of this workshop. We pass to the next session, which is dedicated to the 6G DALI project, a very interesting project. You will find out why in the introductory presentation that will be given by Professor Christos Verikoukis from Industrial Systems Institute Athena, and also Christos is a professor in the University of Patras. So I give the stage to Christos in order to see the approach of the 6G DALI project.
Hello, good afternoon. Again, thanks for the invitation. Give me a few minutes to share my screen. 2 seconds, sorry. Okay, here we are. Once again, thanks very much for the invitation to the InfoCom conference, for all these interesting workshops organized by OTE and Ioannis. I'm Christos Derikoukis from ESI Antennas, and the aim of this presentation is to give a brief overview of the 6G DALI project. Okay, this is the outline of my presentation. We'll start with the motivation. We'll go through the objectives, the pillars and the architecture, the innovation streams, and I will conclude this presentation with the proof of concepts of this project. The main motivation is that all 6G proposals, architectures, solutions, algorithms are based on AI. And when we are trying to develop a solution, we are facing one of the biggest problems, that there is no data. AI is based on data from operators, data from experiments, and the quality of data. First of all, we don't have the data is not, there is no available data from 6G, and the quality of data is also questionable. Then we decided to propose this project, and people who need data should come to us to check our infrastructure, our facility, our data space, and find the adequate data. In case of we don't have it, they can order some experiments and generate their data. So we built the first European AI framework for 6G data spaces, and this is an SGU project. We addressed the call of stream B0108, the budget around 6 million euros. Project coordinators, Theodore Chakikouni and myself, while our technical manager is Vasilios Theodorou from Indraco. The main objective: to build the first European end-to-end AI framework that aims to connect 6G data with verticals, ML developers, experimenters, and we're relying on 6G testbeds from different SNS projects. The idea is to bring together three communities from three different disciplines: experts on the design and experimentation of 6G systems, experts on AI and MLOps, experts on data ops, and the GaiaX. The idea is to collaborate to build an efficient, realistic, and trustworthy framework for AI ML experimentation for 6G. We are 13 partners from 7 member states, 4 research centers and universities, 5 large companies, including 2 big operators, and open source vendors like IBM, Viavi, and Intraco. And finally, 4 SMEs that support the development of the proposed solutions. The main objectives of the project is to deliver a user-friendly end-to-end AI framework for data ops and MLOps, deliver GaiaX and ALT, extract load transport approaches for data ops in 6G environment, streamline 6G testbeds, trustworthy AI MLOps via MLOps and AutoML, pluggable adapters to easily integrate new testbeds to 6G testbeds. For future call, for future SNS projects, build and integrate a digital twinning testbed to generate representative large-scale data sets from 6G, to evaluate the ethical issues of this approach and how this data will be acceptable by the society. We need to check different legal issues and, of course, dissemination, communication, exploitation. We have different innovation streams in order to develop this project. We develop AI-based data cleaning, data augmentation solutions. We'll develop collaborative MLOps and RLOps solutions for trustworthy AI via ML model, data detection, and data augmentation, trustworthy reinforcement learning via natural language assisted explainability, develop digital twin for large-scale CG experimentation, knowledge transfer automation for multi-party ecosystem of CG testbeds, LLM-enabled AI experimentation and hyperparameter optimization, and finally, federated learning for NWDAF operations for CG privacy and efficiency. For the concept, we have two main pillars: AI experimentation as a service via MLOps and RLOps, and for the data and analytics collection storage via DataOps. For the first pillar, we develop distributed MLOps open source software, and we have AI as a service and an AI as a service framework for CG experimentation, while for the second pillar, we will develop GaiaX-enabled CG data space connection with the CG DALI framework, trustworthy AI solutions, and we check the societal acceptance of these solutions, digital twinning, testbed for large-scale experimentation, and then core network data analytics and federated learning for NWDAF. Here is our architecture. As you can see, we have the testbeds. We have an adaptation layer between the testbeds and all these MLOps and DataOps solutions. And with the non-bound interface, we give the opportunity to ML developers, to vertical owners, to run their experiments, their vertical, to request data from our data space. The solution is very simple. The user requests data. We have a data catalog, we have a metadata broker from the data space. If we don't have it in the data space, the experimenter can request some experiment from the testbed. The testbed, through a very simple adapter, is connected to the framework and to the data space, and it offers the generated data to the experimenter and then store it in the CG DALI data space. We also have some intent-driven workflows in case we have more than one experimenters asking for experiments to our testbeds. What we offer, different types of data from 3 testbeds in the project. We have a massive binary testbed in KU Leuven, 2 end-to-end testbeds, EURECOM in our premises and ESI antennas in Patras. We have physical layer datasets, RAM datasets, core network, edge computing datasets, and finally, bigger set of digital twinning dataset, testbed designed by Avi and EURECOM in France and Nice. In order to show the efficiency of this idea of this solution, we have 3 POCs. The first POC is about data management experiment on demand. In each POC, we have 2 experiments. The first experiment has to do with data set extraction using the GaiaX-based service catalog, while the second experiment is data on demand and enhanced ELT pipelines. The second POC is about AI as a service for CDN apps. And the first experiment is about hyperparameter optimization placement of ML models at the edge cloud continuum. And the second experiment is ML model benchmarking drift detection during the testing of a vertical application. The third POC has to do with the experimentation in large scale using MLOps or medium scale digital twinning experimentation, in this case for ORAN-based solutions. That's all from my side. Any questions from the audience or from the organizer?
Thank you, Christos, for this excellent introduction. I don't see any questions, so thank you again. We can pass to the next speaker of this session. Thank you for joining and for supporting us to organize, as coordinator of the project, this related session. And I would like now to invite the next speaker, Dr. Dimitrios Amaxilatis from Sparkworks. Presentation 39, it's about harnessing data spaces to unlock data value in 6G networks.
Thank you very much. I'm very happy to be here with you today. So I'm Dimitrios Amaxilatis, CTO of Sparkworks, and we're going to see today how the use of data spaces can help unlock the value in 6G systems. So the big difference with 6G networks is that we are now seeing a very large number, a very big volume of data generated from such infrastructures. As the predictions go, we are going to have more than 500 billion devices connected by 2030. This includes IoT sensors, edge devices, and also the network telemetry from the infrastructure itself. But the problem is that those data stay locked inside the organizations that provide them. So there is no standardized mechanism to control or share them effectively. There are barriers about trust of how we can share data reliably and how we can maintain sovereignty over them. And that leads to missed opportunities to explore the data and unlock their real value. So data spaces are, for us, the solution to this problem. So it's a framework that can help us overcome those problems based on the core principles that are in the slide. So it offers us data sovereignty, so the data owners can have full control over their data. They can decide how they want to share them, to whom, based on identity management and authentication that is distributed and trusted. Also, they can provide policies about how the data can be used and what is the compliance that is required so that they are offered to users, to researchers, to anyone that wants them. And also, it offers standardized ways to access the data themselves. So it's a way to promote sharing in a more uniform way. And also, finally, there is a peer-to-peer architecture that helps federation with external services. But it's not only the APIs or a big data lake. It has an embedded notion, let's say, of governance and interoperability inside it. So architecturally, there are 5 main pillars that help build this, let's say, sovereignty over the data and this nature of sharing. The first one, as I said, is the identity and trust with decentralized identities and verification of the person that is asking the data, for example. The second one is the federation that helps share data across domains and harmonize them, let's say, in a way. The metadata catalog is responsible for the discovery of assets, discovery of data based on semantic information and descriptions. The policy engine helps us define who and how can have access to the data and for what duration and for what reason to use them. And finally, the data connectors are standardized ways to handle the transfer and the exchange of the data regardless of the protocol each user uses. So the process flow is like the one presented at the bottom of the slide. We have the verified users that have the ability to publish and browse and discover assets, request for them, then automatically negotiate for a contract to get access to the data, and then finally, once we have the agreement, the data is transferred through a controlled manner. And this is the value for all the stakeholders. It's valuable for users and enterprises because they can
build software and solutions using data that others can provide, and they can also decide who and how uses their data to build new applications. And it offers also possibilities to monetize this data or have, let's say, a transparent way of how they are used and by whom. And also there are benefits to the broader ecosystem. It creates a level field even for SMEs, startups, or big enterprises. It is compliant with regulations like the GDPR or AI Act and other ones, and reduces the legal frictions about agreements for data, as it is based on an automatic way of accepting policies and verifying transactions. So it's a foundation for things like the Industry 4.0 or smart city development. This is the data flow. Christos showed the architecture, but this is more about how the data come in and out of 6G DALI. We have the test beds that are infrastructures, IoT systems, or anything else that generate the data. These are introduced to the data space and the data lake of 6G DALI with their meta information, their semantic descriptions, and also the actual data. And then they are discoverable for external users in order to find them, and we offer also the connectors for them to access them. So it's a one-stop, let's say, shop to get your data. And then they can be used for solutions like AI, ML, or anything else by SMEs, by enterprises, by developers, or researchers, regardless of their role. So in order to achieve this, we have some technical enablers that are used to demonstrate how this process is going. First is the Eclipse Data Space Connector. This is a core component in order to perform the data exchange between the different actors in the system. We have the policy management based on ODRL machine-readable policies that can be used in order to define and evolve, let's say, the descriptions of how data can be accessed. And finally, the different adapters to integrate the different sources or sinks for data in our system, supporting both batch transfers or streaming support. All these are applied to the test beds of the project so that we can have a validation of the flow and the usage of the data at the end of the project. So summing everything up, we are currently in an area, in a region, let's say, of time with a booming data economy, but the goal is to find a way to reduce data integration time as much as possible and increase also the stakeholders that participate in this data economy and data universe. So based on this, the key takeaways that the data spaces, we believe, are here to solve the problem and the gap I presented for data with regard to sovereignty and control sharing. Everyone can benefit from that through a technically feasible and validated implementation infrastructure, something that is essential for 6G vision of intelligent collaborative networks and also beyond that for any data environment. So, thank you very much. Any questions?
Thank you very much for your presentation. I would like now to invite the next speaker, Mrs. Vasiliki Parousidou from Intracom Telecom. She will join remotely, as she told me. And her presentation will be about data ops towards intelligent data lifecycle management in 6G networks. Do we have Mrs. Parousidou? Okay.
Hello, everyone. Yes, I'm Vasiliki Parousidou. I have shared my screen. Is it visible?
Yes, Vicky.
Okay, thank you.
You can go on. Thank you for joining.
Okay, hello everyone. I'm Vasiliki Parousidou from Intracom Telecom, and we present you data ops towards intelligence management, data lifecycle management, and 6G networks as part of our work in the 6 Data League. So this is the outline of my presentation. First, I will describe the motivation, the main vision, as well as the initial architecture of 6 Data League, and then I will focus on the data ops requirements, architecture, and workflows. Today, one of the biggest challenges in developing AI-driven networks is the lack of high-quality end-to-end datasets that can support AI model training and validation. Moreover, we need the ability to trigger complete data generation, AI model training and evaluation in a real 6G environment or digital twin. Finally, we want an easy process to scale up. This is where 6 Data League comes in. 6 Data League builds an end-to-end AI framework that tends to connect 6G data with verticals and ML developers and experimenters. What makes 6 Data League unique is the collaboration it brings together. It combines three powerful communities: experts on the design and experimentation of 6G systems, experts on AI and MLOps, and experts on data ops and GaiaX. These communities are working together to build an efficient, realistic, and trustworthy framework for end-to-end AI experimentation for 6G. 6 Data League is structured in two independent pillars. The first one is about AI as a service, MLOps and RLOps, while the second one is about data and analytics via data ops. In short, the data ops pillar provides the clean, processed data that are stored in the 6G data space and are available for training and validating machine learning models as part of the MLOps pillar. This is the initial framework architecture, including the main components of 6 Data League. In particular, there is a northbound API through which verticals and ML developers can send data or ML requests. These requests are translated using an LLM and forwarded to the most appropriate component, which is either an MLOps or a DataOps component. There is also an adaptation layer to connect the AI framework to the adapters of its testbed. The role of the adapters is to translate the received request into local APIs exposed by its testbed. The adapters also include data space connectors to connect to the 6 data space to store the collected data. In this presentation, we will focus on the DataOps component that 6 Data League architecture includes. The DataOps components need to satisfy user requests for data. In particular, the users need access to datasets for reuse or further transformation. These datasets may already be available in the 6 data space, which are called cold data, or can be generated on demand from testbeds, which are called hot data. Upon dataset retrieval or generation, ELT pipelines are initiated automatically. Also, there are available mechanisms for cleaning or enriching datasets to improve their quality, which is assessed using performance and quality indicators. There are also LLM systems available that can convert the user intents in human language into search queries compatible with the data space catalog, or translate the high-level data needs into executable experiments to enable automated testbed utilization in case the requested dataset do not exist in the data space. Datasets generated on demand can be processed and added to the 6 data space. Coordination of multiple testbeds is needed in order to provide secure access for control experiment deployment and data collection. Real-time experiment execution is tracked in order to log metadata, status, and output for readability and debugging. This is the data ops architecture of 6 Data League. It is designed to satisfy user requests for data. It includes three interfaces through which experimenters interact with the framework. A chatbot user interface, where user can use to send a request in human language, and the DataOps user interface and the DataOps as a service northbound interface that accept requests for triggering ELT processes and applying data transformation and data augmentation algorithms on the existing data. The DataOps workflow orchestrator orchestrates the data transformation and augmentation procedures based on the DataOps tool stack. An experiment agent based on an LLM system uses information provided by a testbed knowledge base to translate the user request into data requests compatible with the data space. The experimentation tool is responsible for tracking the data generation experiments, while the translation agent employs intelligent algorithms to identify the most appropriate testbed to run the experiment. A Gaia-X-compatible 6 data space provides data quality, governance, and discovery services. It includes a federated catalog that provides metadata about available datasets, models, as well as transformation services, including data documentation or data cleaning. Both raw and final data are stored in a 6 data lake, where data ops transformation execution can also take place. The data generation experiments run on the testbed, which also includes some testbed adapters in order to interact with the framework. Finally, both data lake and testbeds have a data space connector for data and metadata storing and retrieval. This is a more detailed and deployment-wise architecture. On the left, we can see that the DataOps toolstat is deployed using the Apache Airflow component, while the data space components can be implemented through Pivot. In the next slides, we will describe two workflows regarding data discovery. The first one regards a scenario where requested data exists in the data space. As a first step, the user interacts with the framework through the chatbot user interface and sends the request in human language. This request is translated into a search query by an experiment agent and is forwarded to the data space. In this case, the relevant dataset is identified based on metadata matching, and information about dataset is exposed to the experimenter through the chatbot. As the next step, the specific dataset is requested through the DataOps user interface. So the dataset is requested from the 6 data lake and is finally exposed to the framework and the experimenter. The second scenario regards a case where data are not available in the 6 data space and have to be generated on demand. As a first step, again, the user requests their data in human language through the chatbot user interface. The intent is translated into a search query and is forwarded to the data space. In this scenario, the relevant dataset is not identified based on metadata matching, so the intent has to be translated into an experiment agent request. The testbed that will run the experiment is selected by the translation agent, and the experiment request is forwarded to the testbed. The testbed runs the experiment and raw data is extracted and loaded to the data lake. Finally, the information about dataset is exposed to the experimenter. As a next step, the specific dataset, along with requested data transformation or augmentation techniques, is requested through the DataOps user interface. Data transformation and augmentation algorithms are applied to the requested dataset, and the final dataset is stored in the 6 data lake, while its metadata are stored in the federated catalog of the data space. Finally, the dataset is exposed to the experimenter. To sum up, the 6 data lake DataOps architecture provides a foundational layer for federated, AI-driven, and on-demand data engineering 6 environments. By integrating intelligent user interaction, automated DLT processes, and coordinated testbed operations, 6 data lake enables scalable, transparent, and high-quality data access, paving the way for innovative 6G applications in the future. Thank you for your attention.
Thank you for your presentation, Mrs. Parousidou, for the detailed information and the exact framework you have presented. We can pass to the next speakers, and if there is any question for all, we can come back. So the next speaker in turn is Dr. Giacomo Bernini from Nextworks, SRL from Italy. His presentation will be about MLOps, a key enabler for AI-native 6G networks. Do we have Dr. Bernini with us? Okay.
Yes, can you hear me?
Thank you for joining, and thank you for supporting our effort.
Yeah. Shall I share my screen, right?
Yes.
Okay. Okay, so can you see my screen, right?
Yes, just go full screen. perfect. You go on full screen mode.
Yeah, I'm trying to go.
Okay, perfect.
Yeah. Okay, so thanks a lot for the invitation. So this presentation completes, let's say, the view on the CDG-DALI approach and architecture concerning specifically, in this case, the MLOps aspects as a key enabler for the native 6G network. So I will provide also a bit more of motivation with the final part on the approach that you are following in 6G-DALI. So basically, we know that with 6G, the next generation networks are expected to be more and more pervasive and also including and integrating different type of technologies, network domains, bringing the need of introducing more and more with respect to previous generation and 5G and 5G advanced, full automation in how the network resources, but also the application level is managed and operated. So there is a possibility indeed to exploit a huge amount of data that can be collected in different layers, and we can have, let's say, even more with respect to what 5G started to define and offer, to have a pervasive deployment of AML capabilities, the AML models inside the network, and across a kind of continuum of edge cloud computing capabilities. There are, let's say, a few technology enablers that are, let's say, defined since the beginning of the 6G journey as kind of enablers for introducing this automation and AI/ML integration in the 6G architecture blueprint that was also initially defined as part of the XX2 project, for example. That was the flagship project for the 6G blueprint architecture definition, and these are indeed the same pillars that are also present in 6G-DALI and that concern the MLOps aspect and technology to streamline the management of the machine learning model lifecycle, applying, let's say, a DevOps approach to the IML domain. The DataOps that was just introduced by Vicky, which is an important aspect to manage in an efficient way the high volumes of data that are expected to be managed as part of 6G networks, and also the AI as a service, which is pretty much linked with the two previous ones that allow to expose the AI capabilities and data capabilities in the form of services towards the vertical application layer. But in general, so why the AI/MLOps is needed? So there is a nice paper from Google. It's already a bit old, like 10 years ago, but it gives very nice insights on the fact that if you see also from the figure, the machine learning code, so aspect, it's a kind of smallest fraction of the complexity of an overall ML-based system, because most of the complexity relies on all other aspects that concern with the management and operation of data pipelines, and also how to manage the models, how to train them, how to analyze the outputs of the model, how to deploy and serve a model, and how to monitor the performance of a model to avoid drifts and trigger some kind of adaptation of the model itself. And it becomes clear that without some kind of techniques that try to put everything together beyond the actual phase of development of the machine learning model, all these ML-based systems, like it could be the 6G network in general, there could be an accumulation of technical depth and also reliability of the overall system. That's why MLOps is introduced, which is not a kind of new term or new technology, and it let's say relates to the application of the DevOps concept to the IML domain, trying to introduce this kind of closed loop concept through automated pipelines that try to automate all the life cycle of a machine learning model, from the data analysis to the development of the model, so its engineering, development, and also testing as part of the training, and then at the end the deployment in pre-production and production, testing and evaluating continuously the model in terms of performance or drift detection, to analyze if there is a need of either retraining or even re-engineering of the model through, for example, additional data sets or even new data analysis aspects. So basically, MLOps allows to bridge the gap that is there from experimenting or developing a machine learning model in a kind of notebook approach towards the production-grade deployment of ML services. So it's a kind of set of techniques, tasks, procedures that, if they are automated, that really help in closing this gap, adopting a classical kind of DevOps paradigm that is well used and adopted in the application development. Of course, there are challenges that arises when we want to apply this concept to the CDG networks and to make them really AI native. And there are a few aspects that are also pretty much in line with what was discussed before in the previous presentations concerning 6G DALI that relate to, let's say, manage the life cycle of the models, specifically the training aspects and the deployment aspects for the inference, considering that the 6G infrastructure will have a continuum of edge cloud computing capabilities and resources available, so models could be deployed and run in different points of the network, and this could be leveraged for distributed and decentralized AI techniques. And also an important aspect is related to sustainability aspect, which is very important also from the Commission perspective and as one of the main overall goals. And when dealing with AI, of course, the sustainability is one of the key aspects in order to manage efficiently the different tasks with the goal to be sustainable in terms of energy consumption and energy efficiency. Of course, there is the aspect also of moving some kind of AI tasks at the extreme edge, so running tasks either for training or inference on the extreme edge, so on the device side. And of course, also all the aspects related to agentic AI and specialization of LLM models that allow to, let's say, further challenge the MLOps capabilities to go towards fulfilling the requirements of these innovative technologies. There is, anyway, a wide standardization landscape around MLOps, not natively conceived for MLOps, but in the scope of 6G network definition, for example, in 3GPP, there is a consistent amount of work that has been started in release 18, continued in release 19, and also release 20 concerning the applying the MLOps capabilities to the lifecycle management for the lifecycle management of models in the management and orchestration domain, enabling also distributed workflows and AI deployments across RAN and core, and also another work which relates to the exposure to an AI as a service, let's say, approach of the ML capabilities towards the vertical application layers. And this is the AML enablement layer, let's say, aspect. There is also, in the context of RAN, a set of activities that concern the definition of some kind of AML workflow services in the context of the non-real-time RIC for the, let's say, intelligent control of the Open RAN resources that, let's say, define some procedures to operationalize the use of AI capabilities inside the RAN. And this is pretty much linked also to some work that is defined as part of the AI RAN Alliance, which is a new alliance that started more or less 1 year ago, that goes, let's say, together with the RAN in defining principle for integrating the AI capabilities into the RAN, focusing specifically on different aspects for AI on RAN, AI for RAN, and AI in RAN, that allows to use and deploy AI as part of the RAN networks, covering the specific needs of the RAN, or leveraging the RAN network functions to host some kind of application level AI services. So all of these to show that there is consistent work also on the standardization, from the standardization landscape and domain, of trying to introduce these AML management aspects as part of the next generation network definition. On the open source side, there is also a very wide landscape of tools and solutions available. there is an interesting, let's say, landscape provided by the Linux Foundation in terms of tools and, let's say, frameworks available on the AI and data aspect, which shows a very, already wide ecosystem of tools that are useful for the MLOps aspects. There are several projects that are already available and that are organized in different type of categories, more related to machine learning, reinforcement learning, or data management and data operation, explainable AI, and so on. And also for each of them there are different subcategories to identify those that are just frameworks, tools, programming languages or libraries. And this is something that, at least in our case in SIG Italy, we found very useful to set the ground of the state of the art of the available tools that can be reused to build a more comprehensive MLOps solution. Specifically in the project, we are mostly interested in few of them that we are trying to adopt and integrate for either machine learning cataloging and let's say experiment tracking, pipeline management, or method orchestration like ZML or ONNX that provides a kind of common way to model and describe machine learning models irrespective of the framework that they use in order to foster interoperability. So just to stress that also in the open source landscape there is a huge set of tools that provide a lot of capabilities already to realize, let's see, MLOps production grade solutions. So going specifically to the SIG Italy approach, so what we are trying to follow here is a kind of evolutionary step with respect to a previous project that some of the SIG Italy partners participated with, which is the Android 6G, where we started to develop a more basic framework, which was more tool-based, with some of the tools that I mentioned before, providing just some baseline functionalities for catalogs for machine learning models, functionalities for training and deployment of models, but still very much linked to the capabilities of some of the open source tools available. What we are trying to do now in DALI is to go a bit beyond this and implement a kind of common business logic for the MLOps tasks and processes, providing a clear separation between the tools and the orchestration aspect that should be more generic irrespective of the stacks that are used in the project and in the test beds where the various experimentations and POCs that Christos mentioned will be executed. The goal here in SIG Italy for the MLOps approach is to follow the as a service, let's say, paradigm, so trying to expose the capabilities of the MLOps as a service to be consumed by and integrated with some kind of experimentation framework that allows to define experiments, to benchmark machine learning models, or to test specific reinforcement learning or explainable AI techniques, and also execute some kind of experiments for the upper parameter optimization, as it was one of the goals of the POCs in the project. Of course, there is a strong integration with the data ops and data space aspects presented in the previous two presentations to allow these MLOps common orchestration approach to retrieve and identify suitable datasets to perform, I don't know, training or other type of experiments. And there is this aspect of the meta orchestration, which is very important, which allows us through this ZML tool to abstract.
Dr. Bernini, if you allow me, if you can try to summarize in order to be aligned with the time schedule, please.
Yeah. It's just the last slide, so I will finish in 1 minute. Yeah. So the idea is also to abstract the capabilities of the different test beds in the project to have this meta orchestration approach. So basically, to conclude, so what we are trying to do is to develop this kind of MLOps solution that will go into the direction of supporting the delivery of native and data-driven 6G networks, integrated with data ops and data spaces that were presented before, and of course try to address some of the key challenges that I was mentioning before to realize a 6G ready MLOps solution. Yeah, and that's it from my side. Thanks for the attention, and sorry for being a bit longer than expected.
Thank you for your presentation. And we will now pass to the final speaker of this session, Mr. Michalis Randopoulos, one of my colleagues from OTE. Michalis will present a business model and monetization opportunities for telco operators coming from the framework of the 6G DALI. Presentation number 42.
Hello, everyone. I'm Michalis Randopoulos, and I will be presenting the unlocking the value of 6G datasets, business model, market potential, and API-driven monetization for telco operators. A few words about the contents of this presentation. We'll go through the reasons for the emerging data economy, data scarcity in the telecom domain, again, the reasons why this happens, market opportunities for telco data and AI as a service, and we'll go through the main pillars of the 6G DALI business model. Data-driven innovation opportunities and challenges. There are limitless innovation opportunities in sectors such as autonomous mobility, energy efficiency with smart meters, and healthcare breakthroughs. The key challenges in an open data ecosystems, of course, are privacy breaches, cybersecurity threats, and data overload and management complexity. What can Europe do in the context of all those opportunities and challenges to strengthen technical capacity for data sharing and AI innovation, build robust governance frameworks that protect citizens' rights, and ensure security, trust, and ethical use of data across all ecosystems? By 2030, we'll be having yottabytes of data annually. This is everybody's belief and estimate. The data economy encompasses all processes enabled by digital technologies, such as data generation, collection, storage, processing, distribution, analysis, and utilization. And what is significant to state here, data is often compared to traditional resources, such as gas, oil, or water. But data is unique in two ways. They are its non-rival nature. It's not exhausted by use. As we use them, they're not finished. It can be reused and recombined to create positive spillover effects. And due to the data's aggregation value, data becomes more valuable when aggregated and leveraged through analytics and machine learning. So, 6G DALI sits at the intersection of AI, telecommunications, and data infrastructure. It provides an integrated MLOps, DataOps framework and the 6G aligned data space. It directly addresses current market gaps and emerging strategic needs for intelligent, secure, and data-driven networks. As a key insight here, we'll see that future 6G networks will depend on native AI integration and access to high-quality real-world data to deliver the ultra-low latency, reliability, and security these use cases demand, the new use cases demand. For the telco professionals, the reasons for data scarcity in the telecom domain may be a common knowledge. They have encountered one or more of these reasons due to data being so scarce in the telecom domain. First of all, there are very strict regulatory constraints, strict laws like GDPR. There are great privacy concerns because telco data are highly sensitive. Therefore, a data breach can cause severe reputational, financial, and legal consequences. Data silos, cumbersome old platforms, they lack interoperability with modern data platforms, lack of standardization, and last but not least, lack of incentives for telco operators to share their data. Telco operators need clear economic models and value-sharing mechanisms to drive participation. So, the telco's strategic transformation is to move from connectivity providers to platform innovators. The drivers of such a need are market saturation, regulatory pressure, and over-the-top competition. The focus is on new revenue streams through business-to-business data ecosystems, APIs for data access and integration, and enterprise partnerships. The market opportunities for AI as a service are the market share is estimated to reach $91 billion by 2030 throughout the world. For telecom operators, vertical service providers, and developers, working with the 6G DALI ecosystems underscores the strategic relevance of providing and consuming AI capabilities in a modular, service-oriented format. Within 6G DALI, AI as a service becomes a practical and commercially viable model, enabled by its digital twin testbed, MLOps pipeline, and federated 6G data space. Regarding the key drivers of AI as a service growth, of course, the growth of big data and real-time analytics, adoption across multiple industries, widely used of AI in healthcare, finance, retail, and manufacturing. Very importantly is the rise of low-code or no-code platforms. AI platforms nowadays are very user-friendly, and they empower non-technical teams. No expert can deal with no coding skills are needed. Integration with emerging technologies, combined with edge computing and the Internet of Things. AI as a service in the 6G DALI context. AI delivers cloud-native machine learning models, inference, and data pipelines. It aligns naturally and enables seamless integration with telecom networks and vertical applications, and supports continuous intelligence and real-time responsiveness. The market momentum, it's important for telco operators, the shift of the expenditure from CapEx to OpEx, to operating expenses, and AI as a service toward domain-specific, trusted, and interoperable solutions by means of offering capabilities such as traffic prediction, anomaly prediction, orchestration, intelligence, and network slicing optimization. The alignment with Gaia-X, 6G DALI aims to create Europe's first 6G data space aligned with Gaia-X principles. It builds a secure federated data infrastructure for exchange, processing, and monetization of 6G data. There are three main technical core components: the standardized data connectors, secure data exchange mechanisms, and federated identity management. All the above ensure privacy, data sovereignty, and interoperability across networks. The four key areas of 6G DALI business model, potentially the licensing architecture, modular and reusable offering of DataOps, MLOps components for dataset quality, versioning, and model lifecycle automation. Of course, this is not feasible to be done in the life cycle of the project. However, it ensures the licensing model ensures post-project sustainability, not commercialization throughout the life cycle of the project. A subscription-based access could potentially be offered. Access to curated data sets, either real data from testbeds or synthetic data from digital twins. The subscription could potentially include tools and testbeds for external partners. Consultation and training services by experts regarding integration, maintenance, and deployment support. As well, training and documentation may be offered for interacting with testbed APIs and operational onboarding. I think I'm on time, so this is all from my side. Thank you. Any questions?
Thank you for this detailed presentation, and thank you for being within the time slot.
Right.
Thank you so much for this. I don't have any comment by my side. Once again, I would like to say that, as Christos initially mentioned, this is a new project, a lot of expectation, a high dynamism, new options regarding the way how AI will be treated in the framework of beyond 5G or 6G. Many challenges, strong consortium, experienced consortium, selected, let's say, a framework for trials, for proof of concepts. Also your work in the framework of KVI, you mentioned that the methodology is based on the one you have developed in the framework of the 6G BRICS project, and now you adopt this in the specific framework of 6G DALI. Great challenge. I hope next time when more results will be available, we will be able to examine in depth the options and the challenges coming from this very interesting project. Thank you by my side for your presentation, and many thanks to all other speakers for this interesting session. We can pass now to the next session, session number 10, which will be coordinated by my colleague, Mr. Achilleas Marinakis from the IT Center.
Thank you, Yannis. The next session is devoted in a couple of very hot topics, cybersecurity and AI, and most significantly, how these can be combined. Regarding cybersecurity, awareness is a must, especially in critical infrastructures such as telecommunications. To this end, I would like to invite my colleague Petros Panagiotidis to give us a speech about SEC Awareness Trust EU project. So, Petros, the floor is yours.
So, hi everyone, my name is Petros Panagiotidis. I'm a process analyst in OTE. I'm a colleague of Achilleas, and I'm very glad to be here. So, today I will be sharing with you how the SEC Awareness Trust is revolutionizing cybersecurity training for critical infrastructures, as Achilleas mentioned, such as the telecoms, the energy sector, healthcare, and maritime. And we are doing this through developing a federated cyber range platform that will guide us through this new brave world of AI evolution. The question is not whether our infrastructure will be targeted. The main question is how ready we are to defend it. So, SEC Awareness Trust is an EU-funded project with a budget of 3.5 million, give or take, and is based on the cyber ranges, leveraging IT security, privacy, and data protection culture, and of course awareness for the critical infrastructure sectors we just mentioned. It began in the early January of 2024, and it will last 36 months, hopefully to a great result. It's a collaboration of 9 organizations from Greece and Cyprus with 4 public bodies, 2 industrial partners, 1 academic partner, and 2 SMEs. Actually, it's not a consortium, it's the best of team that will give us something new, something revolutionized, such as we have the ones who govern, the ones who operate, and the ones who innovate, all together, bringing their minds together to make something new, something brilliant. Therefore, the main characteristics of sector awareness trust is that it empowers cyber resilience through innovative training. It delivers practical and cutting-edge programs for critical infrastructure. And it provides cybersecurity awareness and compliance, utilizing a controlled environment for real-world scenarios with embedded systemic incident response capabilities. In that way, we are building muscle memory and not just absorbing information in order to be ready when the attack happens. Some key features that perhaps have been already mentioned, but I would like to emphasize, are the realistic sector-specific modules that we have created. And on top of this, we have cross-sector complex scenarios that our trainees will ask to answer and to be trained in. We have game-based exercises with immersive simulations, so they emulate real-time and real-life attacks or breaches, and we are called upon this to respond and to defend. We have knowledge sharing and collaboration tools for effective training, because what is real for one sector could easily be transferred or translated to another civil infrastructure sector of our times. And we have a centralized management of training content and best practices, so that we can assimilate and assess and assimilate what is best and power through all the noise. This is the brief top view of the high-level architecture of sector awareness trust. We have the IAM system and API gateway, which provides secure identity and data exchange backbone. It's the SAT centralized GUI, a unified dashboard for monitoring and situational awareness. We have the CTI feeds, which are the external threat intelligence for proactive defense. And in the Sphinx ecosystem, we have included the CR platform, the Separate platform, which controls risk management and training. The SPA suite, it's for security and privacy assessment. The MART, which is a maritime-specific module. And the pilots, the 4 pilots for these 4 core sectors, they have their own test bed. So energy, telecom, health, and maritime scenarios are run through this pilot system. We have many scenarios that are common for all these are common practice and they're not sector-specific, such as phishing awareness, which, by the way, is evolving day by day. But we also have sector-specific, we tend to sector-specific needs, such as network security. Let's go to the telecom sector to begin with. Network security. We have, of course, regulatory compliance, technical training, vendor management, and our key module is the golden ticket exploits. That is something very, very heavy and very, very recent in telecom sector attacks. If we move along to energy sector, then we have smart grid security, protecting interconnected energy systems from cyber threats. We have, of course, again, regulatory frameworks that the energy sector must comply to. We have IT and OT integration, and we have incident response that will give us effective detection and management of cyber attacks. We couldn't leave the energy sector without its own key module, which is the man-in-the-middle attacks. Such attacks could easily bring down the whole backbone of the energy infrastructure delivery system. Moving to healthcare, we have patient data protection, which is easily to understand why we don't need our medical data ending on the dark web. Regulatory compliance, of course, telemedicine security, and medical device security, such as insulin pumps or pacemakers. They don't need to malfunction, and because actually lives will be lost with healthcare breaches. And the sector-specific training module we're preparing for healthcare is the cross-site scripting attacks in web applications, which would make them everything safer, actually. Last but not least, it's the maritime sector training. We want to protect the navigation system. We want to raise awareness for regulatory compliance, team collaboration, and risk assessment. Risk is the biggest thing in the maritime sector. And the sector-specific training module for this one is the leveraging of OSINT. Of course, this is just the basis. This is the first step. Many steps we will be able to climb if an AI integration is materialized, and we're looking forward to that, and we're working towards that. We have you can see the pyramid here that will send us to new heights of SEC awareness. It all begins with gamified experience of the training, because we have deeper engaging and of the trainees, and it actually makes it fun to go through AI-powered challenges. Then, on top of that, we can build on automated feedback. That gives us immediate feedback, immediate assessment, and improvement upon our previous experience. And in that way, we don't lose interest waiting for a week or week and a half to get our feedback from actual people that would summarize our results. Then we have dynamic scenario generation, building upon the two previous building blocks. It creates realistic evolving attack simulations that are not a thing of the past, but are a thing of the current times and the future, part of the zeitgeist. And that will lead us to personalized learning paths with adaptive algorithms, tailored content, and difficulty to individual progress for each one involved. In SEC Awareness Trust, we have the basis, we have the 3 generic training modules, we have 3 key sector-specific modules. For now, we are referring to 4 critical sectors, but more sectors are we want to include. But the main thing is the infinity symbol. That is the symbol we look forward to, so that we have real-time threat updates and adaptive content 24/7, all day, every day, whenever one is in need or wants to train something to become better, to acquire more awareness. Cyber ranges, AI benefited cyber ranges will be probably the future, and we're going to lead that. Thank you very much.
Thank you, Petros. Remaining in the topic of cybersecurity, I will give the speech to Dr. Kostas Kalogeros to give us updates regarding CyberSecDom EU project. Kostas, please.
Thank you very much. So, I'm Kostas Kalogeros from ITSIT Research, and I'm a senior project manager. ITSIT Research is an expert on cybersecurity. Our headquarters are in Braunschweig, Germany, but we have also some branches in Athens, so this is where I'm located. And in this session, I will present you the concept of CyberSecDom. We are currently in the 30th year of the project, and there are several partners, well-established partners. Maggioli is the coordinator, OTE is one of the pilots, and there are several technical partners providing their expertise. So Aegis is one of those. So what is CyberSecDom? So it is about providing real-time and collaborative protection to digital infrastructures, especially critical ones. And we follow an approach that is based on both proactive and reactive systems. So, as you can see here, there are two pillars. The first one is about AI, AI-based technologies, and this is where we provide intelligent incident detection, investigation, and response, as well as AI-based threat prediction. And the second pillar is how we provide user-intuitive methods for dealing with all those incidents. And the interesting part is that we embrace virtual reality along with cyber ranges so that we can have an immersive situational awareness. So on the left-hand side, you can see the overall big picture of CyberSec DOM. So imagine that you have a single instance and there are several pillars and layers. So on the bottom layer, we have the data layer. It can be either the actual infrastructure, digital infrastructure, or a virtual one based on digital twins. Of course, digital twins are very handy if you don't want to test new approaches or technologies on your actual production system. So if you don't have a staging platform, then digital twins are perfect for this. There are a set of AI-empowered security tools, and the top layer is about the user interface. So as I said, we are offering VR-enabled user interfaces combined with cyber ranges. And on the left-hand side, you can also see a pillar about how we allow information about incidents to be shared across infrastructures and domes. So if we have multiple domes, which means if we have several instances of CyberSec DOM deployed on several organizations or different domains, then these DOMs can exchange information, incidents, etc., based on well-established policies, determining what will be shared with whom and, of course, when. So if we focus on the AI-based security tools, we can see that there is one of the candidate workflows. The first one is tools related to intrusion detection and prevention. So these are, of course, very important in order to understand what is going on. But as soon as an incident is detected, then we need our experts to investigate whether this is an actual incident or a false alarm. And this is a very important step, of course. Assuming that there is an actual incident going on, then we employ dynamic risk assessment methodologies in order to understand what will be the impact of different approaches on our digital infrastructure. There are also methods for running automatic penetration testing on the digital infrastructure. Of course, this can run periodically, and it can also provide you with information across all those steps. And eventually, what we want to achieve is to have immediate and dynamic response to all those real incidents. And eventually, we want information about all those incidents to be shared with other peers so that we can have a collaborative environment. So if we focus on one of those technologies that are part of the incident investigation group, I would like to present you the Aegis SARC, which means Security Alert Reduction and Correlation. So this is an AI-based tool that can build on top of existing intrusion detection systems, or CM, and solve one of the main challenges that SOC experts face. I mean, false alarms or false positives. So what this system does is to analyze incoming alerts and decide based on several patterns whether this is an actual incident or a false alarm. And we can also cluster different alerts that may appear at the first place as unrelated, that we can cluster if these are following a new pattern of a TTP. And eventually we provide explainability, so we give a reasoning to the user why this is a false positive or a true positive. But what are the benefits of such a method? Of course, we provide effective and efficient incident analysis, and we allow users to be trained along this path. So CyberSecDOM technologies will be validated in 2 pilots of the project. These are, of course, critical infrastructures. The first one is telecommunication domain, where OT is involved, and another critical infrastructure is the Athens International Airport. So if we focus on the first pilot of OTE, there are several interesting use cases that have been discussed. The first one is what happens if we have a distributed denial of service attack. And of course, the second one is about ransomware. So both of them are, very interesting. Maybe the first one is easier to take place, which means that we need to be quick in response. But the second one is also very challenging because there are several TTPs that the bad guys can employ in order to achieve their goal. So in this domain, the OT organization will provide those use cases, will deploy the CyberSecDOM, and eventually will test these technologies and provide us with feedback. And of course, the cybersecurity is a top priority for OTE, but this means that they need to be focused, to be engaged with other experts and see how new promising technologies can be used either for the production environment, either for training of their employees. But apart from those internal pilots, the CyberSecDOM is running several open calls where other beneficiaries will be able to test and validate the CyberSecDOM technologies, but also to provide their own. So during the first round that took place last year, there were 57 finalized submissions and 9 eventual projects dealing with several aspects of cybersecurity domain. And we are currently running the second phase where there are about 6 or 7 projects that will be selected. There was a lot of competition. So there was a 32% of increase in the proposals that we are currently examining and reviewing. So to sum up, the CyberSecDOM project is a very promising project combining AI with VR and AR. And you can also check our website and find out more details, so stay tuned.
Thank you, Kostas. Moving away from cybersecurity topic, I will give the floor to my colleague Eliana Papakonstantinou, process analyst from OTE Group, that will present us a 3D Circular EU project, which is a project in the field of circular economy and has been launched recently. So, Eliana, the floor is yours.
Hello, everyone. I'm Eliana Papakonstantinou, as my colleague Achilleas introduced me. So, this. It's okay. So today I will present to you the 3D circular. Envision a future where every product, every process, every decision contributes to a sustainable and circular economy. Now, envision that future powered by deep tech and digital innovation. This is the vision of the 3D circular. It's a 4-year project from August 2025 to July 2029. And its goal is to create a new generation of education and certification system that equip professionals with advanced and hybrid skills to support the European circular economy driven by digital innovation. This is a truly collaborative effort. We have 32 partners from 14 countries, including universities, research organizations, large industries, and SMEs. The diversity ensures that we combine academic excellence with practical industry insights. So, the 3D circular approach is to develop advanced educational programs at master's and doctoral levels, along with certification modules. These programs align with the European Commission's innovation priorities, and the aim is to upskill and reskill workforce for a digital and green economy. Here, as you can see, are the learning pathways: Master of Science, Master of Business Administration, Master of Science by Research, Doctor of Philosophy, Doctor of Business Administration, all focused on deep tech in circular economy. Also, certifications will specialized in thematic areas will be offered for all to ensure that professionals at all stages can be benefit. Now, as you can see, the structure of the program combines theory and practice, blending learning approaches, integrating lectures, digital tools, and hands-on labs to create a comprehensive educational experience. 3D Circular, as a typical EU-funded project, is organized in work packages. As you can see, the OTE is a task leader in work package 3. So every work package has a different aspect, from syllabus design to infrastructure development and industry collaboration. OTE as a task leader plays a key role. Our responsibility is to develop high-impact industry-focused training labs. These labs will provide hands-on learning, digital tools, and applied research environments to help students to build practical skills. And this ties directly with Work Package 3 objectives, which are delivering infrastructure for blending learning, integrating digital facilities, and supporting practice-oriented research. In other words, creating an ecosystem where theory meets real-world application. Here are some initial ideas that OT has in like digital exercises tackling industry challenges, webinars on AI and robotics in circular economy, physical workshops in OT labs, and synthetic testing data to support circular practices like data reusability. To sum up, 3D Circular is more than an educational project, is an accelerator for Europe's transition to a sustainable, digitally empowered economy. Thank you for your attention.
Thank you, Eleana. Now we're moving to the last presentation of this session. Hello again. My name is Achilleas Marinakis, Innovation Engineer from IT Innovation Center OTE Group. And this presentation will describe the updates regarding Deploy AI EU-funded project. The Deploy AI, along with AI for Europe project, compose the AI on-demand platform, or briefly AI ODP. We all agree that AI is shaping the future and Europe must not fall behind. Towards that direction, the mission of AI ODP is to promote trustworthy, ethical, and transparent European AI solutions for the industry and become a vendor-independent platform that provides European companies with seamless access to the cutting-edge technology. Concerning the offerings of AI ODP, first and foremost is a comprehensive AI resource catalog and marketplace, access to European HPC resources, interoperability with the wider European AI ecosystem, and last but not least, via its marketplace, it offers trustworthy and innovative AI services and use cases that span across the diverse domains. AI ODP consists of three main pillars: the DevOps tools, the marketplace, and the business navigator. Starting from the DevOps tools, those are means and mechanisms that assist the AI vendors to build, train, and operate their own AI models and algorithms, and then advertise them via the marketplace. The flagship of the DevOps tools is the AI Builder that enables the AI developers to create automated workflows based on AI reusable models. Moving to the marketplace, its objective is to provide a one-stop shop for AI-based responsible services and products to democratize access, development, and deployment of AI resources made in Europe. In few words, to become the European reference point for trustworthy AI. The goals of the marketplace are to advertise the offering of trusted AI resources and their benefits in order to boost European industry competitiveness and increase AI maturity and adoption. The marketplace caters the needs of both AI providers and consumers. AI providers to help them onboarding to the platform, advertise their products and gain visibility, and consumers to have a discoverability of the products, find their solutions, what they need for. The marketplace addresses multiple stakeholders and potential customer groups in the European ecosystems, such as SMEs, public administrations, large industries, digital innovation hubs, independent researchers, and others. Since the first semester of 2025, the marketplace is fully operational, up and running. So all of you are more than welcome to register and start exploring its capabilities by your own. Here you can see the products that are currently available in the marketplace, and you are able to filter them based on the type of the product, the business function that they serve, or the sector that they belong to, like energy, logistics, environmental, and others. Moving to the last component of the AI ODP, this is the Business Navigator. The main objective of the Business Navigator is to find the sweet spot between what customers actually need and expect from AI solutions, what is viable from a business point of view, and all this taking into account what the current maturity level of the AI technology can really achieve. The Business Navigator is actually a data product committed to providing high quality and up-to-date information via user-friendly interfaces. That way, it serves as an intelligent gateway to the European AI ecosystem. Business Navigator facilitates the discovery of AI partners, product, services, infrastructure, funding opportunities, and more. In order to support strategic alignment and informed decision-making within the AI landscape across Europe. To achieve these goals, the Business Navigator provides a set of features, such as interactive maps, an extensive business registry with companies from many countries across Europe, and with vendors coming from different sectors. Also, it provides custom-made analytics for personalized information, real-time data integration, and also tailored guidance. So you can visit us in our website and explore all these capabilities of the AI ODP platform, and new releases of the platform are being expected during the first semester of 2026. So stay tuned for more AI in Europe. Thank you. So this brings the end to session Security and AI. I don't know if there are any questions from the audience. If not, I will pass the floor to my colleague Ioanna for the next session.
Thanks a lot. Hi. My name is Ioanna Mesogiti, and I will chair this session, which brings the discussion to AI and how this is developed and supported and fostered in European projects across all layers of networks, starting top-down from the application level to the network level, to security level, and how this can be exploited in the context of networking, of application and services delivered to corporate and end users. With this, I would like to start the discussion with the presentation of Mr. Konstantinos Filis, which will represent the multi-X SNSJU projects, and we'll discuss about the KPIs, the KVIs, and the use cases that are supported by AI and the integrating, sensing, and communication capabilities of 6G networks.
Thank you, Ioanna.
Thank you.
Okay, so the Multi-X is a project of the European Union. We can see here some details. The funding is 8 million euros. So the coordinator is UC3M from Spain. The consortium consists of 18 partners from 7 countries. And the starting date was the 1st of January 2025, with a duration of 30 months. The vision of Multi-X is to redesign the 3GPP RAN to develop the so-called Multi-X Fusion Perspective 6G RAN system, MP6R. The particular system will provide multi-sensor fusion, which means that a lot of different sensors will be able to provide data combined, like LiDAR, cameras, radar, cellular network data, and more. It will provide multi-band operation, multi-static processing, meaning utilizing signals transmitted by one or multiple nodes and processed by multiple receivers, and multi-technology integration, meaning that we can merge 3GPP cellular networks and not 3GPP technologies. The key objectives are to provide use cases and reference scenarios, to integrate multi-technology, multi-sensor, multi-band, and multi-static perception, to design and develop multi-X perception system, the so-called MPS, and to demonstrate the benefits of the project using proof of concepts. The use cases that we have considered in this project are 6. The first one is the industrial collaborative robot supported by multi-layer digital twin. The second one is the contact-free human localization and vital signs detection. The third one is the smart home virtual security. The fourth one is the low-altitude UAV management. Then we have smart shopping tracker and gesture recognition in industrial environments. Some of the KPIs that we have considered in Multi-X, and especially in the smart home use case, are shown in this table. We can see, for example, that we have an accuracy of detecting human position of 0.5 meters indoors and 1 meter outdoors. We have a rate of incorrectly triggered alerts of less than 2%, a rate of missed critical intrusion events of less than 1%, power used by static UE during passive monitoring, less than 5% daily in its battery. So these are some of the KPIs that we consider. Each use case, of course, has its own particular KPIs. Two proof of concepts have been scheduled for this project. The first one is the multi-layer network digital twin for industrial manufacturing. And the second one is the contact-free e-health monitoring at home environment. The role of OTE in the particular project is to define the use cases, deriving requirements and KPIs, and conducting techno-economic evaluations, to provide insights from a telecom operator's perspective on data management, interfaces, and deployment options, to contribute to the POC, to the proof of concept activities in the definition of the experiments, providing its 5G cloud testbed for integration and testing, along with its IoT smart home solution, to participate in dissemination, exploitation, and liaison activities, and to participate in SNS collaboration activities. That's all about the particular project. Thank you very much for your attention.
So now we will move on to another perspective of integration of AI at network and application level in support of applications that can detect early wildfires and their benefits in the context of in general 6G networks. To this end, I would like to welcome Dimitris Almatanis, R&D engineer from OTE, to give the presentation.
Thank you, Ioanna. Hello, everyone. I'm Dimitris Almatanis. Hello, everyone, again. I'm Dimitris Almatanis. I'm going to present basically the early wildfire monitoring system that we have built in the context of 6G versus containing network-native AI. So the 6G versus is a project of StreamD SNS. It has duration of 36 months and funding of 12 million. And there are 34 partners from 10 countries involved. Oh. Okay, so the main objective is to demonstrate how 6G-enabled AI and robotics can help and enhance search and rescue operations triggered by early wildfire detection. So basically, we have our infrastructure is we have a dark fiber connection with Demokritos. And we have set up some cameras there which will basically monitor a forest. This stream will be transferred through the dark fiber to OTE infrastructure and run the inference, the AI there to make the smoke detection. This is the Greek use case diagram. Basically, we have cameras which monitor for smoke, and after a smoke is detected, some robotic dogs, drones, and first responders are actively go to the fire to basically monitor the event. So the application stack of the 6G Versus is triplets. It's the V app, which is the vertical application. In our context, it is a graphical user interface for the wildfire monitoring system. We have the AI app, which is the wildfire detection algorithm that is triggered, and then app, which basically we use the quality of service data to trigger some actions based on the quality, like if the quality is not very good, lower the stream and stuff like that. So the layer of the project is, at the bottom we have the data network, then we have the functions, the 6G core, then the network applications, which speak with the data fabric, and then at the top we have the vertical applications and the AI apps. So, particularly for the wildfire detection AI, our objective was basically to build an application that will run real time from feed from IP cameras, and basically will detect smoke at early stages at very long distances. Then, by triggering this, by triggering of a detection, then we send multimodal alerts to basically a group of people that need to be alerted for these situations. And all these features are built up in a graphical user interface where you can see the cameras, the live feed of the videos, historical event, stuff like that. Now, the most important challenges is to build such a monitoring system and AI algorithm. Basically, we have a lot of situations that are hard to predict, like we have some camera-related issues. Camera could be blurry, out of focus, and it's difficult for the AI algorithm to run effectively. We have environmental issues that basically cloud, low clouds, or fog, which is objects that are confused and can be passed like smoke. We had limited real-world testing. Basically, we cannot test this application because we cannot find many applications where basically smoke is at its early stages. And one of the biggest one is data scarcity. Basically, there is no data set. There are very few images of smoke at its early stages online. So it's the collection of the data set. And the biggest one is that smoke has irregular, is an irregular object, so its shape and color is dynamically changed through the environment. We can find gray smoke, black smoke, and different shapes, of course. So basically how it works in simple terms, it's that we get the feed from the camera. Then on the GPU server that we have, we run the AI object detection system, and all these data are sent to the control room, which is the web GUI. The current status of the project is we have an end-to-end solution running in six locations that are basically monitoring six different forests. We have built up a data set. We have scraped 8,000 images. We have created 10,000 of them through virtual reality or synthetic smoke. Basically, we have an 18,000 data set with annotations. The current model that we use is the YOLO version 8, and we have tested a lot of TensorFlow models, such as the CenterNet, the SSD MobileNet, and the faster RCNN. The MLOps lifecycle that we use is first we collect the data. We use also the data from the cameras that we take in order to train for false positives. Then we have to annotate the images, train the models. The best trained model goes to the AI app for model deployment, and then we run the inference on the AI app. All the data are transferred through MQTT and the events and also the images. That is a glimpse of the web GUI. Basically, we have the map with the location of each camera that we have deployed, some information about the camera, the location, it has coordinates, and the gallery, which is the past events. And on the red color is NASA's thermal satellites images that show which locations are considered hot zones. These are some detections that the AI app has made. Basically, this is through detections. There were fires that break down at the forest, and the AI model captured them. So these are the true positives. And we have some false positives. Basically, these are these are low clouds or fog that is captured as smoke, but it's not. This is the false positives, basically, which are very similar. Everyone can misjudge them as smoke, let's say, but it is not. And this is the true hard part, to minimize the false positives in cases like that. So basically, the KPIs of the project is to achieve a confidence score above 60%. The inference time, the inference time is the time to detect is below 100 milliseconds per frame. The time to detect fire is the time from the first visibility of smoke until the time that we detect it is above 10 seconds. We have to achieve less than 8 false positives per camera per week. The time to alert is the time that it takes from the moment that the smoke is visible until the time we alert the first responders. So this time is below 60 seconds. Achieve above 90% verified successful alerts, basically cases that we know that it is smoke in the forest. We have to capture them, and the two energy-related KPIs, which is more than 30 watts of reduction when we have lower FPS, and deploy more than one models in each GPU. Some future work to basically to minimize false positives, we have we are building of an algorithm that basically detects the smoke movement in order to see if it is a moving smoke or a low cloud that's going very slowly. Also, we need to find the exact geolocation of the event. Basically, we have the coordinates of the camera, but we need to find the location of the events, the exact coordinates. And the fire evolution analysis to find where the smoke speed and spread will go along with the wind. That's all from me. Thank you very much.
Thank you very much, Dimitris. It was an excellent presentation, an excellent example how AI and developments in networking, in 5G and beyond, can be used to deal with aspects that are brought with climate change and can contribute to environmental sustainability. With this, I would like to welcome Mr. Jason Diakomakos to provide a presentation on the envelope approach, focusing on enabling network-aware, coordinated, augmented mobility services in the case of beyond 5G systems.
Thank you, Anna. Yes, sir. Nice to see you all. Thanks for being here. And thanks also for the organization. It's a really interesting event. And we are certainly getting a lot of knowledge. So, should I have... okay, it's here. Perfect. So, I'm Jason Diakomakos. I am part of the OTE group in the R&D research, and I'm going to present you the envelope. Here, we are a party of 23 partners across multiple countries, and we have a total budget of 16, let's say, million. In our project, we are trying to focus on vehicular safety via various of events, including communication between the vehicles, people, and communication with the backend network, the core network where we are connected to. So let's imagine our use case scenario where a car in front is always connected and asking for related network metrics, either from the device itself or through the core network. And in a case of emergency, in our use case, we have a break due maybe to an animal appearing. We need to send this information back to our local traffic center, which will later transmit it to a car that is back of us, in order to alert him that something is wrong, and the driver needs to stop, take care of everything that's happening, and it is able to watch the WebRTC stream through the camera of the front car. Maybe it's a big truck, so with this, the back driver is able to see what's happening. Continuously, during all of these events, the camera is open for us to see what's going on, either from the back car or from the local traffic center, giving us a high-level overview of the situation in our localization status. And we are currently asking the backend APIs to provide us about information, about quality of service or other related information. Here is the overall architecture, where we have currently two domains, our OTE and Demokritos. We have set the Iris cluster that hosts the MQTT server used to transmit messages and exchange information, and the network invoker, which asks the APIs of the network in order to receive quality on demand or quality of service status. And all of this is integrated with a real OBU unit that also sends relevant information, and an Android application that has all of this information displayed to the user. So about the network invoker, we have three main components. The location library, so all the time we can ask about the network and take information regarding where our OBU unit or the CAM Android is. So this is originated from the network itself. The PQS library that has the AI integrated in order to transmit information regarding the future status of our quality of service, so that we know in case of emergency that we need to ask for a better quality. And here comes the quality on demand library. Then all of this, as I said before, is transmitted via the MQTT. So the topic is dynamically created based on the location of the car. So this is a quad tree creating dynamically every time the car moves, and by that each car knows what his neighbors are. All of these are transferred also through the CITS messages produced by the OBU unit, and we have integrated them in our architecture to understand the different kind of messages. Everything is shared through 5G, including the heartbeat messages and the informational topics, either from the OBU itself, the CAM application, or from the backend server. Everything is displayed on the user in the CAM application. Then, as I said, we have thus the front layer, which is the Android application itself, providing all the information. If needed, the user is able to view the camera from the front car and understand what's going on. Then the traffic control web GUI is accessible for the administrators and related users that can see and monitor all what's happening. This is our trial site, which is, as I said, is between OTE and Demokritos. We have set 2 G-Node Bs, and we are trying to achieve a better speeds and handover during the continuum between the two trial sites. So the KPIs measured are 2. The first one is the inter-PLMN service disruption. We need to have a very low metrics on that because we need it to be fast. NT1 is the time needed from the first PLMN closure to establishing the second, and this has to be actually 0. But what we are actually trying to measure is how often do we have more than 0, which means that maybe we're losing some important messages. The second one is regarding the end-to-end metrics, how much time is needed for each message when it's produced via the OBU to reach the back driver so that he's informed. This should be less than 1 second. We have achieved even less time, but this is a good metric because we needed to be fast for a driver to act when an emergency happened. And all of these are measured by the CAM application in the Android level. So what's the impact on that? We are trying to create a more safe environment for everyone because right now it's very important for, since we have more automated vehicles, everyone to be careful and try to avoid incidences. Then we need to raise the awareness between the network and the end users, either through Android applications or through the OBU. Of course, the interoperability, where we have Camara-compliant applications in order to receive quality of service, quality of demand, and of course to have a scalable system able to be used in actual world. Our future work is to extend our KPIs and measure the quality of service, try to create better slicing on the end network. Of course, we have to multi-test it under different scenarios and with various other providers. Increase our AI ML algorithm stability and confidence in order to provide to the users a better quality of service predictions. And of course, extend our envelope architecture to non-terrestrial networks. So that's all from me. Thank you for your time. If you have any questions, feel free to ask.
very much, Jason, for your excellent presentation also. And it was a nice example of how transportation infrastructure can be integrated with network capabilities and deliver really useful applications for the future. And with this, we will link also to the next presentation, which is also about the integration of transportation and logistics and networking capabilities. And with this, I give the floor to Vasilis Papataxiarchis, a researcher of the National Kapodistrian University of Athens, to talk about the vision of TRACE project.
Thank you, Ioanna. Good afternoon, everyone. I'm Vasilis Papataxiarchis. I'm a researcher at the Department of Information and Telecommunications, Informatics and Telecommunications in the National Kapodistrian University of Athens, and I'm going to present the TRACE project. So TRACE overall is about integration and harmonization of logistics operations. So we're a big consortium consisting of a big amount of partners, including SMEs, research institutes and universities, logistic operations, and also industrial partners that come from 11 EU countries, including, among others, Greece, Luxembourg, Spain, Austria, Estonia, and many others. So these are the logos of those partners. We are an almost 10 million euro project, and it lasts for 3 years. We are currently entered the third and last year of the project. It is coordinated by Professor Stathis Hadjefimiadis from NKUA, and it is an innovation action, meaning that we're trying to, let's say, take it to the next level in terms of commercial exploitation of those services that are developed in the context of this project. Okay, just a few words about what is currently taking place. Let's say a few words about the trends in this domain. That includes the adoption of and the development of intelligent services for increasing the performance of intelligent transportation systems. This includes synchromodal operations in order to reduce the CO2 emissions, the carbon footprint, and also to secure the deliveries, the uninterrupted deliveries of the shipments. So behind TRACE, there are different types of drivers. First of all, it is about the optimization of synchromodal operations. This includes the unstable price of fuel, the rise in road infrastructure costs, the increasing complexity of the supply chain, and also the increased environment conscious and public awareness. So this leads us to the challenges that TRACE project is trying to address for the adoption of shared logistics, including, first of all, building of trust among the stakeholders, monitoring and forecasting, and also the connectivity in order to secure the data sharing among the different stakeholders. Finally, there are several barriers that need to be overcome, including operational issues, organizational issues, trust issues among the stakeholders, lack of novel business models, if we're talking about novel business models in terms of, things like robot as a service, and also lack of legal and governance framework. So what is TRACE about? TRACE designs and implements a smart, new integrated platform that enables stakeholders to optimize logistic operations. So this, we're taking into account things like, of course, costs, CO2 emissions, time, estimated time of deliveries, and also fuel consumption. So we're trying to combine different parameters, different factors in order to optimize the overall performance of intelligent transportation systems. Apart from that, Trace also tackles the interoperability problem of logistic operations, since the project tries to connect with the different back-end services of the logistics companies. So this is the, let's say, the operational view of the overall of Trace. At the bottom of this layer, you see the different parts of the delivery of shipments, of goods. We have the project tries to optimize all the 3 different layers, including the first mile, mid-mile, and also last mile deliveries. How this is done, we have built several intelligent services that are used by operators, including optimized rescheduling, data analytics and knowledge, resource management, and traceability of the goods. And all this is supported and facilitated by in-network processing and also efficient telecommunication mechanisms in order to connect the different layers of the continuum. So what are the main innovations of Trace? We harmonize, we integrate, and we orchestrate the different logistic operations. So we speak many different languages that come from the logistic companies. We design an intelligent platform to combine open and shared logistics. We use AI in order to support synchromodal services, and we also implement the required infrastructure for the dynamic data flows. Also, we perform a study on barriers and opportunities that needs to be tackled. Also, a study about novel business models and how this can fit well in the new market conditions. We study the governance of logistic networks, and we also perform the necessary outreach activities in order to raise awareness and increase visibility of the platform. 2 main objectives we believe that we will manage to reach at the end of the project. First, to provide an integrated solution to support synchromodal logistics operations, and second, to take advantage of innovative AI-driven practices, including, among others, blockchain technology, in order to set up the basis for a higher level of trust, security, and automation among the different layers of the platform. This is a conceptual view of the layered architecture. At the bottom, you see the physical infrastructure of resources. Then we have the edge infrastructure, and then we have the cloud infrastructure. We cover all the 3 layers, starting from in-vehicles, from services that run on board the vehicles, including unmanned vehicles. Then we also have operations running at the edge of the network, including blockchain, communication management, and orchestration of resources. And then at the cloud, we have a set of back-end services, including stream processing, harmonization, data harmonization, blockchain, optimization modules, scheduling, smart contracts, and also virtual reality module. We have 3 demonstrations. The 2 of them have already been performed, one in Greece, one in Italy, and the last one in Slovenia. So in those demonstrators, we try to integrate different logistic networks that interact and collaborate with each other in order to fulfill specific goals and run specific scenarios that have been specified by the stakeholders. And a few words about the expected outcomes. First of all, we want to facilitate freight transport and make sure that logistic companies, including SMEs, will be able to evolve, to operate seamlessly, engaging with partners across Europe, across EU, in order to achieve a better utilization of resources. This includes transportation means, but also human resources. And then also energy, reduction of energy consumption and emissions. We plan to achieve this by a number of higher than 20% based on the operative gains. And the overall wider impact of the project, we want to, at the end of the day, to, let's say, upgrade physical and digital infrastructure to achieve a green, accessible and affordable, connected and automated multimodal mobility. We want to increase efficiency, improve interconnectivity and smart enforcement, reduce external costs, whatever this means in terms of urban, peri-urban and long-distance freight transport, but also enhance local and regional capacity for governments and innovation in urban mobility and logistics. Thank you very much for your presence here. It was a pleasure.
Very much, Vasilis. It was an excellent also presentation and gives the vision of logistics and how networks can really be an integral part of logistics in the future. However, given the fact that we discuss about critical infrastructure, we cannot overlook the aspect of security. And with this, I would like to welcome Professor Anna Giannakaki, who will give an overview of security architecture of the 5G tactic project. For 5G networks and beyond.
Hi, hello. Thank you, Anna. Thank you very much for the introduction. It's a pleasure to be here tonight, and many thanks for the invitation. Indeed, I will try to give an overall view of some activities we have in the context of 5G security and architectural considerations in the context of the European project 5G Tactic. 5G Tactic is a DEP project. The acronym stands for 5G Trusted and Secure Network Services, and the main goal is to develop a 5G cybersecurity toolbox that pilots 5G solutions that take security considerations. And we're also planning and delivering training activities for European regulators and cybersecurity authorities. The project duration is 3 years, and we're now finishing the second year of the project. The budget is approximately of the order of 2.6 million, and the consortium involves 15 partners from 7 European countries. And the interesting aspect of this consortium has to do with the composition. So it involves regulators, security agencies, operators, SME, and academia, slightly different to what we're used to in the context of European projects. So here you see the collection of the various logos and the distribution across Europe. What I would like to say before I move on is that there is significant Greek presence, given that the event is happening here in Athens. So apart from us, Institute of Accelerating System of Application, a research institute of the University, National Kapodisian University of Athens, who are also the project and technical coordinators of the project, we have the participation of the Greek regulator, ET, and also, of course, the participation of OTE. There are several other organizations from different parts of Europe. Okay. Now, the key objectives of the project are summarized in this slide, so I'm making an attempt here to summarize the objectives. The first objective has to do with the creation and support of a competitive 5G European ecosystem, which brings together, as I already mentioned, national regulation and cybersecurity authorities. And in fact, in our consortium, we're happy to have regulators and cybersecurity authorities from 4 different member states. We have a number of technology SMEs developing open 5G solutions from European countries like France, Belgium, infrastructure providers and mobile network operators, of course, like OTE and Orange Romania, and a number of academic partners, research institutes and universities. From a technical viewpoint, we are concentrating on developing secure, open, disaggregated and interoperable 5G solutions. Adopting artificial intelligence in order to be able to optimize testing and the operation of the 5G infrastructure. We also put together this kind of solutions in the form, we're integrating these solutions in the form of pilots, and we are working on their evaluation in a multi-vendor open 5G solution environment. with the focus on security. And then, of course, as I already mentioned, we're looking into delivering training that is, from one perspective, technical, and so it addresses technical and security audiences, but also targets non-technical audience, like, for example, the regulators and the cybersecurity authorities that we have on board. So the technology challenges we deal with are inherent in 5G and Open RAN solution. We have to deal with billions of end devices. It's a multi-cloud or heterogeneous cloud environment involving millions of subnets, challenges associated with open interfaces and disaggregation. Of course, a multi-vendor environment is in the heart of what we are concentrating on, and with AI being native operation supported in this environment. Okay, Joanna already introduced the talk, focuses on security. So in this context, we concentrate on the number of threats. We have to deal with a system that suffers with an increased attack surface across all domains involved. We have to deal with risk associated with aspects of scalability of authentication. We have to deal with physical threats. We have a physical network, a 5G network, which is highly vulnerable to physical tampering of nodes. We have to deal with MEC solutions where we have lightweight devices that may be more easy to compromise, IoT systems that are susceptible to resource exhaustion, insecure communication, physical intrusion. And then, of course, it's a heterogeneous edge central cloud infrastructure that suffers interoperability challenges for security mechanism because we have to deal with the lack of standardization in that field. Okay, the aspect of user interfaces is very important. We have limited user interfaces in a number of end devices that, of course, affect the threat awareness and response. We have the issue of the lack of standardized protocols with security consideration in 5G, supporting the strict requirements of low latency, high-speed communications. We have to address issues associated with the fact that it's a cloud-native environment with supporting containerization, so containers may run on compromised hosts or dishonestly consume significant resources. The issue of open interfaces, of course, is a big enabler, but from a security, as far as functionality goes, but from a security perspective, is a real threat, is a real issue. The open interfaces promoted by ORAN, for example, expand the attack surface and expose the system to third-party code. So that's another vulnerability issue here. And then the aspect of multi-vendor interoperability is something positive, again, from an operator perspective, but it brings threats. So multi-vendors and service providers can lead to inconsistent security implementation. And of course, they cannot guarantee a common level of security across vendors, across operators. And of course, AI is a powerful tool that, of course, we're looking into bringing in the context of 5G and more so in 6G, and that brings a powerful attack space. So we have to deal with adversarial attacks, that will exploit vulnerabilities of AI algorithms that can have a big impact in terms of the attack surface in the 5G, 6G environment. Okay, I think my animation here has to be jumped very fast. Okay. So the architectural approach we take in 5G tactic is what is known as zero trust network approach that we apply in the 5G context. So the architectural approach we take from the 5G perspective is the one that you're more or less familiar with. So we have our user equipment, we have our radio access network, a user plane function which allows connectivity with the 5G core and the external work, then of course the capability of adopting edge compute processing as and when needed. And over this infrastructure, we're able to form slices to support different services like eMBB, ultra-reliable low-latency communications, massive machine-type communications, the known services that 5G supports. The approach we take is that a threat, an attack is inevitable. We cannot prevent the probability of having an attack, so a breach is inevitable, or it may even has already occurred, and what we have to do is to deal with it. How do we deal with it? We constantly limit access to only what is needed, and we keep looking for anomalous, malicious activities everywhere. This can be supported over the infrastructure I described before by applying what we call local cybersecurity loops. So we have this local loop per element, which enables, we call prepare, prevent, respond, and recover. And this is supported across each one of the elements I mentioned before. So across the user equipment, the radio access network, the user plane function, our edge compute elements, the 5G core, and across the service slices. We have provided a presentation, a plenary presentation at EUCNC last year with a lot more information on this, and the material is available online, so whoever is interested, you can have a look at this. Now, looking into the details of what we do in 5G Tactic, beyond taking this generic approach, on top of this, we've developed what we call a cyber threat intelligence platform, which gives extra capabilities. So it gives the ability to support analytics, to create vulnerability repositories, to give vulnerability scorings. And we are able to, if you like, analyze and identify issues with the underlying infrastructure. I'm not doing very well with time. This is... I'm sorry about this. I'll jump very fast. So we give these extra capabilities in support of the security services of the underlying infrastructure, and we have a cybersecurity orchestrator that enables us to provision secure services across the infrastructure. Now, some examples of the zero trust networking applied in the various elements of the infrastructure are listed here. I appreciate my time is very limited. So we apply zero trust networking in the Open RAN, and we're able to implement critical security control actions within the RAN through the cycle of prepare, prevent, respond, and recover. And we can apply, we can do monitoring, we can identify threats, and we can react to these threats through the control of the radio access network in a fast control loop form through the near real-time RIC, and the slower form through the SMO, the service management and orchestrator. Okay, we can also apply secure mechanisms in the transport network. So, for example, we can support front haul services over using MACsec protocol to make sure that we provide them as secure as we can. And this can be applied at different segments of the radio access network. Given the limited time, I'm not going to go into any detail. And then we can provide the secure services at the slice level. So we can set up different elements of the 5G infrastructure to support a certain slice. And then if we detect, so there we have the setup of a specific slice to support a set of services. And if we detect an attack, then we are able to reconfigure and use different resources in order to ensure that this service remain secure. There is different things we can do regarding supporting a secure design lifecycle. We create the concept of software bill of materials. So every building block is scanned against threats available in some kind of local repository or some external information, and this goes into the vulnerability repositories of the cyber threat security, cyber threat intelligence platform I mentioned before. Sorry, I'm going to jump very fast through this. And then another important aspect is to share security-related information, so we can use this cyber threat intelligence platform to share information even across operators if needed. But of course, this has to happen in a secure way, so we take advantage of the concept of secure edge proxy to establish this kind of communication. I think that summarizes pretty much everything I wanted to talk to you about. And before I close, I would like to say that we start a new project this December, extending the previous work on 5G Tactic. Of course, OTE is involved in this, is CTIS for NIS. This is an acronym standing for Cyber Threat Information Sharing, Enabling Network and Information System Security in the EU. Okay, thank you. Thank you very much for your attention.
Thank you very much, Anna, for your presentation, and not only for your presentation, for all your work, since you are technical and project manager of both projects, and this work has really finite detail in terms of security architecture. And this is the work of NKUA in principle. Thank you very much. And with this, we come to the final presentation by Dr. Konstantinos Philis, again, R&D researcher from OTE, who will talk about, again, a newly started project, which is Nexasphere, and will deliver a presentation on the project vision on AI-powered 6G network of networks.
Thank you, Jan. So this presentation has to do with Nexasphere's AI-powered 6G network of networks. Nexasphere is a European project with EU contribution of 8 million euros. The coordinator is Safran Passenger Innovations from Germany. The consortium consists of 18 partners from 9 countries, and the duration is 36 months with starting point the 1st of January of 2025. The vision of Nexasphere is to create a sustainable, unified, terrestrial, non-terrestrial network, multi-connected with 3D network of networks, including spaceborne and airborne platforms and terrestrial infrastructure. The purpose is to extend edge cloud continuum and utilize the artificial intelligence resource management, and the focus is on mobile transportation, smart cities, and communities beyond 2030. The key objectives include conceptualize and development of advanced hardware prototypes and software algorithms, the integration of radio and wireless optical technologies, the extent of the edge cloud continuum into space, creating a radio and wireless optical connectivity, and the demonstration using proof of concepts for this terrestrial and non-terrestrial unified network. The key innovations of the project include on-board satellite platform operating free space optical and radio frequency links, distributed radio base stations implementation in space segments, energy efficient wireless optics, high efficiency non-terrestrial network antenna for mobility, artificial intelligence and machine language driven joint resource and mobility management, multi-connectivity in unified terrestrial and non-terrestrial networks, and unified TN and NTN edge cloud continuum and orchestration. The use case, integration, validation, and demonstration of Nexasphere is separated into 3 categories: aviation, automotive, and railways. In the aviation sector, we try to show seamless in-flight NTN connectivity for civilian aircraft. In the automotive section, we are dealing with healing data, boarding, hoarding disorder for connected vehicles with AI-based data distillation. And in the railway section, we try to explore the train-on-board integration of NTN for improved connectivity, reliability, safety, and operation. The role of OTE in this project will be in offering of its 5G NSA and SA testbeds with satellite backhauling, enabling coverage provisioning anywhere in the world for demos execution. OTE will also contribute to a wide range of project activities, including the definition of use cases, system requirements and architectural design, development of multi-connectivity solutions, provisioning of traffic statistics, integration, testing and validation, and dissemination, exploitation, and liaison activities. That's all about Nexasphere. Thank you very much for your attention.
Thank you very much, Kostas, for concluding this.
And
with,
I believe we are exactly on
time, exactly.
Which is unbelievable.
Yes, better than expected. Maybe the key issue is to put you as the last speaker. Because I remember, once again, you were before the last, we were according to the schedule. Okay. Okay, first of all, I would like to express my thanks to Mrs. Ioanna Mesogiti for coordinating this session, the final one, and for the proper handling of the program. It appears that we managed this year as well to finalize our long road towards our discussion about how AI can be a driver for a variety of applications in the combined... Yes, it's the time, unfortunately. I was saying that we reached to the end of this long journey today, discussing opportunities rising from AI combined with 5G, beyond 5G, 6G. I don't know where, maybe no battery. Okay, I was saying that for once again we managed to finalize today's long journey in our discussion about investigating options for including AI in the modern combined framework of innovative solutions originally coming from beyond 5G towards 6G, as well as other potential technologies that practically transform the market. First of all, now, when I'm finalizing, I would like to express my thanks to all of you who joined either physically or virtually, to the speakers. Thanks to them, I think that we managed having a high level of presentations. Some were more technical, it is evident. Some others were oriented to market issues. Some others may have included issues like the KVIs that are not traditionally linked to what we know as actions in telecoms or ICT, but it is a transition towards something new. Some others presented results from trials. It depends on the maturity of all projects we try to touch in our workshop today. So many thanks to all speakers, to the supporters, to my colleagues. I mentioned Ioanna, I see Kostas, previously it was Maria Belesiotti, Michalis Randopoulos, I see Jason Diakoumakos, George Papas, Simos Chimenopoulos, Dimitris Salmatanis, Dimitris Diakakis, also my colleague Alexandros Kostopoulos, who supported the action. And I also want to express my profound thanks to all of you. The aim was just to give some initiatives, just to try to touch some areas and inform the public about what we are doing in the framework of the EU-funded R&D, which I repeat once again, it's not something theoretical, it's very, 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 very close to the market. And the aim is always to identify and investigate opportunities for supporting real market needs and for creating potential for growth in the market and in the economy as a whole, in parallel with the improvement of our everyday life. So by summarizing, we had a very general introduction where I tried to give the framework, the layout. Then we had a session based on the ecstatic project where we identified opportunities for using existing fiber optic infrastructure as a measure, as a means of sensing the network and using this for various phenomena like earthquakes, like tsunamis, like environmental options, also for checking man-made constructions like bridges or tunnels where we have deployed fiber, a new option, which is very, very close to 6G era, proving that there are no frontiers between fiber and wireless communications as they both serve the best. Then we passed to another chapter. We touched the area of Sunrise 6G project, which is about the federation of public and non-public networks with the involvement of a lot of partners from all around Europe, giving information about the intended use cases, the option of including AI in our activities, and in particular the metaverse, the use of robotics in mining, all these innovations that will transform our way of living and our perception about the future. And then we changed somehow direction and we focused upon the area of the Flecon 6G project, another one which promotes the option of artificial intelligence, of native artificial intelligence. This is a new project. We expect that this will give feedback and results, especially for the support of standardization activities. Then we changed again the direction because nothing can be done without having data, and we discussed about the options of the DataMite project, a very different one, which investigates opportunities for creating value for data and for serving a vast majority of vertical sectors all around Europe, all around the globe. And then we passed again to another area. We discussed about the 6G BRICS project, an innovative effort for creating an environment mainly for including RIS applications in various scenarios. We have seen for this project the ongoing use cases, results, because this is a project which gradually reaches to its end by next June. Then we have seen another option implicated by the ambitious European project, which was about creating an interactive continuum between AI, edge computing, applications in verticals. We have identified several potential options for improving our everyday life, some security applications in cooperation with the municipality of Egaleo, some other applications in agriculture, in marines. So we have since options in IoT-oriented world where AI may be included and may give potential benefits. The next stop was about discussion relevant to cybersecurity. We extensively referred to the Cyber NEMO project, which is the second phase of the previous NEMO project, a very innovative approach where actually there is involvement of many actors. We have numerous test beds and use cases, and the core option here is security in the cyber environment with potential, let's say, influences coming from the inclusion of AI. Then we refer to the 6G Path project, where I have the honor to be the coordinator. It was not possible to cover all use cases, so this time we focused on the joint OTs and ACTA use case, which was about automated logistics, and we tried to present the framework for that, the innovation for the transport and logistics services and sector via the inclusion of 5G and beyond in cooperation with AI, and we explained the level of maturity of our use case, and we also touched another application about smart water management for agricultural issues, where personally I tried also to correlate this with the common European policies, because as I mentioned in several instances, our work is not isolated from the European policies. Our work in R&D is the application, is the effort to implement something that may be characterized as pure theory, because it is policy of the European Union or national policy, but this is the initiative that funds R&D and expects feedback. So it's not isolated from policy requirements, from needs that, at least at the level of the European Union, expect to improve and our living standards and provide new opportunities for growth for the society, the economy as a whole. The next stop was about the 6G DALI project, a new project aiming to focus on ML operations, aiming to create for the first time a joint cluster of experts coming from various sections, from standardization, from the market, from big operators, from companies, about creating adequate data sets that can be used for applications related to AI in the telecom sector, because there are other data spaces, like, for example, GAIA-X, that give this opportunity, but for areas like constructions or economic issues, but there is something like this covering the telecom sector. So the aim was to deal with that. And then, apologies if I missed something, we had two final sessions. One session with my colleagues from the IT department focused on several cybersecurity issues combined with AI. There was reference to some ongoing projects like the 3D, the SEC Awareness Trust, the 3D Circular, Deploy AI, if I remember correctly, and another one. And finally, we had a very, very interesting joint session, which practically is the meaning last but not least, with several projects, mainly coming from my colleagues, like the 6G Verse, like 5G Tactic, like Envelope, like Nexus, I don't remember, Costas, exactly. Yes, all these have given the flavors about how to consider implicitly or explicitly the inclusion of AI in some modern applications, not only about networking, but also for services, also for combined beneficial uses. After this effort, I'm quite happy, because I feel that all these presentations normally will be uploaded, will give a basis, at least for those who want to check and try to have a starting point, just to see that there are some ongoing projects. The project is there, the website of the project is there, somebody may check it, may access the information, see what is going on. I'm quite happy for that. I expect that this will give a lot of options, informative options to everyone who wants to look and find something new or even investigate opportunities for collaboration, try to reach some consortia and many other options. Now it is time to close. Thank you again. Thank you for your patience. I apologize if, once again, for some among the speakers or among the technical team, because of the pressure, I was more, let's say, strict than expected. Maybe I still have memories from the time I served as an officer in the Greek army, but there it was that or not that. There was no middle solution. And I feel that this is also a priority for every manager. It is the aim or not the aim, no intermediate solution. Thank you again, all. I hope next time you will be here, either virtually or via physical presence. And this is a promise. Next time we will try to be more interactive, try to give the stage to more, let's say, participants, because this year we had to include 52, finally it was 51 presentations in a strict project. That's all by myself. Apologies if I missed something. Apologies if I made somebody unhappy. But from the pure professional point of view, thanks to you, either as speakers or as participants, I'm quite happy, thanks to you, for the final outcome of this workshop. Hope to see you again next year. Thank you.